take your seats for the beginning of this ECHA workshop on new approach methodologies. Thank you. My name is David Cliff. I'm the head of communications here at ECHA, and I'm just going to run you through some of the housekeeping rules for today. I'd also like to welcome our online audience. Their questions via Slido throughout the course of the day. So, very important security here. You have to have your badge at all times. Please return it at the end of the day. Any documents for reimbursement, very important. Please, by 4 o'clock, have those submitted to our staff. And for the lunch and coffee breaks, they will be served at the ECHA restaurant, which is just out here to the left of the conference centre. Food or drinks are not allowed in the meeting rooms, except for water. And there are smoking areas outside the conference building. In case of an evacuation, you can follow the emergency signs, the highlighted in green. Please exit in an orderly manner, and the meeting point is behind the buildings by the pretty impressive crane that still stands there. For your luggage storage, this again is out over to the left. So anything left in the public areas may be removed, and we would just like to ask you to keep the corridors and also the pathways in here clear of any luggage. And the luggage room is on the second floor. Personal use items is on the first floor next to the restaurant. Important probably for everybody here, the Wi-Fi and the password for today. So you can take a bit of time to get yourselves connected if not already done so. And printing, again, you can see the details here. We can print for any requests outside of the conference center. If you just go to our staff or go to any of the Canon printers. And the event will be streamed live today. So photographs and videos will be done for external communication purposes and internal communication purposes. If you don't wish to be in the pictures or the video, please say that to our cameraman as they approach you. With that, I would like to ask Dr. Sharon McGuinness, the Executive Director of ECHA, to take the floor for welcome and opening words.
Thank you, David, and good morning, everyone. I'm delighted to welcome you all here to Helsinki, those of you in the room and indeed those of you online. I think the numbers attending are really a very clear reflection of the importance and relevance of this topic for not just us who are here at the workshop, but I think the wider EU as well. As you know, the topic of replacement of animal testing is also very highly relevant in the context of current policy discussions on the chemical strategy for sustainability. It is also a topic, as I said, of increasing importance and relevance to the wider public, with some 1.2 million European citizens calling for an acceleration of the pace to replace animal tests. We in ECHA are taking action and are stepping up our efforts to contribute to the scientific debate while continuing to implement the regulatory frameworks adopted by the legislator. And this workshop is just one aspect of ECHA's commitment to promoting alternatives to animal tests and to supporting our colleagues in the Commission on the transition to an animal-free regulatory system. We believe NAMs have a real potential to perform both hazard and risk assessment more efficiently and with no or minimal reliance on animals. As someone whose regulatory career has mirrored the EU's interest in NAMs, I started in the European Chemicals Bureau when ECVAM also started, so I have a long parallel career to the work on animal testing reduction. I believe that if we truly want to move fully away from animal testing, and still ensure protection of human health and the environment, that we have to first start by aligning on what it is we have achieved and collectively determine what it is we want to achieve in the future. We don't believe the protection of health and the environment versus no animal testing is an either-or situation. We think we can do both. However, to get there, we all need to have open and transparent discussions on the limitations and challenges that limits what NAMs may bring, particularly in the context of a regulatory drivers and expectations, as this will allow us to have a shared and realistic view on what is achievable. We also need to think about how we might navigate uncertainty as we move to identifying hazard and assessing risk without the use of animals. It is ECHA's wish that this workshop will provide a good opportunity for this open and transparent discussion. We hope that in the discussions here over the next few days that we can collectively identify the critical needs that will enable the faster progress that we all wish for and that 1.2 million EU citizens also want. We in ECHA are ready to provide our competence, our experience and our commitment to support policymakers in developing a suitable, consistent approach for regulating chemicals based on an increased use of NAMs and with the eventual phase out of animal testing. Moving towards animal-free chemical testing requires shared commitment, collaboration and concerted efforts by us all. And as I mentioned, we hope that this workshop will be the start of a discussion and an example for us to how we can collectively collaborate to achieve this goal. Before concluding, I would like to take the opportunity to thank the members of the organising committee for helping us shape the agenda for this workshop. Katrin Schutte, European Commission, Gavin Maxwell, the industry co-chair for the European Partnership for Alternative Approaches to Animal Testing, the EPAA, Katia Lacasse, CEFIC, and Julia Baines and PETA, and all the speakers that have contributed to the organisation and the participation in this particular workshop. We look forward to hearing from our speakers and indeed our participants over the course of the next few days. And now all that remains for me to say is that I wish you all a fruitful and lively discussion, and thank you very much and enjoy the two-day discussions.
Thank you, Sharon, for those words. I'm just now going to introduce some videos by some speakers who unfortunately could not make it here today physically, but have provided us with their thoughts via video. The first video will be from Tilly Metz, member of the European Parliament for Luxembourg, member of the Greens European Free Alliance, and also sits on the Committee on the Environment, Public Health and Food Safety.
Good morning. When I received the invitation for this event, I was delighted. I am so happy to see ECHA and the EPAA getting to work together to concretely map out how a future without animal testing for chemicals could look like. We all know that there is an end goal for total replacement of animal testing, but in some fields we still struggle to concretely envision how to get there, or if it will even be possible one day. By organizing the workshop, New Approach Methodologies towards an animal-free regulatory system for industrial chemicals, ECHA is sending a strong signal. It is possible, and one day soon we can get there, if we put in place the right regulatory framework and support. And I am very grateful for this signal, and of course, fully encourage any future ECHA undertakings on the topics of new approach methodologies. As you all know, the European Parliament called for a renewed and clear commitment to the ultimate phase out of the use of animals for scientific purpose. We asked for an EU-wide action plan which defines steps on how to go there. While we are still waiting for an overreaching plan, I am very happy to see that such an important actor as ECHA is getting so active on this subject, because there are unfortunately still a lot of mixed messages, confusion and fears regarding the EU chemicals legislation and the upcoming revision. Last year, for example, the Commission introduced questions in a public consultation survey on the revision of the REACH regulation, the main EU law on chemicals, implying that new approach methodologies, so-called NAMs, would weaken health and environment protection from chemical hazards and hamper the competitiveness of the EU industry. Animal welfare organizations, but also NAM pioneers, were surprised and worried. Will there be more animal tests in the future instead of less? Are we questioning the validity of NAMs more than before? Is the end goal of total replacement moving into unreachable distances far into the future? And also important, will any of this lead to actually safe products and a toxic-free environment? Because of course, when it comes to regulatory testing, I always want to repeat, we all want safe products and high environmental protection. So the goal is not to have less testing, research or production. We want a different testing, more human relevant results and equal levels of safety, but without the use of animals. NAMs hold a lot of potential to help us achieve the ambitious goals of the European Chemical Strategy for Sustainability. NAMs have numerous benefits. First, ethical benefits. The phasing out of animal testing is a progressive step towards a more compassionate society. Secondly, economic benefits. Alternative methods are often faster and more cost-effective than animal experience, making it an attractive option also for companies. And lastly, scientific benefits alternatives can be more accurate and reliable than animal testing. As I always say, we are not 80-kilo rats. I believe when it comes to regulatory testing for chemicals, a dynamic approach is required in order to increase the accessibility and use of innovative non-animal testing strategy. A positive development worth mentioning, in 2022 the Commission updated the list of accepted testing methods under REACH to include new alternatives and to kick some animal-based methods off the list. So there is quite some progress. Let's continue on this path. I wouldn't be chair of the European Parliament's Intergroup on Animal Welfare if I didn't at least mention the ECI Safe Cruelty-Free Cosmetics, which collected over 1.2 million validated signatures. This shows that EU citizens deeply care about this issue and that they consider current actions to phase out animal tests inadequate and insufficient. I know that the tests for cosmetics represent only a small percentage of all EU tests on animals, but to me it is not acceptable to question a clear ban because of inconsistencies between laws and slow validation processes and acceptance of alternatives. Let's clear up these inconsistencies and deliver on what the EU promised, be it for cosmetics ingredients or eventually all chemicals. The future of regulatory testing is animal-free. I wish you a successful workshop and fruitful discussion, and I will follow the outcome of the workshop with a lot of interest, and I'm looking forward to working with all of you in future.
Thank you there to MEP Metz for those introductory words. I'll now introduce a video from Kristin Schreiber, who's Director of Directorate Ecosystems 1 in the Directorate General for Internal Market, Industry, Environment, Entrepreneurship and SMEs, DG GROW.
Ladies and gentlemen, I'm very pleased to open the workshop towards an animal-free regulatory system for industrial chemicals on behalf of the European Commission. I wish I could be with you in Helsinki and could have made my intervention live. Unfortunately, my work schedule did not permit it, but I'm glad that my colleague Georg Streeck is with you in Helsinki. The EU has set 10 years ago a policy goal to ultimately phase out all animal testing for scientific purposes, including for regulating chemicals. This workshop aims at helping identify steps to reach this ambitious goal and accelerate moving towards animal-free regulatory systems. If the EU is clearly leading worldwide in this domain, I'm also aware that efforts still need to be made. The transition from animal testing to alternative methods can only proceed together with scientific progress, in a way that always ensures the protection of human health and the environment. This workshop is taking place at a particular time when the debate on the use of animals for testing of chemicals has gained a new momentum. The Commission is working on multiple activities to foster non-animal testing. In January, the Commission received the submission of the European Citizens' Initiative, Safe Cruelty-Free Cosmetics, Commit to a Europe Without Animal Testing, which collected more than 1.2 million signatures. This shows that citizens care about animal welfare. The Commission is now preparing its reply to the initiative in form of a communication, which will outline actions to reduce animal testing and phasing it out in the longer term. In general, we take into consideration any new valid methods that can replace animal procedures as soon as they become available. On this line, in March of this year, the Commission adopted some 100 new and updated test methods for regulatory safety testing of chemicals. Most of the newly approved tests are methods which do not involve animals. The importance the Commission puts on the issue of transitioning to non-animal methods is also evidenced by the funding it provides to research. Over the past 2 decades, the EU has provided more than €1 billion dedicated to support more than 300 projects to develop non-animal methods and strategies. So I can definitely assure you that we give a lot of attention to this topic, also on the validation of alternatives. The involvement of stakeholders in the transition to non-animal approaches is vital. In this context, I would like to highlight the fruitful collaboration with stakeholders through the European Partnership for Alternative Approaches to Animal Testing, which we call EPAA. DG GROW has co-chaired EPAA on behalf of the Commission since its creation. EPAA leverages the interaction among different stakeholders to promote cross-sectoral dialogue. EPAA brings together all relevant Commission services responsible for relevant sectoral legislation and research, and companies from different sectors, working with chemicals to promote replacement, refinement, and reduction of animal testing. EPAA has greatly contributed to this effort over the years, organizing different activities. And let me flag that the EPAA annual conference will take place in November at the Commission premises in Brussels. As you all know, we are also working on the targeted revision of REACH. The revision, which is still in progress, is likely to increase the need for animal testing, despite our utmost efforts to include new non-animal approaches wherever possible. The reason for that is that we also aim to increase the available hazard information, for instance on substances with endocrine disrupting properties. But switching to regulating using non-animal methods goes beyond REACH and CLP, the regulation on classification labeling of chemicals. It will also require to bring together all scientific experts. I'm therefore happy to see scientific experts from EFSA speaking at this workshop. I also recognize the strong presence of the experts from the Joint Research Centre, including from the Reference Laboratory for Alternatives to Animal Testing, and the participation from experts from member states. Last but not least, I would like to thank ECHA for organizing this workshop. Once again, and before closing, I would like to underline the commitment of the Commission to transition to non-animal methods. We want to phase out animal testing as soon as scientific progress allows it. Let me close by a request to you. I hope that during this workshop, you can identify the major challenges and obstacles that you see on the road ahead towards the replacement of animal testing. And I'm looking forward to see the results of this workshop. Thank you.
So this will be as much of a surprise to me as to you. So what do new approach methodologies mean to you? I think, as we can see there, the majority of people seem to see this as an opportunity. Other areas, it's the future, it's a challenge, change of paradigm in toxicology, opportunity for regulations, challenge for capacity building. But I think, we can take from that, from the answers from both here within the building and the online audience, that people see this as an opportunity for the future in relation to animal testing and new approach methodologies. If we could move to the second question? I think it was technical issues there. Here we are. So what type of organization do you represent? So we have a large number of people in the building, and I imagine online from industry, national authorities, NGOs up there as well, and consultancies. I think it's fair to say it's quite a spread of the relevant stakeholders who are interested in this topic, and it's great to see so many people in the building here. It's one of our, I think it's only one of our second large gatherings in the building for externals since we moved here and after the pandemic, and also everyone online who's joining. There are several hundred, I believe. With that, little recap, I'd like to ask Mercedes Baines, our Director of Submissions and Interaction, to take the stand, and I'll hand over to her.
Thank you very much, David, and good morning, everyone. Very welcome to ECHA and to this workshop also from my side for all of you here. I must say it's quite energizing to see so many visitors. It's not very often that we have so many people here in ECHA and also online. In this first session, as you can see, we're going to start the workshop by setting the scene, mapping out what is the current status on the use of alternative methods in the regulatory landscape in Europe. And also I start identifying what are the needs so that we can move forward. I think looking at the speakers that we have, I'm sure we will have many different interesting angles to this question. And without further ado, I'm going to introduce the first speaker, which is Cristina de Avila. She's heading the Unit of Sustainable Chemicals in DG Environment in the European Commission. And I think, as many of you know, she's been a key figure in the drafting and now the implementation of the Chemical Strategy for Sustainability, being extremely active in the REACH and CLP regulations from many, many years already. So looking forward to hearing what you have to say, Cristina.
So good morning to all. First of all, I want to express how grateful I am to be here today with this huge audience here in the room, but also online, to talk about this very interesting topic of new approach methodologies, how to get there eventually to deliver for the regulatory scene. The title of my presentation, as you see, covers almost everything. So the current status, anticipated changes, long-term vision. I'm not going to start here giving you a big presentation about the REACH revision and the CLP revision. I have done this for already a lot of time. So if you're really interested in knowing more details, I'm sure you can find some online. But I'm going to try to focus basically on the topic of the discussion today, which is what do we have today in terms of regulation in Europe, how we go about regulating chemicals, what are the changes that we are envisioning now, but also what is the long-term vision for further changes that we may need in the future, in particular, to make a reality our aim of having an animal-free regulatory system in Europe. So, as you know, in the European Union, we have very extensive regulatory acquis on chemicals. So we have horizontal pieces of legislation, such as REACH and CLP. And we have also sectorial pieces of legislation that look at the specific uses. For example, we have legislation on plant protection products, or on biocides, on cosmetics, on toys, on food contact materials. Some of these sectorial legislation are associated also with protection of a given group of people. So it could be consumers, professionals, it could be children. And many of these pieces of legislation pursue aims additional to the protection of human health or the environment from chemicals risk. So they, for example, the Toy Safety Directive look at safety of toys from a very wide angle. So it's not only about chemical safety. Food contact materials legislation also aims to ensure food integrity. So it's not only about what chemical risks associated with these materials that are in contact with food. So it's a complex system. It's more than 40 pieces of legislation, and they are all intertwined or related. So I try to simplify in this slide the relationship between this piece of legislation, and you will see why I've tried to simplify it like this as we advance in the presentation. So some of these pieces of legislation provide information on chemicals. It's the case of REACH through the process of registration, but also evaluation. We obtain information about chemicals, about their intrinsic properties, about the uses, about the exposure. This happens also with other pieces of legislation. And I mentioned here pesticides and biocides, but we also know very well that there are other pieces of legislation that also look at chemicals, maybe from a different angle, that are providing a lot of information on these substances, as, for example, the pharma legislation. With that information, we, in particular, the ones on intrinsic properties, the information on intrinsic properties, we activate CLP, which is our means of identifying the hazards of chemicals and then classifying the substances, either by means of self-classification by industry or through harmonized classification. Today, and I put in the square brackets because hopefully this will disappear soon, there are other pieces of legislation that also identify hazards. It's the case, for example, of REACH, pesticides and biocides for endocrine disruption, or for persistence, bioaccumulation, and toxicity. These new hazard classes, these hazards have now been introduced in CLP as new hazard classes. So eventually, we have made CLP the repository of all hazard identification in Europe, and that was one of the aims that we had. And then once the hazards are identified, the risk management measures come in, sometimes by the hand of the same legislation that have already provided information, or maybe of others. And there is, as I said, in the case of REACH, of course, we have restrictions and authorizations, but also we have other sectorial legislation that introduces risk management measures in order to ensure that exposures from chemicals in the different products or activities do not create a risk. So as part of the implementation of the chemicals strategy for sustainability, we are revising many of these pieces of legislation, and I've highlighted in red some of those that are being revised or have been revised. CLP, as I said, has been revised to include the new hazard classes to identify endocrine disruption, also substances that are persistent, bioaccumulative, and toxic, or very persistent and very bioaccumulative, which in the past was the repository was rather rich, or substances that are persistent, mobile, and toxic, or very persistent and very mobile, the PMTs, so looking more into environmental protection. As I said, the objective was to make CLP the reference for all hazard identification and classification in the European Union, very much in line with the ambition that is set in the One Substance, One Assessment. Why we wanted to make CLP the reference? Because also in the way that the legislation interacts, it triggers, the classification under CLP triggers risk management measures. The other pieces of legislation that are establishing the managing the risks already have established triggers that depend on CLP. So it's important that we are very clear what is the streams that we are following here in order to address the risk associated with chemicals. REACH is also being revised. It's been revised to improve hazard identification by extending information requirements, so we can better classify the substances and we can do better risk assessment. In terms of information requirements, of course, we are looking into the identification of endocrine disruptors, this new hazard class under CLP. We also want to improve risk assessment, and we will require more and better information on uses and exposure of chemicals. And finally, we want to improve risk management by including a mystery allocation factor or by extending what we call generic approaches to risk management to the most harmful hazard classes and to certain professional uses, and of course by reforming the authorization system. Of course, this is an oversimplification of what we are doing, and it's just for the sake of focusing on what I consider is the most relevant aspects from a regulatory point of view for the discussions in this workshop. So both CLP and REACH, of course, have been revised for other elements. In the case of CLP, we are revising labeling requirements, online sales, bulk sales. And in case of REACH also, we are also looking into obtaining information on substances that have been either exempted from registration, which is the case of polymers, and also to improve enforcement. So there are other aspects of REACH and CLP that are being revised. In the case of the new hazard classes, as you will know, the revision is already in place, so it has been published. So what is the future for NAM-based information requirements? So when it comes to hazard identification, the data provided via REACH or via other piece of legislation on interesting properties needs to be usable or relevant in order to trigger or activate the classification criteria in CLP. In REACH is very present the commitment to use animal testing as a last resort. So the question emerges, can we classify substances under CLP without animal testing? We know that there are important limitations for the way that some of these criteria for some endpoints are being expressed, in particular those that require adversity. And this is the case, for example, of the new hazard classes introduced on endocrine disruption. But also there are other important limitations. One of them being the fact that CLP implements in the European Union the UN GHS, the Globally Harmonized System for Classification and Labeling of Chemicals. So we should not forget that we are not the only masters of CLP criteria, and there is an important global dimension here that has also ramifications into other areas, such as the mutual acceptance of data under the OECD. So there has been in one of the opening videos reference to how we are advancing in REACH on implementing new approach methodologies, and how we in the past have updated, for example, the existing tests based on animals and changing them for tests that are non-animal based. This is the case of eye irritation and serious eye damage and skin sensitization, skin irritation. We did these changes back in 2016, I think this is a very good example of where I want to go with my presentation. We did these changes in REACH. The tests were agreed, the test methods were agreed at OECD level. We committed to introduce them in REACH. We introduced them in REACH in 2016 and 2017. Only in 2021, 2022, JHS took them on board, so the criteria now can be based on non-animal methods. The Commission has yet to introduce this in CLP. So in effect, we could still, under the current CLP, not classify for these endpoints without animal testing. So this is a very good example of where we need to go, or how we need to get there to make non-animal based information requirements suitable and a reality in our regulatory environment. So some of the challenges that I've been thinking about for this workshop: we have invested in the European Commission hundreds of millions of euros in alternative methods over the last 2 decades, and very few, the example that I just gave is one of them, have come into regulatory use. So should we not prioritize the development of alternative methods that are relevant for regulatory use, and how can we speed this up? There are claims also coming from industry that we can already do chemical safety assessment based on NAMs, only for some chemical categories maybe. So what do we need to do to ensure that NAMs are used for classification? How can we create confidence on the information that is coming from NAMs that is different from what we're used to, and that for some people is difficult to make that leap of faith, or that change of mindset, and start having the confidence on these results? I'm told that these NAMs have the potential to identify hazardous properties for many more substances and in less time. So this is really interesting from a regulatory point of view. So from my point of view, I think that for that to happen, we need classification criteria that is adapted to NAM-based information, and we need information requirements that are adapted for the classification criteria. So we need to have also the reassurance that we can rely on that NAM-based information to identify the hazards and classify the substances under CLP. In terms of the long-term vision on chemicals regulation as set by the chemicals strategy, we have a number of important components. So we want to have better knowledge on chemicals for the ones that we have already some information, and that's some of the efforts that we are doing now under the REACH revision, but also for the many more that are still not under our radar. And we want to acquire this knowledge faster. We want to tackle the substances by groups, so both for hazard identification and for risk management. So we want to stop regulating substances one by one. Why? To achieve a higher level of protection of human health and environment, but also to avoid regrettable substitution. And if it's true that NAMs would allow to generate more information on more chemicals and do it faster, we then need to realize that these two objectives will be better achieved and more successfully achieved if we finish our reliance on animal testing. We also want to design better chemicals that are safe and sustainable by design. And again, Non-animal alternatives will allow us to predict better upfront the toxicity of the chemicals as we develop them, and will help drive decision-taking at the various stages of the innovation process, from the design, planning, experimental, and the prototyping. And the future is the reuse of data by authorities and across legislation. I see this is advocated by the One Substance, One Assessment ambition. And this would allow us to use better resources and reduce the burden for all actors. This means that eventually, in the long run, all chemicals-related legislation will need to get there, sooner or later. So this is not only about REACH and CLP. So what are our commitments? I'm here today in this workshop, only today. I'm not going to be here tomorrow, but I will try to follow online. And I'm here full of hope, looking forward to hearing what I'm sure will be a wealth of ideas on how to get there. My hope is that we'll be able to identify the necessary steps to get to the ultimate objective, to regulate chemicals without reliance on animal testing. And these steps may not be all long-term, maybe short-term, low-hanging fruit, medium-term, and then the end point. I think it's possible, and I think many people here in this room and online know it's possible. And but I also think, and this is very much coming from a regulator's point of view, is that we need to set up clear, concrete, achievable milestones. Setting ourselves a long-term goal without the milestones that will tell us that we are advancing in this road and that we are doing it in good progress will not be enough. And these milestones have to be designed for the regulatory context, so that the regulatory acquis, all our pieces of legislation, can evolve and stop relying on animal testing. From our side, from the environment point of view, we are committed to identifying and completing these critical milestones on the road to a NAM-based future. However, as I said before, this is for all chemicals legislation in Europe, and we will require collaboration and commitment from many more Commission services and agencies than just the environment. So I see in any event that we'll need to start somewhere. So why not start with REACH and CLP? I'm ready to do that. So let's roll up our sleeves and start getting the work done. And with that, I thank you very much for your attention. I'm looking forward to this workshop. Thank you very much.
Thank you very much, Cristina, for sharing not only the current status, but also already identifying some of the needs on how we could do to move forward, but also sharing your hopes for the future. Now we're going to listen to the ECHA's perspective, and I'm very happy to introduce my colleague, Ofelia Bercaru. She's the Director of Prioritization and Integration here in ECHA, overseeing all our selection and identification of substances for regulatory action, but also overseeing ECHA's work on alternative methods. I think if you have seen that ECHA has stepped up our efforts in this area, I think Ofelia and the team in Thiago's unit, many of whom you will meet later in the workshop, and also many colleagues across ECHA are behind that. So, Ofelia, all yours.
Good morning, everyone in the room and online, and warm welcome also from my side. It's really nice to see so much interest generated by this workshop, and I think one of the main objectives for this workshop, it's also to start understanding each other better. I think progress could be achieved by understanding that we all want to move in the same direction, but we all have different perspectives. And by talking more to each other, we can better align the different perspectives and make faster progress. My presentation, it's in a way reiterating some of the issues that Cristina already mentioned. No wonder about that, as we work on REACH and CLP quite a lot, but also bringing a few other elements from ECHA perspective. So besides the regulatory framework, also the findings, recent findings from the report on alternatives that we just published yesterday. And also some activities that ECHA has been doing over the past decade for promoting the use of alternatives, and also how we step up our efforts. This slide is in a way similar to what Cristina presented. It's showing the regulatory landscape for industrial chemicals and beyond in Europe. And as you can see, the REACH and then the CLP are the basis. They are at the starting point for regulating chemicals. REACH has been designed to generate information that would allow identification of the hazard, classification, and then enabling horizontal risk management to a large extent. And as you already heard, CLP is also the implementation of the GHS system in Europe. Besides that, we have a number of other frameworks that regulate chemicals at the product level and also ensure the protection of workers and the environment. Besides REACH, we also have pesticides, biocides, and pharmaceuticals for generating data. Pesticides and biocides maybe at a smaller scale. Pharmaceuticals are in a way separated from the area of industrial chemicals, also in terms of how they deal with the effects, as the purpose is different. And besides, there are quite a large number of players in this arena, different agencies, different services in the Commission, and of course different bodies at national level that we all work together, and we try to ensure consistency to a large extent of the work that we are doing. But when we think about REACH, maybe a very brief recap where we started from and then how we move forward. When REACH was put in place in 2007, after many years of discussions and negotiations, it had, and I think the principles remain very valid today as they were in the beginning. It had a number of goals. The foremost is protection of human health and the environment, but in the same time ensuring that chemical industry in Europe remains competitive and ensures the innovation. And in relation to the innovation, also that animal testing is used as a last resort. So this was supposed to stimulate the development of alternatives to replace animal testing. Also among the principles of REACH are the standard information requirements, which are based on the tonnage. The higher the tonnage, the increased number of testing needed, and also for the exploration of the long-term effects of chemicals like reproductive toxicity or carcinogenicity. It also requires, as a benchmark, the use of the OECD guideline studies, which are expressed in the different annexes as standard information requirements. And of course, adaptations and waivers of that information is possible based on specific rules. And these requirements aim to ensure, as I already mentioned, that the risk assessment is properly done, including the classification and labeling, and with this it ensures a high level of protection of human health and environment. Over the past decade, there were 3 registration deadlines, which were supposed to bring all the data, existing data, into the database and consolidate the database on chemicals. We have also observed over the years that perhaps the level of compliance was not sufficient with the intention of the regulator, and there was quite a high focus on filling data gaps, getting more data to ensure compliance, and also ensure confidence of the citizens that we have appropriate protection of human health and environment. And the journey continues with the aim to ensure also faster risk management, especially at the union level, through appropriate regulatory risk management measures. So just to recap, there are a number of key elements that make the current regulatory system working, the REACH in conjunction with the CLP, and maybe also good to mention that this system has been appreciated not only in Europe, but also outside Europe, and has been used as a model for other systems in other countries. So the main aim is to identify the substances of concern based on their intrinsic properties, based on their hazard. And for this, we need defined hazard classes with good criteria that allow a consistent classification. And this classification is based on adverse effects, especially when we talk about the higher tier testing, like reproductive toxicity or endocrine disruption. In the same time, they require derivation of safety levels and thresholds for ensuring that those substances can still be used under certain conditions according to some criteria. The system also allows appropriate decision making. The quality of data makes it more reliable and reusable by other actors, and data sharing is also one of the main principles to ensure the reduction of animal testing and avoidance of the application of tests. It also allows mutual acceptance of data, not only in Europe, but also at international level. REACH also introduced the reverse burden of proof, which means that authorities do not give a permission for using the chemical by default, but we share the responsibilities. Authorities focus on those chemicals that are widely used with hazards of concern for the society, while the industry is able, through this set of information requirements, to ensure that they do their part and then they put on the market chemicals that are safe. And also the standard information requirements allow predictability and legal certainty for both industry and authorities, ensuring also enforcement and feasibility from the workload perspective. Few words on the 1173 report, the last edition that was published yesterday. This report it's a legal obligation stated in REACH in 117 in the article 1173, which requires ECHA to report on the status of implementation and use of alternatives for data generated in REACH registrations. For this edition of the report, we did a data analysis of the current REACH database in the same way as it was done 3 years ago. But on top of that, we also did an analysis of the last 3 years. Since the last registration deadline was in 2018, we consider that the past 3 years represent now the way we see registrations coming in on a regular basis. And that's why it's important to see the trends after we have dealt with the so-called legacy of the past. The report also contains ECHA activities on NAM and our contribution to the ongoing debate to transition towards full replacement of animal testing. So what do we see in the report? We see something that is very similar to observations from the previous reports, meaning that the adaptations are widely used to fulfill the information requirements, much more than experimental studies. And when we talk about experimental studies, it's cover animal testing, but it goes way beyond, because the experimental studies are also the non-animal testing. Besides read across, the use of QSAR is quite important, and weight of evidence. We also see that, as said, there are not big differences comparing to the previous deadline, to the previous report that was in 2019. And this is also because the steady state of registrations after 2019 was at quite a low pace. There are not so many chemicals registered every year following the last registration deadline. We see that as we move to the higher tonnage requirements, to the higher annexes, the use of animal testing is decreasing, and this is also something expected because it relies a lot on the testing done at the lower tier, and then this enables waiving tests requiring a lot of animals. We also see an increase of uptake of alternatives for the endpoints where there has been a change towards replacement of animal testing. Skin corrosion, skin and sensitization, and also eye irritation see an increase in the in vitro testing. So about 90% of the studies are done using alternatives in vitro methods. And only a very small percent is still covered by some animal testing, as those chemicals are not within the scope of the current test guidelines with the in vitro testing. So maybe a few words about ECHA's work on development and promotion of alternative methods. As said, we have been active in this from the very beginning, also because of our legal obligations, and we use alternatives at different stages and in different frameworks. We use alternatives in our processes for prioritization of substances for regulatory action. It's a form of grouping to reduce as much as possible the need for animal testing when we request certain studies that are not there and are needed to enable us concluding on the hazardous properties. We also provide input to harmonization and reporting, and here we work quite a lot on Euclid and promoting Euclid as the standard format for sharing the data. But we also contributed with the development of the framework for assessing read across, which is a reference nowadays for assessing read across. We contribute massively to the QSAR toolbox development that we co-own together with the OECD, which in itself constitutes a very reliable tool for using, for developing alternatives for certain endpoints. And we have also contributed significantly to the development of the OECD test guideline for the skin sensitization from the beginning of the project until it became a standard in the REACH requirements. More recently, we are also active in the organization of training and promotion internally, but also towards our stakeholders and collaborators in the member states. Last but not least, we interact a lot with sister agencies and key stakeholders like the EPAA, European Partnership for Alternative Approaches, or working on international collaborations like APCRA, accelerating the pace of chemical risk assessment, and also with collaboration with EFSA. Yeah, this is more like a promotion because this is in a way our baby. We worked on the QSAR toolbox for many years, and we would like to continue promoting also because the data that has been generated under REACH over the past decade, it's somehow assimilating in the QSAR toolbox and enables better predictions for the future, and hence reduction of animal testing. Our priorities for 2023, well, obviously this workshop, which is our contribution to the ongoing debate on reduction and replacement of animal testing, focusing on the NAMs for hazard assessment. And then this, for obvious reasons that I already mentioned, the REACH and CLP are very much hazard-based. Other priorities are related to increasing the cooperation with our partners, but also with the research projects, because this is the way we see that we could make progress, as I already said, by working all of us together. So if we envisage a system with full replacement of animal testing, how do we make faster progress? There are a number of questions that need to be answered in this field. And one of the main is how we could address the adverse effects, the most relevant diseases and concerns for the society through the alternatives. How we can address the carcinogenicity, the reproductive toxicity, endocrine disruptors, immunotoxicity. Is there a way that we move away from adversity and then find a different way to address it with the NAMs? And how ensure at the same time the same level of protection or better for the human health and environment. For this, we need to identify the critical needs, and this workshop is hopefully one way to go in this direction. And we also need the concerted efforts of all stakeholders. We all need to play our part to enable faster progress. From our side in ECHA, we are very committed to play an active role and together with you to pave the way towards a full replacement. And with this, I would like to thank you very much for your attention and looking forward to the discussions.
Thank you, Ofelia, for sharing ECHA's perspective and for reminding us of the report we published earlier this week on the use of alternative methods and, of course, the promotion of the QSAR toolbox. I'm sure there are already questions or comments that come to mind when listening to the speakers. I think we will have an ample Q&A session later this morning, but you can, of course, start putting your questions already in Slido. And if you want to indicate which speaker the question is addressed to, you can do so. We have heard already a few times references to the OECD in the context of the test guidelines. So now I'm very happy to introduce the next speaker, which is Dr. Patience Browne, which leads the pesticide and hazard assessment programs in the OECD in Paris. Before that, she was working in the US EPA. And I think she's in a very good position to bring us today the international perspective to this topic. Unfortunately, she couldn't join us here today, but I think she will participate online in the panel later this morning. But for now, we will listen to her intervention through a video. So, video with her.
Good morning to everyone. It is my pleasure to be here with you virtually today to talk a bit about the OECD work on international acceptance of new approach methods in a regulatory context. We've already heard and will continue to hear from speakers today about some of the drivers for increasing the uptake of NAMs in a regulatory context. There's recognition that reliance on in vivo testing really limits the throughput in terms of the number of chemicals that can be evaluated each year due to the time required. It inflates the cost. The estimated cost of bringing new products to market ranges in the hundreds of millions to billions of dollars, for example. It requires a lot of time, so even if associated with higher uncertainty, decisions based on NAMs may be more protective of human health and the environment because they're so much faster. There's recognition that animal tests may not be the most relevant predictor of effects in humans, and there's changing regulation globally which reduce or prohibit animal tests to evaluate the safety of chemicals. So starting with the OECD test guideline work using NAMs, you can see on the left side a variety of different OECD internationally harmonized test guidelines that use new approach methods. By and large, these address acute toxicity endpoints. The couple that are highlighted are defined approach test guidelines, and I'll come back and talk about DAs in a bit. But there are, as well as the test guidelines, guidance on NAM use in this context. The results of OECD test guidelines are covered by the Agreement on Mutual Acceptance of Data, and I'll touch upon that on the next slide. These are test guidelines that describe methods for generating data to evaluate hazard, and these are independent of the regulatory frameworks. So they include some interpretation of the hazard that may be yes, no, or quantitative data, but don't generally include outputs for specific frameworks. For example, information to classify chemicals according to the GHS classification and labeling system. Results of OECD test guidelines conducted in a GLP environment are covered by the mutual acceptance of data. However, the use of NAMs may actually challenge MAD. Regulations vary in specific data requirements and the flexibility to fulfill those requirements. And in addition, there are now explicit national or organizational mandates to use NAMs. This variability creates potential divergence among countries and regulatory authorities with regard to their ability to accept data. So there are a variety of NAM roadmaps that discuss how authorities will use new approach data, and that acceptance is not harmonized. MAD regards information sharing among member countries that have the same data requirements. So these variability in data requirements and acceptability actually may jeopardize MAD. In contrast to the OECD test guidelines program that publishes methods and guidance for producing data for chemical hazards, the OECD Hazard Assessment Program is intended to develop best approaches and practices for integrating information to come to decisions on chemical hazards. There are a variety of different projects that discuss the use of NAMs in a regulatory context. For example, IATA Case Studies project is in its 9th year. There's ongoing work to update the OECD guidance document on chemical grouping to produce a 3rd edition, which is expected next year. The QSAR Toolbox and other electronic tools are under the Hazard Assessment Program. There's been recent work to develop omics frameworks and guidance to support chemical safety assessment. And there are a variety of topic-specific guidance documents, for example, the recent PBK modeling guidance document. This is intended to be a forum to discuss how to build confidence in NAMs among regulators and other stakeholders. And there is work to identify aspects of new approach methods and reporting that can be harmonized. The products of the OECD Hazard Assessment Program are not bound by the mutual acceptance of data, so they are inherently flexible and innovative approaches for evaluating chemical hazard, although some of these may be destined eventually to become test guidelines. Not all are intended to end up there, but are not necessarily at this point. So when we think about both of these programs, there are a number of critical elements to consider for NAM acceptance in a regulatory context. And you can see here just a path with a number of these critical elements identified. I'd like to point out at the end of this path, we have the possibility of leading to a test guideline, but it's not necessarily the only place the path leads. So I'm going to go through. So the first critical step is to come to a common understanding on what we're talking about. So first of all, what is an OECD new approach method? New approach method in the OECD context is everything that's not an old approach method. So this is in chemico, in vitro methods, data science and computational approaches, as well as in vivo methods that fill data gaps. These may be standalone methods, but probably more often these days they're integrated methods. They are not non-animal methods, but they are aligned with the 3 Rs. They lead to faster time to safety decision making, and they're less resource intensive in terms of cost, the time required for testing, and animal use. So it's written in a variety of different documents that OECD supports the use of new approach methods when they can be determined to be as good or better than the existing test method. So what are the standards for evaluating what is as good or better? First of all, results must be reproducible. It must be a scientifically robust method. It must be documented in sufficient detail that following the same approach, the result can be reproduced. The test method must be relevant, although relevance may vary with the specific regulatory application. For example, for prioritization, one may need a NAM that's only sensitive to chemical-induced changes, while for other circumstances, the NAM should be predictive of a specific toxicological endpoint. In all cases, the NAM should be biologically relevant to the target species. So in some cases, it should be relevant to human health or predictive of ecotox responses. The other aspect of evaluating suitability is a consideration of the approaches that are currently in use. On the right side, you see the iceberg analogy, which I'm sure will come up for a variety of different contexts today. But that is to say that about 30% of the chemicals in commerce have data for chemical assessment, while the other 70% have limited or no data whatsoever. So suitability of the NAM should consider how much information you have, and the standard for some NAMs should be to perform as well or better than the in vivo reference test method, while for that 70%, the NAMs may provide information when in fact there is none, which is a substantial step forward. The third critical element is having clear contexts of use. So we need NAM solutions for a variety of regulatory contexts. There are some NAM solutions that are suitable for data-rich chemicals and have a very high standard versus data-poor chemicals where we really don't have any information at all or very little. That was addressed in the previous slide to some extent. We need solutions that are suitable across a variety of different chemical sectors and regulations, for example, cosmetics ingredients, pesticide active ingredients, and industrial chemicals. We also need NAMs for a variety of different regulatory problem formulations. When we look at the sub-bullets here and we start with prioritization, moving through hazard identification, hazard characterization, points of departure, and risk assessment, of course, there's different levels of information that's needed for each of these contexts, and likely different levels of confidence or uncertainty that are associated as well. That is to say that perhaps in some cases, the same NAM may be suitable for prioritization initially, which is a fairly low standard. And as more information is acquired, there's less uncertainty associated with the NAM itself, and there's more experience using this. The same NAM may actually be suitable for a different purpose as the information accrues. So this is likely to be a continuum and an evolving process. A critical aspect of the acceptance of NAMs is identification of aspects that can be standardized. So why is standardization so important? It facilitates the review and uptake by allowing regulators to become familiar with the elements of the method, to rapidly assess the adequacy of information, to easily share the information, and to link the information to existing chemical databases that include things like the traditional in vivo information sources. Standardization can occur through reporting formats, and we have on the left a variety of reporting formats for things like QSARs, elements of AOPs, omics, the test guideline data, as well as non-test guideline data, PBK models, etc. And standardization can also include how that information is integrated or evaluated. For example, in AOPs, the recent work on the QSAR assessment framework, which should be publicly available later this year, and demonstrations of approaches through the IATA case studies project. The fifth milestone for acceptance of NAMs is understanding regulatory needs. When we ask what information do regulators need to assess chemicals, the answer is typically not the raw data that results from experiments. On the left side, we see a stylized cartoon of the mouse local lymph node assay test, and in fact, regulators are not directly using a measure of lymphocyte proliferation from those assays, but an algorithm is applied to the data to give regulators something they can use, for example, a category 1A strong sensitizer. But this isn't the direct output of the test. When we started using NAMs in the regulatory context, we can think of step one as being test guidelines that were based on what was available at the time. And this is somewhat of a square peg round hole analogy. These were in vitro methods that were largely coming from the pharmaceutical industry that were useful, but perhaps not highly tailored to the regulatory context. Step two was to develop NAMs that were developed with an intended purpose in mind, so they were certainly more suitable, but we're now in step three of this phase, which is to integrate information sources to overcome limitations of standalone methods, address relevant biology, and meet regulatory needs. These are NAM batteries that are designed specifically to address biology. So when we think about methods that can be used in combination, there's the critical need to understand what regulators want. The defined approach for skin sensitization test guideline is the first example in my mind where we have methods used in combination that address different regulatory contexts. In the DAs, we have DAs that are suitable for hazard classification, that's GHS potency subcategories, as well as hazard identification of sensitizers versus non-sensitizers. Okay, so putting this all together, I mentioned that where we end up is not a single path. We have different places. We can go to test guidelines or we can go other. Just an example of how these two approaches might diverge. We have IATAs on the left and defined approaches on the right. IATAs are intended to be flexible and judgment-based, whereas defined approaches really take a lot of the same framework, if you will, but they fix the decision-making, including information sources and the data interpretation procedure to be highly reproducible. That is to say that the defined approaches can end in NAMs used in a test guideline, and the skin sensitization is our first example. It took 4 years to get the first defined approach test guideline and a decade of work supporting that guideline, but it only took 1 year to get the second. So we can think of this as really a blueprint for how to do this, how to put methods together in combination, have a defined approach that includes a data interpretation procedure suitable for a variety of different regulatory needs and produces something covered by the mutual acceptance of data. And here other is something in addition to or other than a test guideline. And I mentioned I'd come back to the OECD Integrated Approaches and Testing and Assessment Project. So this is a somewhat unique project under the Hazard Assessment Program. It's unique because it includes examples of NAMs used in a regulatory context. They've been drafted by data submitters or regulators. They document the information sources, all approaches for data integration and expert judgment. They catalog the uncertainties and describe the conclusions. In many cases, the NAM is compared to a traditional approach. And there's independent peer review by regulators that includes questions regarding the applicability in a variety of different global contexts. So this project over the 9 years has led to a variety of guidance documents on the use of NAMs in a regulatory context and provides an opt-in path, if you will, for use of the IATA with or without modification, as well as a possibility of fixing aspects of the IATA for inclusion in future test guidelines. So for NAMs that are not test guidelines or not yet test guidelines, rather than asking if they're ready for regulatory use, we can consider what's missing and how the methods can be used now. Are there additional technical or implementation aspects that would increase the usability of the NAM? But perhaps most critically, we can separate the NAM itself from how the information or results fit into a regulatory context. The animal test data in most cases don't directly produce results that regulators use, but there's a model or algorithm that's applied to make that information usable in particular frameworks. The same can be built around NAM data, and I think the defined approaches are our first and best example of how this can be done. I thank you very much for your attention, and I wish you an excellent rest of the workshop. Thank you.
Panel. I think it was an interesting reflection of the important role that the OECD plays when we talk about test guidelines and integrated approaches for the further use of NAMs in regulatory setting. I think with this, I think it's time for a break. So we will have some coffee and tea and water served outside of the room. We're going to break for half an hour. So please come back at 10:45 in Helsinki time, adapt to your time zone for all the people online. And then I'll see you later. Enjoy. everyone. Welcome back, everyone. Also to the participants online. I hope you enjoyed the coffee break and you were already hopefully exchanging on some of the ideas that were presented this morning. We are now going to hear a little bit new ideas or new angles to it, starting with the industry perspective. Of course, an important player in this topic, and we are happy to introduce Chantal Smulders, who is currently heading the Global Product Safety Science and Regulatory Advocacy at the company Shell, but she's also the chair of the board of the ECHA, and she's also here today representing CEFIC. So looking forward to hearing industry's views on all this. Chantal, floor is yours.
Thank you, everybody. I had a lovely introduction here telling about the why, but the why has been so lovely represented by all the previous speakers here. So I can only say that I'm amazingly positive, actually, by hearing the speakers. And I see some patterns emerging, and I see some willingness for collaboration, and also already some small alignment around where the needs are. So I don't need to address the why any further. It is really about what action are we really now going to take. I think it's time to just roll up our sleeves. I don't have sleeves today, but and to really get working on it, right? So I have a clicker. Let's see if I can make it work. There we are. So here I'm presenting the industry view on behalf of CEFIC. Let me just move forward straight away. And I only have 4 slides for you to keep it simple and easy. We are going to reflect the 4 needs that we see, and you will see the themes that you already heard previously by my predecessors. So the first need that we see is that we all need to agree on a framework for the current application of the NAMs. What can we do now in the current regulatory context or in the short future? The next is, of course, then the longer-term vision. We need to have a longer-term vision for the new hazard and safety paradigm and a roadmap towards it. So we first start to gradually use them and then need to rethink and rebuild the whole system. We also need internationally harmonized application of NAMs methodologies and mutual acceptance of data. Pat had an excellent presentation and I can only build on that one. And last but not least, we need better users and exposure information for substances. The short-term work, what can we do now? And why is this so important? We really need to start building confidence and experience in the NAMs because those are the best available science today. We've built and used the best available science in the past years. But it's like a colleague of mine described, it's like driving in snow. The first day of snow, I mean, I live in the Netherlands, he lives in the UK, it never snows, it hardly snows. So the first day it's snowing, everybody is staying inside, like I'm not getting out today. The second day, everybody has some essential things to do, so they gradually start to get out. And the third day they're driving in snow like they're in Helsinki. So all in all, we need to start building experience and start using the NAMs. Also, we need to build the experience to avoid triggering even more animal testing in the future, because that's what society expects of us. So I have identified a few enabling activities to actually get there. 1, we really need to allow the use of NAMs in the current regulatory schemes for weight of evidence, read-across approaches, as well as the new hazard classes and lower tonnage bands. We already saw some great examples from Ofelia. We are already doing it. The omics data are used in read-across approaches. But if you look at the new hazard classes, there's more and more a need to inform ourselves about neurodevelopmental and endocrine endpoints. Are we really going to test the animal tests to the limit? Or are we leveraging the NAMs that we have for this perspective? Also, and that's a real need, we need to establish a science discussion platform to share and discuss the learnings and the interpretations and experiences, a safe place to discuss science. We all are scientists and we need to agree on how to move forward. We also need to evolve the development of NAMs for screening purposes to designing them really for the classification of substances and for safety decisions. As Pat alluded to already, it's the context in which they are used. If they are designed to be a screen, they are designed to be a catch-it-all, and that's different if you use them in the context for the derivation of a classification. We also need to define the domain of validity and the acceptance of the outcome. And the last point in action is a very lengthy wording for basically we need to validate differently. Next, it's the longer term vision. Really, we need to change the whole paradigm and agree on a roadmap towards it, with clear milestones, as already alluded to by Cristina. I think that's an excellent plan because then we all have a bit of a compass to work towards. So one of the activities that we do need to do is map the required changes to the regulatory frameworks on the medium and the longer terms, because REACH is not the only framework, there's also GHS. I will address the qui vive interpretation later, but definitely what we also should do is really define some capacity building, training needs, laboratory capacities and capabilities, but also what can we do for the small and medium enterprises? The next point is already reflected by Pat in the previous session. We really need to ensure an internationally harmonized application of the NAMS methodologies and mutual acceptance of data. If we need to test in multiple frameworks and in multiple regions of the world, you can only make some baby steps if you change in one place. So we better need to do a synchronized change all across the whole system. So as some starting points, we need to start developing a robust system for data reporting and data sharing for NAMS. Also, workable and straightforward weight of evidence approaches for data interpretations. And last but not least, because there are so many stakeholders involved, a multi-stakeholder platform, and evidently the OECD need to be at the table, and Pat had great slides that you all just saw. The last action and the last needs is a very important one. That's why I kept it for last, but it's also a very complicated one. It is the improvement of the use and exposure information governing the registered substances. It's critical for a few reasons. First of all, for the objective of improving the protection level, as really refined exposure metrics can help targeting testing needs, but also because the use and interpretation of NAMs really depends on the internal as well as the external exposure metrics. So we need to work both on internal as well as external exposure metrics. So I've been thinking through and going through also the EPAA partner forum that already had an excellent discussion on it. If you look at the internal exposure metrics, there's really a need for the development of qui vive approaches to extrapolate from NAM data to in vivo benchmarks. A lot of work has been done, but it needs to be the agreed methodology and the framework in which we use them. Also, we need to progress the development and use of bioavailability and thresholds of toxicological concern concepts for exposure-based adaptation and targeted testing. There is a very large chemical universe. You can't test everything for everything on every topic. So you really need to know, where do I need to focus my efforts so we can effectively identify the chemicals that really needs risk management. Last but not least, it is the improved use of aggregate exposure estimates and of human biomonitoring data. We all have to play our role in insights in this. And I say this with a sense of humility, because I know that there's a lot of work to do also by industry. But I'm positive because REACH has really improved the insights that we currently have already on use of exposure compared to the period before REACH. So we really have to roll up the sleeves and start working on it collaboratively. Thank you.
Thank you very much, Chantal, for sharing industry's expectations already formulated in terms of actions that you expect to see progress with. I think when you talk about the whys, I think all the speakers have mentioned animal welfare. That's why I'm very happy to introduce now Julia Baines, representing PETA. I think they're one of the key players behind also the Citizens Initiative, so definitely playing an important role in this debate. So Julia, welcome to the floor.
Okay, thank you very much for giving us our voice really today. Although I'm here representing PETA, I am giving the voice of the animal protection stakeholders. So I do want to mention that I have also been collaborating with colleagues at Eurogroup for Animals, the Coalition to End Animal Experimentation, Cruelty-Free Europe, and Humane Society International Europe. And so this is our collective voice, and we feel that there is more to be gained from moving to a regulatory system that seeks to rely on non-animal methods. And we know that the limitations of traditional tox testing using animals are obviously characterized by, as we've heard before, the high cost in terms of throughput, the inconsistent responses we get, the ethical issues, the extractability to humans. I mean, I could go on and on. And these limitations and also the wider issues that we face in terms of the administration issues, these can all prevent the complete assessment of substances. And so the transition away from animal testing does clearly face numerous challenges. And as we've heard just now, that includes the need for robust validation of the non-animal methods. And I'm looking forward to hearing João's talk later on this afternoon on the framework that we can put in place for this. But there's also the complexity of assessing long-term endpoints, limited funding for developing additional methods, the regulatory acceptance, the requirement for education and training. These are not new challenges that we're facing, but they are ones that we need to recognise. But equally, we've got the development of a generic risk assessment approach, data sharing issues, ensuring reliability, consistency, reproducibility, standardizing methodologies, considering what is an acceptable level of risk, the uncertainties, promoting mechanistic understanding. And these aren't just challenges faced by the non-animal methods. These are very similar challenges faced that we see with the traditional animal approach as well. And so I would say our first message is really our first step towards rehabilitation is admitting we have a problem. And so it's fair to say that we are at a tipping point in the EU. The chemical strategy for sustainability represents very critical challenges for us all to address. So these include the identification of endocrine disruptors, the registration of polymers, hazard identification for neurotox, immunotox, expanded information requirements that we might be seeing for lower tonnage substances. And so without very clear steps to modernise the regulations and without the requirements put in place to ensure that these goals will be achieved without using animals, there is a risk of maintaining the status quo and continuing in that comfort zone of relying on animal models. And so it is very, very crucial that we work together to find the solutions that support this transition to what we see as being a more reliable, but also a more scientifically advanced way of achieving protection within the EU. And so it's nice that we have seen that we've been speaking about opportunities. Now, for some reason, the slide isn't showing the bullet points, so you'll just have to listen to me instead. And so first, in terms of opportunities, we want to recognise that it is entirely feasible to achieve the dual objectives of the chemical strategy, which is to enhance human health, protect the environment, whilst also simultaneously reducing animal testing. And these goals are not contradictory, but rather they are synergistic. It's not a balance between one or the other. It's about promoting a better way of achieving regulatory protection. So that's one of the critical points that we really want to address. It's not a trade-off. That's not what we're looking for. So some solutions then, well, to effectively accomplish and enhance human health, protect the environment, reduce animal testing, we would say it would be rather a good idea to have the creation of an expert scientific committee in the area of NAMs. And so this committee could, for example, play a really vital role in achieving our goals by providing impartial advice, recommendations aimed at reducing animal use. The committee could also conduct comprehensive review of existing legislation, practices, identifying further opportunities. It could rigorously assess, for example, testing proposal waivers, emphasising that requirement to only test on animals as a last resort. There's plenty of expertise in this room here today and online, and it's these kinds of people that we would want to see feeding into this kind of committee. It's bringing that expertise to the forefront. Some other short-term solutions, well, we propose removing any redundant animal testing from current legislation. So whenever we're looking at a transition and advancing on what can we do in the future, first we need to ask, what can we stop now? And so it is a case of reviewing what isn't working. Maybe, for example, we want to address the multiple testing on different trophic levels, the 2 species requirement. That is a starting point that you could look at. We advocate against introducing new animal test information requirements, and this is due to the limited nature of those kinds of tests. And until existing animal tests are replaced, we recommend requiring testing proposals for all vertebrate testing to keep those checks in place to make sure that last resort requirement is clearly being met. And so we would also say, in terms of the REACH review and what can we do now, let's look at the language of REACH. How can we make it a more positive language? How can we reframe our thinking a little bit? What can we do with REACH Article 1, for example, that is explicitly about advancing non-animal methods? And could we put in there that the goal is to ultimately phase out animal testing? That's something that could be recognised in Article 1. Likewise with Articles 13 and 25, that last resort requirement, the requirement to use non-animal methods wherever possible. Can we mandate that animal testing only happens when it enhances safety? Because we don't think it particularly does. And so again, we've heard, similar to what Patience was describing earlier, implementing more of those kind of testing frameworks where we're looking at IATAs or defined approaches. There's already some really excellent work that is going on. So as well as what can we stop, what can we continue? And that is some of those kind of practices that we'd like to see more of. And we also emphasise the need to enhance transparency, particularly in grouping practices that are employed. And this is because grouping should not be used as a trigger for further testing. And so, as we've just heard from Chantal, it is that risk that non-animal approaches might be used to trigger further testing where it's not actually required. So I think we need to have some of those checks and systems in place. So as we look more towards the long-term future of chemicals legislations, we'd recommend incorporating some more kind of flexible language, more positive language into the regulations, into REACH and CLP. And this is to keep the regulations aligned with scientific advances, because we don't want to confuse information requirements with data requirements, putting in very specific test guidelines, for example, into the REACH annexes. It could have that limiting effect on, well, if we do have these new approaches as Patience described, how are we going to actually incorporate those and make sure that we are future-proofing the legislation to keep up with the scientific advances? And so we also advocate again for a paradigm shift in risk and hazard assessment. And a new paradigm should ultimately try to strike a balance between these two approaches, incorporating different data types. One approach to achieve this is adopting next generation risk assessment. Proposed frameworks by HSI, for example, also presented by the JRC at the Caracal meetings, have emphasised this kind of approach. And also to try and optimise efficiency and resources, we'd also think about, well, what can we do to streamline our regulatory processes? What can we do in terms of looking at dossier evaluations, substance evaluations, and making sure that we consider the essentiality of animal testing? Again, it's having some random things, or it doesn't want to describe the text, so I shall carry on describing. But what I was really, really pleased to hear from one of this morning's sessions from Cristina really was that it is so important to effectively track and monitor our progress. And so one of our key points really is about having the metrics and the goals and the systems in place so we know how we are doing along that road path, along that map to success. And so we would say we need to conduct regular reviews of available methods. We know ECVAM are already doing this. Can we look at the role in which ECVAM's doing and incorporate that into the Article 117 report that was also just shown earlier this morning? How can we make sure these two different types of work are actually working synergistically together? We can also look at monitoring progress through KPIs. So these could cover various aspects like the use of non-animal methods, promotion activities, acceptance rates, compliance with the last resort requirement. What more data can we get to ensure we're still going in the right direction? And so enhancing reporting obligations is something that we can look at through ECHA and both the Commission. And so finally, just to conclude, as we've heard that the phase out of animal testing represents a really important goal that is driven by the demands of EU citizens, as we've heard about the European Citizens Initiative. And so it's crucial to really acknowledge the pressure that is being placed on the regulators and align that with the values of Europe as a society as well. And we know that transition science will play a pivotal role in envisaging and shaping this picture. And I know for many toxicologists in this room, you might be thinking, well, what on earth is transition science? So I would say watch Meryl's presentation tomorrow and you'll hear more about that. And so with optimism, determination, we can embrace what we see as a very transformative journey and embrace these values of progress, but also compassion, because it does come back down to animal welfare at the end of the day. Thank you.
Thank you, Julia, for sharing the perspective of the animal welfare NGOs, but also for setting out some very concrete ideas for things that could be put in place. I'm sure we will discuss some in the panel. I think last but not least, we're going to listen to another group of important stakeholders, which is the health and environmental NGOs, with Natacha Cingotti, who's joining us today from HIL, the Health and Environmental Alliance. I think she's a very known face in the area of chemicals regulations, participating in many of the discussions we have on the current implementation and also the future. So looking forward to hearing from you, Natacha.
It's working. Great. Good morning, everyone, and thank you to ECHA for organizing this workshop and offering the opportunity to share a civil society perspective today. I'm representing the Health and Environment Alliance, but I will speak on behalf of several health and environment organizations, including the European Environmental Bureau, ChemSec, ChemTrust. And in fact, we think this workshop comes in particularly timely. With a group of over 20 NGOs back in February, we actually shared our points of view on this issue of the replacement of animal testing in the future with the Commission. And in fact, the presentation I'm going to make today is mostly based on the demands that we have developed jointly in this paper, which is publicly available. So, of course, importantly for us as health and environment NGOs, drivers of our demands on this topic really stem from the regulatory context and the market reality that we see for chemicals on our markets. And what we identify, and I think have also been identified by the European Environmental Agency and the REACH review, is significant data gaps when it comes to chemical substances already on the market. The real-life consequences of those data gaps is that, of course, we are facing major health and environment protection challenges, but also, as we can identify, an issue of credibility for our regulations and the good application of the letter of the laws that we have here in Europe for chemicals and for product regulation. Other considerations to take into account when we approach this topic is also, of course, the reality of the setup of our regulatory framework for chemicals. We do have in Europe a high level of evidence necessary to identify, classify, and regulate chemicals of concern. And because the no data, no market principle is currently not implemented, we actually see a reversed burden of proof, mostly on regulators to often be able to prove concerns. So we think this is an important problem at the moment, and we hope that this can be fixed through upcoming revisions, including the REACH revision. I think all stakeholders in this room and those watching are, of course, committed to the uptake of NAMs for regulatory use, but we also see a number of limitations at the moment. We are lacking still validated and regulatory accepted NAMs across endpoints of concern, and I will come back to that in a minute. But still, I also share some optimism, and I want to point and stress that the transition to NAMs today is already underway. We have seen it with the uptake of new tests. For instance, we talked about endpoints such as skin sensitization, eye irritation in REACH since 2016, we think it's very positive. We have also seen very positive development in the recent development of new hazard classes under CLP, for instance, for endocrine disruption, where we do see references to NAMs in the evidence base that can be used in the future. So we think this is positive and this is a way to go. Now, when it comes to our recommendations, I would say that they are at 3 different levels, and I will go through them in this presentation. The first one is, of course, linked to ongoing discussions about the REACH revisions. We think that revising the REACH information requirements is urgent. And this is urgent in our view because the current loopholes that we have regard endpoints of high concern. Endocrine disruption, carcinogenicity, these are things that we need to have much better information about. Now, we acknowledge very exciting developments are going on in regards to NAM development for those endpoints. But at the moment, with the current regulatory definitions and requirements that we have, we do not see that on their own they're able to meet those regulatory definitions. Which is why, at the risk of being controversial here today, we also need to say that at the moment, yes, we still believe that in vivo studies are necessary to establish knowledge on important endpoints such as immunotoxicity, endocrine disruption, when we're looking at effects across generations. The second demand that we have, and I think points to a lot of what has been mentioned already this morning by other speakers, is also that, of course, we would like to see in chemicals regulations a commitment and an inclusion of provisions to gradually really being able to do NAM-based hazard identification as a basis for future regulatory control. So that really means having a ready up language so that we can use validated acceptable NAMs as soon as they are available. So again, here I think the development on the recent CLP hazard classes is particularly positive, but that also means in our view that we need to be much better at promoting group assessments for classification as VHC identification restrictions based on read across and in silico as a standard approach. And that needs to be clarified in regulation, including in REACH. The third recommendation that we have relates to also probably the most cost-efficient way to combine the goals of reduced animal testing and increased protection. We think, in our view, that it is necessary to implement a precautionary approach to our chemicals assessments and regulations, and that requires to ask ourselves maybe difficult questions about the level of evidence that we want to use to make decisions. And I think the upcoming and ongoing regulatory discussions on REACH, CLP and other sectors are an opportunity to do that. We also think that this reflection on the precautionary approach and the question of the level of evidence must lead us to ask ourselves how we can use the data that we have and all the data that we have in a better way towards a more precautionary approach. So, of course, developing NAM academic data, but also the in vivo data that is there. We need to be able to take action much earlier when we see concerns emerging out of the new data. And that, again, requires us to ask ourselves, are we ready to be able to take decisions based on early indications of concern? And of course, also having a honest discussion about how we use in vivo data when we need to use them. Maybe we can be more efficient. Maybe we can do better with data sharing, with test adaptations. And also, certainly we can do better with looking at how we design studies, how we establish dosing regimens. We see too many discussions in the ECHA, ED expert groups and elsewhere where actually we are using animal studies that have not been dosed properly, and that should not be possible in the future. So I will just finish this presentation with a couple of considerations to feed into the discussion of the next 2 days, hopefully in a helpful way. But I think for us as health and environmental NGOs, we need to approach this discussion on the transition to NIMS by really clarifying what are the priorities of the regulatory goals. And in our view, the urgency is indeed to identify and regulate chemicals of concern in a faster and more protective way. And that should lead us to also keep in mind important considerations. Of course, everyone wants to avoid using laboratory animals, but we also need to approach the question of animal protection from a broader perspective, including the protection of wildlife and domestic animals. And that might sometimes require considering in vivo testing, for instance, when we're looking at endocrine disruption for the environment. We also think that it's important to put the issue of animal use for chemical safety testing in perspective with other uses. We sometimes hear a lot of criticisms towards chemicals regulators, but we also want to repeat that actually, well, the pharma sector is a very big user of animals, and that needs also to be reflected with honesty. And as I mentioned earlier, of course, if we are serious about really taking up NAMs for regulatory use, then we need to think about the architecture of our regulatory system and make it less burdensome, in particular for regulators to be able to make conclusions. Having said that, also I think pointing to what has been mentioned earlier, we think it's important to have a holistic and flexible approach when we look at this topic. We don't see it as an exercise where we're pinpointing at regulators for using or not using a specific test methods. We really need to look at it as a package of measures that really question our scientific practices, our regulatory practices, and concerns all the stakeholders. So that also means that we need to be ready to review our practices and update them on a regular basis, and to be ready to approach this gradual transition in a way that we're not looking at the replacement of a specific in vivo test method by another one, but maybe indeed have a more comprehensive, refined approach depending on the endpoints we're looking at. So that leaves us also with this conclusion that in whatever we do, we also need to keep in mind that expert judgment will remain very important, and that also needs to be built in whatever framework we will adopt in the future. I see the screen is telling me I have no more time, so I will leave it there, and I look forward to the discussion. Thank you very much.
Thanks, Natacha, for sharing these recommendations and considerations. We're going to move to a panel discussion. So I think I'm going to ask all the speakers of this morning to join me on stage and take a seat here while we rearrange a bit the stage. In the meantime, we are going to launch a slide already because we want to already hear how much you got inspired by all the contributions made. So please look at the Slido and participate on this request for input that we can then comment with the panelists. Do I take the microphone then? Okay. This one? All set. Very good. So thank you again for all the contributions this morning. I think we wanted to start with some reflections, and in the meantime, just to remind also the audience online, we are having close to 300 participants following us online, which is very good. And you can also ask your questions via Slido. You can specify which panelists would you like to answer the question, and we will also use the microphones here on site. But first, I would like to ask the panelists to reflect already on some of the input shared this morning, and also on what the participants are sharing now. What is the biggest advantage of using new approach methodologies? I think we've heard many of the whys earlier this morning, and we have here some reflections in terms of human relevance that has been mentioned a few times. Of course, the reduction of the animals, but also the speed, to look at NAMs as a way of taking action quicker, faster on chemicals. So I'm going to ask the colleagues here to share some reflections. I mean, do you agree on these biggest advantages, or do you see any other that perhaps there are many, I must say. So you can take the microphone and Ofelia.
Yeah. Maybe I can you hear me? Can you? Yes, now it's working. Well, I think I can agree with many of the issues highlighted there, the human relevance, and then also the reduction of animal testing, but also thinking about the CSS goals, the sustainability aspect. The NAMs have potential in the future to help us be more predictive, and in the sense that we would know about the properties of the chemicals before we put them on the market, and eventually they don't go on the market because of our ability to identify the hazardous properties before, and this is an advantage not only for the citizens, for the regulators, but also for industry. They would not invest in such chemicals that could later on be phased out from the market. So I think this is also one aspect that could be mentioned besides the ones already on the screen.
Thanks, Ofelia. I don't know if Cristina or Chantal maybe wants to react on.
You can always go. So I think like Ofelia, I also agree with many of the things that are on the screen, although they keep on moving and it's difficult to follow them because they keep on being placed somewhere else. From a regulator's perspective, of course, one of the greatest advantages, the ethical concern, moving away, and animal welfare. So stopping using animals in order to ascertain safety. But what I'm also very interested is know more and know faster. And of course, as Ofelia said, I think that's very important, be able to know earlier in the process. So the role that the NAMs can have also for the safe and sustainable by design, and how to deploy better chemicals for the future.
Yeah, thank you. I agree with all of it. I think the good thing is the human relevance. It makes it the best available science. A little word of caution towards faster and cheaper, what is also sometimes there, because if you really look at an extensive NAM battery, that can be pretty complicated with a lot of tests. The capacity and the capability is not everywhere yet. So I think we are on a learning curve, and as we are learning, the benefits of faster, cheaper and higher throughput really depend on the context that the NAMS is designed, but also we may only achieve that after we have built the confidence and we have had the experience. So there is a little run up towards those benefits, I would say.
And I guess, I mean, it's clear that it's very nice to see that relevance is something that people continue to talk about, because we do talk about the scientific relevance. We're not just talking about human data, but also for ecotox, of course. And as well, it was mentioned earlier, the opportunities that NAMs bring, because they do bring many additional opportunities, not just in terms of relevance and better predictability, but also, of course, going back to animal welfare, because it is a legal requirement, not just under REACH to use animals as a last resort, but we have to go back to Directive 2010/63 as well, in that if there is a non-animal method available legally, it has to be used. And NAMS gives us that benefit. And of course, we're not looking for that one-to-one replacement. We're looking at a different way of doing regulatory assessments that don't rely on animal test data. And I think probably for me, in terms of one thing that might be missing from that are the benefits that NAMs bring. It brings a different way of thinking. It brings a paradigm shift. And I think that's something that we can really try and emphasize and move towards, so that we can step out of that kind of status quo approach.
Thank you. Lots of things have been said already. I think, of course, for us, there's the advantage of the data generation in hopefully a faster way. But where we do see the potential, if well crafted, indeed, is also going faster in terms of moving to the step of risk management and helping regulators prioritize what they need to focus their effort and resources on, and establishing a roadmap about, okay, what are the worst culprits that we really need to deal with right now, and what are those that, in fact, are less problematic and maybe need less resources and attention.
And you see we have an empty chair, which is a physical reflection of Patience, who's joined us hopefully online. And maybe, Patience, you want to share your views at this stage?
The environment than the few species that we currently use for in vivo testing for that purpose. Also, you know, for example, in the developmental neurotoxicity space, the NAM batteries that are being designed now are intended to cover the biological complexity of neurodevelopment rather than, you know, relying on a rodent model to predict such things in humans. We can really identify the key biological events in the human biology and create NAMs for that purpose. So, you know, maybe that's an extension of what's already been said about relevance, but really considering what it is that we would like to do with the NAMs and developing for the purpose.
Thank you, Patience. I think there seems to be quite some agreement on the advantages and the willingness to move to an enhanced use of NAMs. So now I would like to reflect on the challenges. I mean, because obviously there are a number of those, otherwise this willingness would have allowed a faster taken on board. So we again have asked all the participants to reflect on what you all think is the biggest challenges in using more on an enhancement of the use of NAMs, and you see some of them on the screen. The biggest one seems to be the regulatory acceptance. No, this is confidence, this acceptance of the use. Validation also comes up very usually in these discussions. How can we ensure that they are validated and again underpinning defining the regulatory acceptance. And then we see others, the modification of the regulation so that we can match the regulatory decisions to this availability of data, predictions. So I'm also curious to hear from the panel some reflections on what do you think are these biggest challenges? Do you agree with those identified here, or are there others? And of course, later we will look at how can we overcome these challenges. But the first, as it was said, is to identify the problems. You want to start, Ofelia?
I can give it a try. Yeah, of course, regulatory acceptance, validation, very, very pertinent issues. And I think something that was already mentioned today is, reconsidering how we address the higher tier endpoints. It was mentioned we don't look for one-to-one replacement. Yes, that's true. But the biggest challenge is how to consider redefining the adversity that comes from this higher tier testing, mutagenicity, reproductive toxicity, endocrines, how we could consider that we could address these issues that are of concern for the society with the support of NAMs. And there is progress. That's true that it's not tremendous because it's not so easy. And this also, so it's on one hand, it's a scientific progress, but it's also redefining the GHS, the way we address the adversity through the harmonized classification. And again, this is quite a considerable process to consider.
I think from my side, what do we really mean by regulatory acceptance? I think the regulation follows once there is the confidence. I think that is what I'm seeing more and more, is that as a regulator, the only thing that I need is that the scientific community tells me, yes, we have the confidence, like with this method, with this NAM or with this battery of NAMs, we feel comfortable to say that this chemical has this particular hazard property. Then the regulation follows. I only need to be told that there is this confidence. If we use again the skin irritation and sensitization and the eye irritation as examples, we went to OECD, we developed the test guidelines. They were ready for regulatory acceptance. They were ready to be introduced in the law. When we came to have the discussions at European level, I heard reluctance by individuals that had been involved in the OECD test guidelines. How is this possible? The only thing that we need from a regulatory point of view is to have that confidence. And maybe it's still a road to be walked, or because there are people that are really very convinced and very engaged, but maybe not the whole community is so. And the decision making in Europe is complex. I mean, we need everyone to be involved. We need all the member states and the scientists that also give their feedback to the regulators. So I think there is an issue of confidence. I think at some point we will need to find some turning points in the way we look at how we regulate chemicals and how we obtain that information. There will be a point in which it will be easier to find this confidence and there will be more consensus. And at some point, maybe, and that will be rather medium term, I would say. So there's still a long way to go. And I would like to see if we can do something in the short term to build that confidence, like we did with the skin and the eye. I think that helps a lot. Long term, maybe we're looking at some really big shifts. Maybe we need to change our conventions. Maybe we no longer will be looking at carcinogenicity and reproductive toxicity. We'll look at other parameters in order to obtain our hazard identification and then risk manage. Maybe we will be looking at at these endpoints differently, no? But that's very long term, and a lot needs to happen in the long way. So I think for me, one of the big challenges is this confidence and this disagreement on the confidence on NAMs.
Let me build on that, because I think that's why it's good to have those perspectives here in the panel. Because I also realized that regulatory acceptance is easier said than done. Because there's also a difference between the rule makers and the implementers. So there's definitely an element of regulatory dynamic flexibility, allowing the use of emerging science. That needs to be addressed. Also, experience and confidence is one of the items that we brought forward. And it is really, what can we do? Because you can see that there's pockets of a lot of experience in certain methods. So we also need to get it out. We need to be able to share that information in a standardized way, to publish it, so that all of us can grow in knowledge and capacity and capability in these methods. And it can't be one single lab doing one method. It needs to be, we all have to walk that journey together in understanding what works, what doesn't work. And in all reality, we are almost 80 years behind on the animal tests. That's how long we use them. So it's also accepting that we are still learning and that we are all learning together.
Yeah. I mean, we're hearing a lot about building confidence, so my suggestion would be, well, we need to look at a PR exercise for NAMs. We need to look at public relations, because I think there's a lot that can be done in terms of just communication and the way in which we are talking about NAMs, the way in which they are being framed. And it's not just what they are, but it's how they are being used for making decisions as well. And we've heard this morning through various talks that we shouldn't be using non-animal approaches for triggering further animal testing. It kind of defeats the object and defeats the purpose of us actually trying to aim ultimately to move away. And so I think we need to be looking beyond endpoints. We need to be transcending endpoints and looking more at a broader perspective in terms of communication. What else can we apply around the regulatory frameworks? And this whole paradigm shift and the way in which we are thinking about building this confidence. And I think one of the things that might be missing from the screen that I'm looking at is education and training. That's an important aspect, because the burden isn't just on industry to provide the data. The burden's also on the administrators to verify that information that they're receiving. The same we've heard REACH is a huge burdensome regulatory vehicle. It's massive. It involves all of the member states. There's a lot of input there. And so we need to make sure of this kind of harmonized approach, that we've got that education, that training, that understanding of the data that they're looking at, so they know how to make the appropriate decisions. So I think that has to be a really key point.
Thank you. I'm not sure if it's on the screen because some of it is written very small, but I think there are a couple of points from our point of view that we would like to stress. The first thing is, of course, here we're having a very general discussion on the uptake of NAMs, but we need at some point to also refine this discussion based on the types of effects that we are looking at. Of course, you cannot compare what is happening when we look at short-term acute effects versus very complex processes with regards to endocrine disruption effects that might be lasting across generations. So for us, that is really the starting point, and that's also something that we're missing sometimes a little bit in the public and policy debates around this issue, and that's very important because that brings us to this key question, which I think will come back later in the day in the program, about how do we establish adversity and how can we, in confidence, agree on a level of adversity. And I think for us, that is really the point where we're trying to figure out how a future system looks like, because we want to avoid protracted regulatory discussions where we do have indications from all kinds of NAM batteries, but nobody is actually ready to conclude and go for a decision that will have a classification, maybe a regulatory consequence. And that is really what we need to be having a honest conversation about. And that's, I think, the very big challenge right now. What we also want to avoid, and I think is a challenge for the discussion we're having, is that in the future, a regulator taking a decision based on a NAM battery, maybe based on very early indications of concern, shouldn't be right away attacked for doing so. And I think that brings us back to what I was raising in my presentation about, also building in this precautionary action. Are we ready to collectively move towards this approach? And I think that is a challenging question.
Thank you. And maybe Patience, I would also, if I may, ask you to reflect whether you see some of these challenges being also common at international level. I think these are some challenges that we are discussing also in the context of the OECD together with other regions. So we're not alone in that. In this. Is that right?
Yeah, indeed. I think it was well said before, but already we're talking about a field that was based on animal test data. Toxicity, educational training, regulatory decisions are based on that history. So shifting to NAMs is going to, across the globe, regardless of your agency or your regulatory legislation, is going to take some communication, some education, and some change in thinking. But I think part of, while agreeing with what has already been said, part of that challenge and opportunity maybe is also reflecting on how the current data are used, the animal data are used, where those limitations are. And while we've been talking today largely about hazard identification, I think, ultimately when we talk about risk assessment decisions, there are things like safety assessment factors added to the animal data, at which point we're now talking about something that's essentially protective rather than specifically predictive. And starting with the recognition that already animal data are used in that framework in many jurisdictions, I think NAMs fit a lot better or a lot easier. The idea that these can be protective of human and environmental health without necessarily predicting a specific adverse response. Maybe that's a longer term goal, certainly, but it's something to include in the conversation, hopefully.
Very clear, yes. I think at this point, if that's okay, I'm going to turn to the questions that we have received so that we can start addressing some of those. So while I invite, of course, the participants here in ECHA with us to get closer to the microphones, maybe we already got some questions from the online audience. So maybe, Andrea, you want to share some of those?
Yes.
To whom or to all the panelists?
Hi, Mercedes. Thank you. Here we have been quite busy at the Slido table. We have about 200 people on Slido right now, over 50 questions and votes. They go up and down. We have tried to group the questions and also to give them some logical order. And the first topic is a NAM definition. People have noted that PETA uses NAMs as non-animal methods. OECD does not, referring to the fact that NAMs can involve also some animal testing. And this has perhaps consequences for cosmetics. So there was this request that ECHA should state what is meant by NAMs in the context of this workshop.
Interesting. Thanks, Andrea. And looking at the panelists, what is it that we're talking about here, NAMs? What is NAMs? Is it the end that is important? Is it the alternative? Start, Ofelia, or anybody? The question that Andrea raised, like the definition of NAMs and why there are some, at least perceived differences in it.
Well, there is no universal definition of NAMs, and then it's how we want to approach it. From our perspective, NAMs refer to new approaches that help us taking decisions on the hazard and then the risk assessment without the need for engaging necessarily into new animal testing. And then this could be related to the new approaches, the omics, but also considering incorporating some of the knowledge that we already have in relation to QSAR, read across, and so on. But of course, I think more important here, it's the ultimate goal. And of course, we want to use whatever possible, whatever feasible that is currently available, but also to work towards developing new methods that would enable us making robust conclusions on the hazard and then risk assessment.
I see some nodding, but maybe Julia wants to complement.
Again, it doesn't help that non-animal methods and new approach methodologies are both NAMs. So I would say let us be clear and say NAMs are non-animal NAMs and that they don't involve in vivo testing. If the objective is actually to gain an animal-free test system, then we don't want to be using in vivo on the way to that system. So for me, it's very clear that a definition of NAMs is about the tools that you use. And those tools are in silico tools, in vitro tools, omics, etc. And that is very different to how those tools then may be used. So I would say let's put a full stop after what NAMs are, and then you talk about how NAMs may be used. Because yes, NAMs may be used for a reduction approach. NAMs may be used to refine further animal testing. NAMs could be used as a screening tool, for example. So NAMs are used in the context of 3Rs, but they are not in themselves a reduction method. They're not in themselves a refinement. What they are replacement methods. So I think we do need to be very, very clear on that.
Any other perspectives of maybe we have other questions for us to reflect on, Andrea?
Yes, there is plenty of. Now the questions that got the most voted, they referred to the REACH revision. There is one for the DG Environment and one for everyone. And for DG Environment, we had how do they plan to incorporate the milestones for animal-free assessment for chemicals with the REACH revision. And then there was a question on a similar topic that was, are you worried that the NAM-based information requirements at low tonnage bands could lead to more animal studies because we are able to do better screening of these low volume tonnage substances?
Andrea, I know, Cristina, you said you didn't want to talk extensively about the REACH revision, but I guess it's unavoidable. So
it is avoidable because you are going to get a full presentation on it. I think it's later this afternoon. So my colleague Katrin will tell you all about the REACH revision and how we are incorporating. And let's be clear, it's not about milestones. Our commitment to reduce animal testing. And why I say it's not the milestones, because we still don't have the roadmap, and that's what we're here for, to develop the roadmap and to agree on a roadmap that then we can embrace in the Commission and we can present as such. So so we have taken our commitment seriously, and when looking at the revision of the information requirements in REACH, try to, as far as possible, replace some of the existing animal testing. And as I said, I want to have a spoiler for you. Katrin will tell you all about it this afternoon.
Any reflections on the lower tonnage that Andrea was raising?
Yeah, sorry, I didn't capture it because I was trying to read it, but then it was not showing.
Is whether you are worried that NAM-based information requirement for low tonnage substances may lead, in fact, to more animal testing because we will be able to better screen the hazard of these substances.
I don't think the verb would be worried. I mean, if we can obtain more information about the hazards of the chemicals in lower tonnages, produced or imported in lower tonnages, I would consider this a good thing. So for me, the verb will not be worried. Maybe others will be worried that actually we are doing more. We are doing some animal studies because the NAM screening has identified this is necessary. But for me as a regulator, I would be quite happy with that result because it would allow me to better achieve a higher level of protection of human health and environment.
Want to Chantal?
Yeah, I agree here. Eventually, the purpose also of REACH and of multiple stakeholders is adequate protection of human health and the environment. So if combined NUMS and exposure show that there is an actual risk, then you need to make sure that you adequately assess that. And that is what we are here supposed to do, to protect men and the environment.
Yeah. Any reflection from Julia?
I'd say in terms of triggering additional responses, additional testing, yes, it is a concern because it is a concern how NUMS may be used. And that's something that we need to think about early on, is making sure we can use NUMS to make a classification decision so that we have the appropriate data derived from those methods, so then we can stop. And we don't need to do further testing because, like I say, NAMs really should be a tool that allows us to make decisions for protective purposes. They're not really designed to be just pure screening tools, to just carry on further down that line. So again, it's that shift of thinking of what NAMs are and how are they actually used.
Thanks. I don't see anyone waiting by the microphones, but maybe now to start engaging with the audience here, I think Sylvie from CEFIC has a question.
Good morning. Yeah, Sylvie Lemoine from CEFIC. A question, maybe it's extending a bit the scope of the discussion, but I still see it linked to regulation. Part of you want regulatory, yes, we all want a protective system, faster regulation. Part of it is substitution and innovation. When you invent new chemicals, it starts on a computer. It's in a lab. It's long before you place on the market and you reach the 1 ton, right? It's long before we have all the data to classify and so on. And I tend to see a huge potential for NAMs, and it's probably more in silico, maybe AI, maybe one day we do ChatGPT based regulatory compliance. I don't know. But I see a lot that happens before we even enter REACH. And I don't see this being discussed, but it's part of avoiding regrettable substitution. And I tell you, no one wants to spend time on chemicals where you find a problem later, including industry. If there's the potential to do things faster, to use the REACH database that we have now to improve, AI-based whatever, I'm sure we can model the molecular biology of humans, whatever, with all these IT. And I miss a little bit that dimension. We talk a lot about regulatory compliance. We have polymer registration coming, and we're talking REACH revision. We're going to need a lot of that even before we start checking compliance at the level of ECHA. So I'd like to hear a bit whether you see this first as a potential, and second, how to integrate this pre-REACH stage in the long-term roadmap. Thanks.
Thank you, Sylvie. Interesting industry suggesting regulatory decisions based on AI. I think Ofelia touched upon this briefly before, on this safe by design very early stages. So maybe, Ofelia, you can elaborate on this.
Well, this is very nice, Sylvie, that you brought it, because I was talking during the break with Hans and others exactly about this topic. I think we have generated data over the past 10, 12 years, and we should make better use of that data to exploit the possibilities for using QSARs, for using NUMS, how we could extrapolate the conclusions. And we have also done a few other side projects, not part of the regulation, but maybe some of you are aware that with the help of the colleagues and also with some partners, we put all FDA data on pharmaceuticals in the Euclid format. And this is also to help making comparison between the human relevance and the animal data. Also, you may be aware that this is more for Cristina about the common data platform. This approach to integrate the data on chemicals and having it in one place, this would help also the the partners, the research, to make use of that data and eventually contribute to further reduction. Yeah, so it's a very important point. It's very close to our heart, because this is one of our priorities, to make data available, to increase the use of the and reuse of the information that it's already available.
So I'm also quite grateful that you brought it up, Sylvie. I did mention in my presentation that the future is reuse of data, interoperability of data. So that's why I said eventually everybody will need to get there. Otherwise, the difference will be too outstanding. And I also mentioned safe and sustainable by design. We want to have better chemicals in the market in the future, and I really hope that the NAMs can help in this process, and can even through this screening and predictability at an earlier stage, drive the innovation into a certain direction, so we can make all these decisions at an early stage, when in the drawing virtual, obviously, drawing board of these chemicals. No, so indeed it's a very important aspect, and for us fundamental of our long-term vision for chemicals, as also established, in the chemicals strategy. So indeed, thank you.
Maybe I can ask also Patience whether she has any reflections. I think this data availability also has quite an important international component. Patience, anything to share here?
Yeah, thank you. Thanks for the question. Yeah, certainly, as many may be aware, the JRC have just started a project in collaboration with OECD on the use of academic data. And part of that project, we hope to have an OECD harmonized template for the data extraction from, for example, literature reviews that's compatible with the IUCLID database format. So really, I mean, I think part of what we're thinking about, and what was maybe already touched upon, is how to make sure that all of the OECD tools are interoperable. So not only having the data formats that were mentioned just previously and in the talk that I gave, and I'm sure in other talks coming forward, having those compatible with the IUCLID format, having QSAR toolbox being able to be an analytical tool for that database, but also having interoperability with things like the AOP framework, so we can easily take those available data and build predictive models from that. So this is something from, really cradle to grave in terms of chemical management, from the earliest stages, being able to predict chemical effects based on having just a wealth of data that works well together. So I think that's really a goal for OECD. Ultimately, it's one of the sort of pillars, if you will, of creating a forum to make sure that regulatory data are shareable, compatible, and hopefully, have the electronic tools widely available, so not only regulators, but also other stakeholders can use that information readily.
A very clear enabler for process, this data availability and interoperability. Very interesting. Any other questions here in the audience? Yes.
Hi, I'm Matt Dent from Unilever. Ofelia, I was really interested in your comments about cooperation internationally, and you mentioned the APCRA project in your slides. And I was just interested what ECHA had learned as part of that collaboration, how that might be able to help us with the transition to an animal-free future.
Thank you.
You will hear more from my colleagues in the upcoming presentations on particular projects that we run through this platform. What we have learned, it's also having a better understanding of the different regulatory needs, and also how NAMs are used for prioritization, and what is the potential then for the hazard assessment. There have been some very interesting projects on making the bridge between what we see now in terms of adverse effects, how we could make a parallel comparison between studies done with animal testing and the potential for replacement with NAMs. And again, it's not one-to-one replacement. We know that the regulatory decisions are based on certain level of approximation of some uncertainty factors that are considered to enable taking decisions. And that's why we don't look for, in these projects, we don't look for one-to-one replacement. I think it has been mentioned. With the skin sensitization, we see somehow a cap for this one-to-one replacement, and we need to rethink on how we address the long-term effects. And then this is what we work together with the partners from Canada and the US EPA, and then also with some sister agencies in the APCRA. Of course, the regulatory frameworks are different, and this is also an element that needs to be put in the context. But we learned that there is potential for working together and then making progress. And as said, you will hear more concrete from my colleagues in the presentations later today and then tomorrow.
Let's take more questions from the audience. I think there is a little queue.
Queue, Hello, Matthias Herzler from BFR in Germany. I have a question maybe both to Cristina and Ofelia, because my observation is if you look at the research landscape on NAMs and on the contribution that the authorities provide, on the member state level, it's mostly those authorities who in their statutory laws also have the remit of doing science or initiating science. Also, we have EFSA, who have in their statutory law such a mandate, and they are very prominently present, maybe not so much research on their own, but initiating research. So my question to Cristina would be, are there thoughts in the Commission to provide also ECHA with a comparable mandate, maybe in the context of now revising ECHA's foundation law? And to Ofelia, what would she think about such a mandate? Thank you.
To give the mandate to ECHA to do the research.
Not necessarily perform research, but being able to initiate research, such as EFSA, for instance, does.
You're referring to the possibility that was given to EFSA with the amendment of the food legislation. Mm-hmm. And this is something that we have looked into. And in particular, when we were looking into the proposals that are going to come out, in particular, one of the proposals that is coming out now, one substance, one assessment. So we have given it to some thought, but I cannot spoil what is going to come out of the open because we are now undergoing into service consultation. Thanks. So we have given it some thought. Yeah.
Thank you.
From our side, I think we have already engaged closer with the research. We are collaborating very closely with PARC, which is, you may know, the big scientific project which aims to bring science closer to the regulatory needs. And then one of the topics that we propose there to better steer the research is related to NAMs development, how we could influence that the scientists would work for those areas that would be useful for the regulators in the shorter term. And of course, with our minimum resources available, we try to make a difference also in how we use the data, how we engage also with the consultants, with the partners that could eventually move on with these ideas.
It was actually about raising those minimum resources, not about criticizing all the good things that you do with them. Thank you.
Thank you. I think I'm going to take one more from here and then we turn to the other microphone. So if you can go ahead, please.
Right, Pekka Kohonen, Karolinska Institute, Sweden. So due to shared pathways of toxicity and things like that, it might be easier to predict the point of departure concentration or the protective concentration rather than the specific effect at the organism level from in vitro data. So is that something that regulators would be okay with if we can just give the point of departure, and then maybe some sort of a range of possible outcomes? Would that still work?
I can try to respond, and maybe Cristina could complement. As you know, the decisions are not taken by individuals, are not taken by ECHA, not even by the Commission. There is the large consultation of all stakeholders before everything moves forward. And I already mentioned during my presentation that it depends on what decisions we are talking about and in which context. In the context of the classification for the higher tier endpoints, we are bound by the adversity. So you cannot request RUC to make a decision that a chemical is reproductive based on the point of departure, because this is not specified in the CLP GHS rules. Having said that, this is a direction that we are all willing to consider moving forward, how we could go into that type of decision. But again, this would require discussions, agreement, regulatory acceptance, and not from the regulatory side, but rather of the wider community of stakeholders.
I don't know if Cristina. Yes, very good. So maybe we turn to the lady on the microphone.
Oh, thank you. Helene Lone from the European Environmental Bureau. And first of all, I would like to thank all the panelists for the very interesting presentations. You're really paving the way for the transition to non-animal tests. And we, of course, support it very much because it can improve protection of the environment and human health while reducing the need for animal tests. My question is a little bit related to the previous point. A prerequisite for a successful transition to non-animal testing is that reliable NAMs are available that are accepted by authorities for hazard identification and risk management. And in that sense, I found it very interesting that Julia Baines said that the use of NAMs should not trigger further animal testing, and NAMs should be used for classification. And indeed, we can get a lot of information, mechanistic information, bioactivity from NAMs. And my question to you is, do you have concrete proposals how we can advance on using NAMs as basis for classification?
I would say a good direction to go is, as Patience was describing earlier, is looking at the defined approaches and looking as well at integrating more IATAs. And there are various case studies going on at the OECD that is looking at very substance-specific approaches for using the NAMs and then being able to make appropriate decisions based on them. So yes, sometimes it's substance specific in terms of what we're doing. Sometimes you need to look at what is all of the wider type of data that we can take as evidence. We talk about the weight of evidence approaches, but yeah, there's definitely ways in which it can be done, in which it already has been done. And I think it is going more into looking at the different case studies, understanding that data, and then working with the regulators to make sure it's accepted as well. Because we hear about mutual acceptance of data, we look at MAD, and that is a very, very important point. So I do think some of the work that is going on at the OECD is fantastic, and we need to see more of it.
I wonder whether Patience wants to also build on this reference to the fantastic OECD.
Yeah, great, thank you. Who says no to that, right? Yeah, no, I think the point about the IATA Case Studies project being a great place to start, it was well taken, and thank you for the promotion. I'd like to point out that the defined approaches for skin sensitization actually did start in that program, and they were IATAs before they were defined approaches, and then defined approaches and now a test guideline. So I think that's very much what we hope to be one of the possible paths to build NAMs that are covered by NAMs used in combination, most likely, that are covered by mutual acceptance of data. And I'd just like to point out that OECD published a call to its stakeholders in November of 2022 asking for IATAs that address carcinogenicity So we've had 2 submitted this year. We're hoping to have a number submitted in the next several years. And for example, these will be NAMs that address a much more complex endpoint. So the idea is to build a number of different examples of NAM approaches for human carcinogenicity to reflect on those, how they could be used by different regulatory authorities, where the strengths and limitations might be. And hopefully, if we get a sufficient number of examples and have some experience to reflect upon, have some guidance on that. We see this as sort of various milestones moving those approaches along to hopefully eventually define approaches and test guidelines in the future. And it's just one example, but this is really what we hope to be kind of the evolution and collaboration between the IATA Case Studies Project and the Test Guidelines Program.
Thanks, Patience. I think very important development there. We take one more question from the audience, and then I will turn to the online again.
So it's Costanza Rovida from ECOPA and CAT Europe. And my question is about risk assessment, because we have talked a lot about hazard characterization this morning, but just a little bit on risk assessment. Just Julia mentioned very quickly the next generation risk assessment. And my question, and it's also related to that question about the derivation of NARS. I am worried about the REACH revision that will request CSA for Annex XI substances. And at the moment, the only way to do it is through the NARS, and NARS are derived from in vivo tests. So the question is whether you are planning or doing something, some guidance to being able to derive at NEL, or call it another way, to perform a risk assessment without doing a new in vivo tests.
Thanks, Constanza. I guess that's for Cristina.
I'm really hoping that Katrin will cover this in the presentation this afternoon. I can tell you that we are looking in the REACH revision about including the chemical safety assessment and documented in a chemical safety report for the low tonnages. We're also looking at what kind of information we need to accompany with in the Annex VII information requirements, so to have a proper and meaningful chemical safety assessment. Because if we are not going to be able to have the information that will lead to a chemical safety assessment, then the question is why we're asking for the chemical safety assessment. So indeed, that's part of the REACH revision. And on the guidance on the scenarios, and that's rather for ECHA than for me. And I don't know to what extent Katrin will also throw some light on this afternoon.
Maybe we can refer to the afternoon to go deeper in this. Thank you. Let's take one question from the online, Andrea and Doris, before we go back to the audience, if that's okay.
Yes, so there is a question about grouping. And the question is, could you please give one concrete example where the prioritization grouping done by ECHA has effectively reduced or avoided animal testing? So far, it seems that the system is being used only to trigger animal testing to confirm hazards.
Yeah, this is a very good question. I'm not going into the naming and shaming. I think there are examples that can be given. But what I would recommend is that you could have a look at the information on the assessment of regulatory needs on the ECHA website, and also on this integrated regulatory strategy reports, where you will find particular examples where we propose moving forward, for example, in terms of harmonized classification for groups of substances, although not all data may be available in the respective group. But based on the data that is there, we come to a conclusion that there is sufficient evidence to enable classification. You could say that this is the harsh measure. There are also cases where, based on the data available, we consider that we know enough and we don't need to request further information, although all the substances in the group may not have the full data set. but it's sufficient to give confidence that there are no adverse effects, maybe, and then we could say these substances do not need to be prioritized for further work by authorities. Such examples are very visible on the ECHA website, and then also are given in the report on the integrated regulatory strategy. So it's very transparent and easy to find.
Thanks, Ofelia. I think I'm gonna go to that side, if that's okay.
Okay.
Your question, please.
I'm Vera Rogiers, co-chair of the SCCS, Scientific Committee of Consumer Safety. So we are concerned with cosmetics, that is clear. And I know that here it's about REACH and it is go further industrial chemicals. But when I hear here talking about confidence, having confidence to put it into the legislation, I wonder, when we talk of cosmetic ingredients, we have there also Regulation 1223 2009. And there seems to be enough confidence because local toxicity is inscribed in the legislation. We use local toxicity, dermal absorption, genotoxicity, mutagenicity, and that is written into the legislation. Why is there then a problem? Is then cosmetics, is that then good enough? The alternative methods, are they good enough to be used for cosmetic ingredients and not for industrial chemicals? For me, that is not something that I can easily accept. So I think that when there is confidence for one type of cosmetic ingredients, for one type of chemicals, because cosmetic ingredients are chemicals. So where is then the obligation that these, which we have validated methods, which are OECD recognized, are not in? Obliged, not voluntarily.
Thank you. I think very clear question. I wonder who of the panelists would like to share some reflections on the approach that has been taken by cosmetics as compared to industrial chemicals.
Okay, I would fully agree. Absolutely, I'd say we need to give her a job within ECHA, because I think, but essentially, I think one of the key concerns that we've always had with the REACH revisions and through proposals through the chemical strategies that we might lose the expertise of the SCCS, and they are experts in knowing how to apply and use the data derived from new approach methodologies. And I would say it's essential that we maintain that expertise regardless of where it sits. We need that independent overview of the experts who know how to use the data.
Thank you very much. But in fact, you know our concern that we are taken up in ECHA, it will be like that, okay, fine, but we want to be an independent committee because it is as independent and not taken up in whatever existing and not in the RAC. So we want to be an independent committee. And then there is, of course, collaboration and so on possible. And we are busy with the NGRA and so on, because it is saying we should have a transition to NGRA. But where is the practical example of NGRA? So this comes from the cosmetic industry. And so I'm not of the industry, but you see that I defend it because I think you have to think very carefully with these general rules that you imply. Because when we probably will talk about the MAF as well. But if you have a MAF of 5, which I hear circulating, then you lose half of your preservatives. And what is then going to be the consequence? We will have a lot of contact allergy because the list becomes so small. And then you have a problem for human health. So I think one should clearly, and I understand that is the REACH and it is more about industrial, but don't forget, by having rules which take everything and putting in an easy way of going forward, that you forget we have in Europe the safest cosmetics of the world. The rest of the world is following it, and you see it also with Mokra and so on. It is all going towards the European way. Don't lose that way of what we have built up, that expertise, and that's the only thing I want to make you aware of. And I know it is saying there is the vertical legislation and so on. So, okay, cosmetics is one small one and so on. But this is something I would like to put attention on. Thank you.
I want to react also to what Julia said, because actually, if you follow the logic of the one substance, one assessment, and without making this now a new discussion about cosmetics and the wonders of how cosmetics legislation achieves a high level of human safety, but not environmental safety, that is achieved through REACH. Let me just react to what you said. The whole idea of integrating the SCCS into ECHA through the one substance, one assessment approach is to actually be able to better exploit that extensive knowledge that they have on how to do risk assessment, relying on non-animal data. So for me, this is the best example of how to take expertise and expand it for the industrial chemicals, rather than lose it or keep it isolated as it is today. So this is the real objective of it. And then we go into whether we will achieve this by keeping it as a separate committee, only with an ECHA secretariat. But that's a different discussion and not the discussion that we are having today.
Thank you, Cristina. I think clear. Thank you for your patience. Now, question from the gentleman here.
Yeah. Hello, I'm Giel Hendricks from Toxis, and we're actually a developer of NAMs. I have a question to Chantal, maybe to the rest of the panel as well. So if we are involved in any discussions on implementation of NAMs, I think the number one question we always get is, has the assay been validated? Whatever that means, typically means that you compare to animal studies, and then if there's disconcordance, then typically the result is, okay, so the NAM doesn't really work. In your presentation, Chantal, you said that we should rethink the way that we validate new approach methods and how we can maybe improve the way that we get new technologies adopted. And so maybe you can comment on that, what you meant with we should change the way that we validate, because I see that it's a typical question that ends the development of new NAMs and looking for their application is, has it been validated? And then it ends. So maybe you can share your thoughts.
Yeah, thank you for the question. I think first and for all, most of those methods are indeed already used internally in many industries, pre-marketing. So to get some internal pointers in the development pipeline for new chemicals, where you allow more flexibility and you get all the information that you can get. And if you can get early pointers from a NAM, we will take it, because that will help us to provide more sustainable chemicals. So I think that's already one thing. If you look at the validation, you also look at against what benchmark, because a lot of it is benchmarked against the animal test. And there we looked at the word cloud. So what is the benefit of the NAM? It's human relevance. So we need to rethink in how we validate it, because also the processes for validation in the OECD, they take time. It was already alluded to by patients. It took a long time in the development before we had also the skin and eye corrosion validated. And if you look at the amount of NAMs needed in those batteries, we can't validate for the next 50 years. We need to really start using them. So it is the benchmark and the time. So that's why we need to rethink the system.
Thank you. I wonder if Patience wants to react briefly on the validation topic.
Yeah, great. Thank you very much. I know João is speaking this afternoon, so I don't want to steal any of his thunder, and I'm sure he's going to talk in more detail. But I'd just like to say that OECD is definitely thinking about how to modernize the validation process. My colleague Anne Gormelon, who runs the test guidelines program, is there in attendance, so she can talk more about this at the break. But I'd like to highlight that the first of a number of planned workshops was held in December of 2022, talking about modernizing validation. And it really covered a number of these topics of how does OECD want to consider validation of a battery of in vitro assays, none of which are intended to be standalone. I don't think we have the answers right now, but we certainly are thinking along the same lines, and there's an active discussion on this. We're engaging expertise from all of our stakeholders, and this will be an iterative discussion, but there's also an intention to update what's often referred to as the Validation Bible, which is Guidance Document 34, talking about the harmonization of international test guidelines. So João will speak to that this afternoon, but great to hear the topic come up, and definitely something that's on the forefront in the OECD discussions.
Thank you very much. Thanks for that. I think as we enter in the last 5 minutes, I'm going to have to ask the colleagues asking the questions to keep it very brief, and also the panelists. So maybe you can proceed.
Thank you. I'm Minne Heringa from Reckitt. We apply in vitro assays even before validation. But I think validation is a key thing here, as also in the new method that Chantal was mentioning, but still it requires investment even in that new approach, I think. So a question I also posed in the chat box is, who is going to invest? Because I have noticed that is sometimes the bottleneck. Nobody has the real sole benefit. So who will do the sole investment? And I think that should be part of the roadmap. And I was wondering if that has been considered in the roadmaps.
Very good, and thank you for already bringing some of the questions from the online. Any reflections on funding? And I think there are already a number of programs set for channeling some support into these areas. So I don't know if any of the panelists wants to bring some of the existing ones as examples.
I'd like to, at least some of the consideration is, of course, that this is a joint effort. There's a lot of European programs already had, like the Risk Hunter and others. So this is really a joint effort. It can't be one company, one industry, or one academia, or one CRO. It needs to be really a joint effort where we all pull up together and spend time, resources, and funding in it.
Yeah, one comment on those. Most of the research or the programs of the EU, the projects, they only last 4 or 5 years. Lots of validation strategy or efforts, they take 10 years, 8 years, something like this. So that should be a consideration in these projects then as well.
Thank you. Very clear point. Taken note. A question, please.
Hi, João Barroso from the JRC. Since my name has been mentioned a few times and we're discussing about validation, and I'll be presenting about it this afternoon, but I thought I should make a comment here. I'm not sure if validation is really the problem here. We can certainly evolve validation, and I'll discuss it this afternoon, but I don't think that alone will solve the issues we have today in terms of acceptance and implementation of NEMs in a regulatory context. Looking back, I think validation has worked well so far. It has served the purpose. It has been fit for purpose all the time. I mean, if you look at skin sensitization, when we conducted a study, I mean, we did a short, study that was not really assessing relevance, because we always considered this would need to be done in an integrative context, as was done for the DAs afterwards. As we approach more complex endpoints, of course, we need to look at new strategies. But it's evolving. It's a scientific process. It's evolving along the way. To put all the burden on validation and continue stating that validation is the bottleneck for acceptance is wrong, in my opinion. It's two different processes. You may have really properly validated methods and still take 10 years to get acceptance of a method in a regulatory context. And I think we need to split the two discussions, right? And just a comment from my side. Thanks.
Thank you for bringing that perspective. I'm sure we will continue discussing on this later in the workshop. So I'm going to take a last question here from the audience and perhaps a quick look at the online before we break for lunch.
Thank you. Miriam Jacobs from the UK Health Security Agency. I just wanted to comment with and support the last speakers. Validation is critical. Validation is really critical, and it's very expensive to do. So we've heard from some of the speakers this morning that it's cheap and easy to develop new approach methods, and validated new approach methods are really important, because many of the new approach methods that are not validated, that haven't been demonstrated to be robust and reliable, are not reproducible. And that's the reality that happens in the validation process. Many test methods fail. There's a big failure rate, and we don't get to hear about those. Those are not published, and they fail. They don't work. And they don't work for a lot of different reasons, and they need to be optimized further. And that's why it takes a long time, very often. And to make it more efficient, it's a question of resources and financial resources and support for validation to speed it all up. That's what's really needed, not to cut corners in the validation process. The whole process is essential for ensuring regulatory acceptance. Without that, it won't really happen. It really is about putting resources into the whole validation process to make it a reality. Thank you.
Thank you. support on this. Clear. I don't know if there is any quick reaction. If not to this comment, Chantal.
I mean, quickly support it. Again, there we have trialed a few because you really would like to make progress. And yes, you also see once you start to stress test a few nums that you reach the domain edges of validity where they just simply don't work or don't predict as you would hope to. So there is indeed a lot of failures, and it is really a pity that it's not being published as much as it should. Because I also see that people would like to present and publish working methods, and there's not a whole lot of uptake on negative results and on failing methods, and there should be actually a home for it. And perhaps this is also another advocate for a science panel that can really help us in assessing what NAMs could be used and which ones still need a bit more research or are failing.
Yeah, thanks. I think
just a quick reaction on that. I mean, we hear a lot of stress being put on the validation steps itself, but I think, in fact, in the last years, we've also seen very interesting developments with regards to pre-validation steps. And I have here in mind, for instance, the French PETA platform, exactly to accompany this validation process and maybe more invest in those pre-validation steps and how do we get there and how do we get those test methods ready to actually pass the test once we get to the validation step. So again, yeah, I wouldn't focus so much on the end stage, but rather think about how do we get the different actors involved, including academics, geared towards a regulatory acceptance process that they don't know well and actually could benefit training from and learn from.
Okay, I think I'm going to see if patients would like to have any last contribution to the discussion before we close.
Just to note, to follow along the last intervention, part of, I think, the JRC work under OECD on academic data is exactly that, reaching out to the researchers in the developmental phase to try to prepare them better. And I couldn't agree more that the more preliminary work that can be done in terms of standardizing things like protocols and having some of the transferability issues worked out, having reference chemicals worked out before they're proposed as OECD test guidelines really accelerates the process. And part of the academic work is not just looking retrospectively at scientific publications and extracting the data, but also looking at those who are in the research process, who are developing methods that are intended for regulatory uptake, hopefully, and preparing them accordingly so they get better buy-in early. So I just agree with what's said and I wanted to expand a little bit on that.
Thank you, Patience. I think we have reached the end of this morning session. I think we will break for lunch now and be back in 1 hour. So at 1:30 here Helsinki time. Lunch will be served in the canteen. I think you just need to show your badge at the end of the line. Please, may I ask everyone to observe the time to be back because we have quite a number of meetings today going on and we want to keep a bit the people flow smooth. We'll be back for a new session on more opportunities to use NAMs. And please join me in thanking not only the panelists, but also all of you for the active participation. Thank you very much.
come on, take a seat. There are still places. Hello, everyone. It's my pleasure to welcome you to the second session of today's. My name is Katia Lacasse. I'm from CEFIC, the European Chemical Industry Council, and it's my pleasure to moderate the second session where we have been asking the speakers to focus on what can be done in the current regulatory systems. And our first speaker will be Elisabet Berggren, Deputy Head of Unit at the Joint Research Center at the European Commission. I've been told that Elisabet started already at the European Commission back in 2096 at the European Chemicals Bureau. And when you took over your current unit back in 2009, you have been hosting also there the European Union Reference Lab for Alternatives to Animal Testing, ECVAM, that is established under the Directive on the Protection of Animals Used for Scientific Purpose. So we are looking forward to your presentation now.
Okay, thank you very much. And thank you for the opportunity to come here and speak. And even more than so, I'm very happy to be here because it's such a good atmosphere with a lot of discussions, a lot of things to talk about. So I'm looking forward to the rest of the day and also tomorrow. I am going to speak about the challenges in regulatory endpoints and the opportunities and the problems of applying new approach methods, avoiding animal testing. And first here I look at the endpoints as they are defined under the CLP classification criteria because that is the basis for all the EU chemicals legislation. So the physical hazards, the physical properties are not that we don't use any animals. And as you heard earlier in the morning, the non-systemic effects, it was Ofelia that was talking about them, they are replaced with NAMs. And actually also acute toxicity, we feel quite comfortable that they can be replaced by NAMs. Instead, the environment and the systemic long-term toxicity, they don't have any sort of solutions for not using only NAMs, at least if you are using the sort of international accepted guidelines. And we have written this paper I cite down here where you see an overview of this and the different methods for the different endpoints. Now I'm concentrating on the systemic health hazards, even if a similar reasoning could be done also for the environment. So if you look at the bubbles, the bubbles are representing the different classes for systemic hazard toxicity, and the number in each big bubble is the number of chemicals that are harmonized classified under the CLP regulation for this hazard. And if you look at the small bubbles within the big bubbles, then it is like this, that these are the ones that are exclusively classified for just this endpoint. So you see, there is quite a large overlap between the different systemic hazard classes. And this is because there are a lot of underlying mechanisms that are in common for systemic toxicity. And by the way, it's also a little bit underestimated, actually, the overlap between the classes, because of course in the classification and labeling it's not always that you have had enough data to classify sufficient to classify in a certain class. So there are challenging of understanding the overlaps and the common mechanism. And we published also a paper on that from the GRC that is cited here a couple of years ago, and there we were looking at the cancerogenicity as an endpoint. And just a couple of weeks ago, we also came out with this report on the mechanistic analysis of repeated dose toxicity studies, where we look at this underlying mechanism. So the question that arises is basically, do we need smarter classes? I mean, perhaps we should look at the mechanism behind and not the adverse effect to be sort of more efficient. And as it has already been told in the morning several times, a problem is, of course, that the EU legislation on chemicals is not sort of fitted for NAMs. So you run in a problem straight away. You try to fit this little square with a hole, a round hole, and this thing. But we were leading one of the actions under the chemicals strategy for sustainability, and that was the one to suggest extended information requirements for the impact assessment. And we run into a lot of problems. Katrin after me will tell more about the details, and I just would like to sort of in my discussion say that often the NAMs were not sufficiently validated or standardized, because in the legal text you would like an OECD test guideline. And perhaps that is something to reflect on, and I know that João will reflect on it later in this session, so you come back to that problem later. But then we also this morning talked about that there is the perception that this is less safe in NAMs. It's the higher uncertainty. And therefore, they are triggering additional testing of animals rather than reduce the animal testing, which is rather disappointing when you try to include more NAMs. So we started to take out the NAMs again because we just saw that they were triggering additional animal testing. And then it was also another problem, of course, and that is that the classification and labeling criteria as set up by CLP and GHS today for the systemic health hazards as well as for the environment, they are based on a criteria on animal testing. And of course, that also need to progress, but as today, I mean, it's not a sort of fast solution. So we are already in an era where we are close to the REACH revision now, and we can assume that it will come into force. We will have extended information requirements. We will have hopefully some additional NAMs, and perhaps we will also get rid of some animal studies. But still, it is something that is running on, and there will be about 14,000 registered chemicals that are in the scope of the extended information requirement. And then they will slowly start to then be checked, and you will evaluate them, and they will be fed in to the risk management of under REACH and also on the harmonized classification and labeling. So we assume that that will take a little bit of time, of course. So it will be like perhaps 20 years or so. And then we could come up to something like perhaps 14,000 assessed chemicals if it's done fast. And I put 15,000 here because we have a chemicals legislation also including pesticides and biocides, and they will also continue to work meanwhile. But the iceberg we already see this morning, this very but let's embrace the iceberg. That is my message. So let's see what we can do about this. We know now we have this problem, we have to do something about it. So what do? We try to design a future regulatory system that is based on NAMs. So they should then be applicable to all substances on the market and provide equivalent protection as today. And this is something that is important because we believe that we should keep the conclusions from the classification and labeling we have done so far. And you have to think about it. It has been a long story, and it is not sort of an exact science, even we want to believe it. It's a lot of different type of data behind the conclusions we have made in the years. But we assume that we were not completely wrong, and that is good, isn't it? But we want to do it better, and we want to go for all chemicals. So we want to make the same decisions as now. That was not very progressive to say, but it is the idea. You make the same decision, but perhaps not the same prediction. You don't look perhaps for the adverse outcome. You perhaps don't even try to mimic the adverse outcome. Today, we believe that we have three classes of chemicals, basically. We have those that are chemicals of high concern, and those are the ones that are banned or severely restricted, typically classified in category 1 for CMRs and STOT. And then we have the hazardous chemicals that we are sort of in some way restricting. Perhaps we put concentration limits, perhaps we decide or evaluate them for certain uses that we are authorized and so on. So we need to do them, we handle them in some way. And then we have the vast majority of the chemicals that are presumed actually to be non-hazardous. And there we use used it as an innovative space, and we use them without restriction. So we suggest a new system that is only based on NAMs. And on the x-axis, you see we are looking at the activity, that is sort of the toxicodynamics. You predict, you see that a molecule has a certain action in the biological system. And on the other axis, you have the potential systemic availability. You consider also the ADME properties, but also that based on NAMs. And then you can divide them into different concerns. Of course, something that is persistent in your tissue cell system, and you can see activity is something that is of high concern. And then you will have those where you don't see anything and they get metabolized and so on, and there will be of low concern perhaps. And the thing is that we will calibrate this system with the current system. So the substances that are assumed to be considered red today will continue to be red, more or less, and the orange one equally. And the green one, we compare, calibrate the system with those that we have data on today, but we consider of low concern. And then in this way, we will manage to capture some more of the chemicals in the green area, some that actually would be considered as of high concern or hazardous. So we then have an overall higher level of protection. And then we will have done something about all the other chemicals. The idea is that we have a system that is rather light, and that, of course, these orange chemicals can be further tested, also using NAMs. But the green ones will be tested. And then you have some idea how you can sort of use them in the future. Because besides identifying those with concern, we hope to identify low concern chemicals. And that would support the replacement of the most of the hazardous chemicals, and they could also be used to support the sustainable by design. And we hope that this is something that we can do in parallel to what is happening under the current legislation. And then we will manage to develop such a system. We will also get sort of see if we can have confidence in this system And we assume that we were not completely wrong. So we assume that actually the ones that have already been prioritized have a larger amount of red and orange chemicals, while the ones that we are in the green zone, we actually will find out that we have quite a few chemicals that are of low concern and that we can sort of push to use more. And so when I am now talking about all this in this session, it is because we are not going, this is not perhaps a future system, but we are going to do something about it now. So we will start to think about it, and we are going to launch today the EPAA NAM Designathon. And this is an initiative by EPAA, and we invite the submission of NAM-based solution to form a future classification system for systemic health hazards. And you are all invited to provide your own solutions and to participate in this. There will be no winning solution, and that seems very sort of, oh no, that I will not do. But that is because we are realistic, and we believe that we need to compare and contrast different solutions. We need to co-create. And we are going to co-create something together, and together with all participants in the Designathon. So this is the launch. In early July, we will provide you with some orientation webinars if you're interested. The 1st of August is the registration deadline, and then we will provide you with 150 chemicals that you should try to beam into the 3 boxes of red, orange, and green substances. And you will have the time until the 31st of December. The important thing is the hypothesis, the solution, the ideas, not necessarily testing everything, but you send us a proposal, and early next year we will discuss this together. And you are very welcome to participate, and thank you very much for the attention.
Thank you very much, Elisabet, for this forward-looking and also the very nice project. So take your pen, start to think, bring ideas. It's my pleasure now to introduce Katrin Schutte. Katrin is Policy Officer at the European Commission DG Environment. On the unit of sustainable chemicals, her responsibility covers several aspects of REACH, mainly registration and evaluation, and as well as the implementation of directive on the protection of animals used for scientific purposes. She is also a member in the steering committee of the European Partnership for Alternatives Approaches to Animal Testing, and co-chairs there several very interesting EPA project teams. It's my pleasure, Katrin, now to give you the floor and let us answer. I understood some of the very popular questions from this morning in the Slido.
Thanks very much, Katja, and thanks a lot for the invitation to speak here. And I'm happy to try and address the question how the Commission is planning to give NAMs a place in the REACH revision and in the revision of the standard information requirements. The slide is not showing what it should be showing. What we try to do with the strategy is to increase information requirements for low tonnages and to allow to identify most harmful substances, among those also endocrine disruptors. From the onset, that undertaking seemed to be challenging enough, because we also have to try and do this, if possible, by the use of NAMs, such as not to increase animal testing further. And of course, speaking of low tonnage substances, we wanted to continue to take proportionality considerations into account. In the following slides, I will try to give you a glimpse of how we plan to amend the information requirements, but I must add a disclaimer that this is a work in progress and this is not yet the final Commission proposal that we will submit and that will be adopted, so it is the current thinking. We're planning to increase information requirements at Annex VII, mostly via the use of NAMs. We were hoping, as Elisabet already alluded to, that acute endpoints could be dealt with NAMs in the future. So the acute toxicity in Annex VII, we are hoping could be replaced by the combination of in vitro cytotoxicity and a specific QSAR, the CATMOS model. Then we are planning to introduce NAM methods to address the gap on toxicokinetic and ADME information that we have for a lot of chemicals through the 3 assays that are depicted here in the slide. And the idea with these assays is that we would use the data to facilitate read across or to have more information how chemicals could be grouped or could be how similarities could be demonstrated. So there is no concrete classification in mind with the introduction of these assays. And then there's another group of in vitro assays that we are proposing for the identification of ED properties for both human health and the environment. These 4 in vitro assays, they are checking for the different pathways of endocrine mode of action. Going further about increasing information requirements for low tonnages, it was already alluded to that we also consider to require a chemical safety assessment for low tonnage substances. And we already talked about the fact that a chemical safety assessment ideally then should be meaningful. So if we want that, then we need to address the current information gap that we have on low tonnage substances, that we do not have repeated dose toxicity nor screening information on reproductive or developmental toxicity on these substances. Unfortunately, we consider that there are no NAMs available for regulatory use yet in this area. So we're currently considering to use the combined study OECD TG422 also for low tonnage substances. However, again, the proportionality considerations come into play. We were wondering whether we could limit the amount of testing there to substances that have sufficient half-life in the body to at all be conceivably exerting such hazards. So we could potentially do that by considering waiving opportunities for this requirement in case a substance does not have sufficiently long half-life, and we have not yet arrived at a final solution how to do that, but there could be waiving options in terms of the physical chemical properties. For example, if the log KOW is above a certain cutoff. Perhaps we could also use the in vitro toxicokinetic data that I just explained in the previous slide to predict the substance's properties, or we could use in silico predictions. Several people already asked how about NAMs for the environment, at least in the Slido. I saw some questions passing. Indeed, there we are hoping to introduce the in vitro methods, either the in vitro cytotoxicity or the fish embryo toxicity method as a replacement for the short-term fish tox test. And we are hoping to increase the information at the lowest tonnage level by bringing down the invertebrate Daphnia long-term tox test to Annex VII already. Staying with the environment for a second, together with our expert colleagues from the JRC, we came up with the suggestion that probably also the bioaccumulation endpoint could be replaced by NAM approaches, either by the in vitro test methods that you see depicted here, together with a in vitro in vivo extrapolation modeling, or the bioaccumulation test in invertebrates, the Hialela azteca test. But you have also heard already that for the identification of endocrine disruptors, we don't consider us currently in a place yet where we could predict these hazardous properties or adverse effects in an organism on the basis of NAM methods only. So we have to consider how we could follow up positive NAM results with in vivo testing to confirm the mechanistic effect and to confirm adversity in an organism. The assays that you see depicted here in the slides are the ones that we are considering for introduction in the REACH annexes. Currently, we have not yet arrived at a final proposal at which annex level they would be required. But some of them we believe we cannot do without. And for the low tonnage substances, there are probably some waivers or triggers under discussion. Again, like I explained for the combined study earlier, that we perhaps try to limit the testing to those substances that have sufficiently long half-life to exert this kind of toxicity. So now I mentioned about a lot of data requirements that would appear to look like increased burden. For that reason, we are also considering some deletions or some amendments of current information requirements under the consideration that some may actually do with an update to scientific progress. And we also simply, from a political angle, want to balance the additional information with maybe deletion of requirements, some of which may not, in fact, be fulfilled that often currently anyway. So the acute oral toxicity in rats, the dermal and inhalation toxicity, the irritation and irritation tests, we believe could be removed. Likewise, the assessment of toxicokinetic behavior. We are also considering that longer-term studies beyond the 90-day study or the 12-month study could be removed. Another example that the previous speaker already alluded to was the second species prenatal developmental toxicity study. Could perhaps be removed. And also in the discussion is the carcinogenicity study in Annex 10 today. This has a question mark because we haven't taken a final decision yet within the Commission, and I don't want to dwell on it too much here, but there are proposals made towards us how one could perhaps also do without the study and still arrive at a reliable conclusion for carcinogenicity. However, we do acknowledge that for non-genotoxic carcinogens, this is still a big challenge today. So we have also shared this larger overview to the members of Caracal at the end of March. And a month later, we got some feedback from the members of Caracal. And when I had a look at the feedback from the different parties submitted, I rather felt like this, stuck between a rock and a hard place. So why is that? And hopefully we can together identify a way how we can come out of this situation there again. I just can try to give you a high level of the concerns raised here. This is not complete, and maybe it does not do exact justice to all of the comments, but I still felt I need to try and summarize the dilemma somehow. On the one side, several member states and health protection NGOs were expressing reluctance or objection to replacing in vivo methods, even the in vivo methods for skin and eye irritation or for acute attacks that are not used very often anymore. Several commented that OECD standardization of NAMs is an absolute prerequisite before mandating them. On other methods, there was a lack of confidence expressed in NAMs, even if, for example, for the CATMOS model publications clearly demonstrated very good predictivity. There were comments raised that we can't change REACH at all before UHN GHS criteria haven't changed. I think we have all heard how long we would then need to wait if we really wait for that. And another concern raised was that NAMs can indicate the presence but not the absence of hazard. Well, definitely that we would need to change, at least that perception. On the other side, animal welfare NGOs and large parts of industry support the NAMs that we have proposed. They would also propose the deletions of the in vivo tests, and some came forward to us with concrete approaches how we could use weight of evidence to cover an endpoint. And some do not support all the in vivo tests that we propose for the ID identification. So it is really not that easy to deal with such opposing comments. Some considerations that I would like to offer for the moment. As we saw, or as we can see in the new Article 117.3 report that was published, the change of a regulatory requirement toward NAM is one of the strongest drivers for their use. So the amount of in vitro tests for irritation and sensitization has really drastically increased after the changes in 2016 and 17. And then to give another example from another area, under the pharmaceuticals legislation, pyrogenicity testing for vaccines and other biological medical products is required. In vitro methods are around and are listed in the European Pharmacopoeia since 2010, but the use of the in vitro method has really only really taken up since the EDQM announced that the in vivo test would be deleted from the Pharmacopoeia. I also personally think that we have to start somewhere, and we have to somehow try and live with uncertainty, or try other ways how to address it and deal with it. We are aware that some in vitro or other NAM methods still have applicability domain issues, but maybe they can get addressed, or other solutions to them can be found once a NAM method is mandated. Several methods, and depending on their uses, we could perhaps use them if they are sufficiently standardized and have not yet reached quite the level of an OECD technical guideline yet. We also firmly believe that laboratory capacity will increase as soon as it becomes clear that a certain test will be mandated in the future. And we were considering that adaptations will continue to be possible under REACH. So maybe we need to reverse the picture. Right now, it is such that any animal testing requirement can be adapted to have registrants propose an alternative. If we make a NAM method the default requirement, we should probably keep the door open to also still allow the use of a in vivo method. But then the last resort argumentation should really be documented in a testing proposal, or in the other way around. If ECHA considers the in vivo data are really needed, then specific argumentation could be given in the evaluation decision. I wanted to add here that with the revision, we are also considering that the testing proposal route should be required for all studies that involve the use of animals, or at least higher amount of animals. So that will be another change that we are considering. And I'm moving to my last slide here. I was asked to also inform you whether or not we are planning to change the Annex 11 about adaptations. We do, and we are trying to meet here a dual ambition to first incentivize more use of more NAMs for adaptations than what is done today. And at the same time, we would hope to come up with a new text that increases legal clarity as to what an adaptation needs to provide. So we aim in the legal text, which I cannot yet give away completely because it is not yet finalized, but we aim to describe how an adaptation can provide an equivalent predictive capacity to that information that you would normally obtain from the study require. And then endpoint per endpoint, there's probably more guidance that would need to be developed on the side of ECHA. We intend to spell out what really characterizes a valid in vitro method or a valid defined approach. And we need to, of course, recall that the results shall still be adequate for the purpose of classification and risk assessment. And as we mentioned already several times this morning, we need to, in this context, start to agree how we can classify based on NAM information. So after these changes, I mean, there will be just some changes that we're doing with the REACH revision right now. What we do not intend to change is the obligation for the Commission to adapt the REACH annexes to technical progress whenever that is possible and required. So this will not be the last revision, and hopefully future revisions are possible at much shorter intervals than between 2017 and now. So in that context, we are very happy to work together with all of you on the roadmap that we already mentioned several times. And we indeed strongly believe that we need to work together collaboratively to identify the critical needs necessary for that transition. Thank you.
Thank you very much, Katrin. A lot of very interesting ideas. We will have really a very interesting panel and for sure 2 very interesting days today. Our next speaker is Tomasz Sobanski. Tomasz is the leader for alternatives methods at the European Chemical Agency. He is working at ECHA for over 14 years. Focusing on the development and the application of alternatives methods in the regulatory process. And before becoming what I'm tempted to call the Lord of the NAMs at ECHA, he has been project manager already on the OECD QSA toolbox, and those of you knowing how important that work was will get credit for that. And in recent years, he focuses more on the NAMs and their application in the regulatory science. So looking forward to your contribution, Tomasz.
Oh my goodness. Lord of the NAMs. I think it might be a bit too heavy burden to bear, but I will try not to disappoint you, at least not to big extent. So what I'm gonna talk about this afternoon is we've been to try to identify those critical needs, those which in previous sessions they were indicated that maybe we should finally think about those critical needs and start to focusing our resources and our attempts to cover them. And then I will try to as well share with you some of our ideas how we can on the short and medium term try to cover how to progress towards an animal-free system. So starting point, I think morning session, we've been talking about it a lot. I don't want to repeat it. You've heard a lot about horizontal system, how classification is important. And this focusing the problem formulation around this is very important because NAM discussion will be quite different whether we are talking about sectoral legislations like cosmetics or whether we are talking about horizontal system like REACH or CLP. So that's why we are trying really to focus your attention on this horizontal system. And we have to remember about those key 3 pillars of the system. Very clear hazard classes, which for some reasons have been considered as a very important for our society. Clear classification criteria related to them. Standard information requirements, which meant to provide outcome, which could be used to judge whether chemical is of concern or not, and global harmonization. So if you are thinking about it, then the first question is, okay, so what we can do about it? So our proposed approach is based on 3 simple steps. First, define your problem. Second, demonstrate already whenever it's possible that it can work. And finally, consider or redesign, if needed, the current system. So no other, so basically we don't want to start with redesigning because we are not sure how to redesign. Let's start from what we have. Let's concretely formulate the problem. I think we did it already quite well during our morning session and in the previous presentation. We can now discuss how we can demonstrate that it works and then think based on this experience after some time what we can change and how to better adopt the regulatory system to better accommodate for NAMs. And then I've heard this question this morning, okay, ECHA, you are involved in so many different research projects, initiatives, you are doing many different things, what you've learned for it. And one of the things which we learn is that basically if you are trying to imagine animal-free system, so try to imagine we need to make all our decisions without any animal testing, no triggering, no second tier, nothing. We have just NAMs. And try to imagine, okay, then try to think about some key needs which we need to have, regardless of endpoint, which we need to cover to be able to do this. And then we come up with those three main elements. The first is hazard identification. So basically, we've heard quite many times today, NAMs are good to trigger further concern. They are not good for confirming safety. And we are saying, no, if you want to have a system which is working without animals, we need to be able to conclude on safety without using animals. There is no triggering. So basically, the first thing which needs to happen is we need to come up with the NAM battery, which is able to distinguish between whether we have even toxicological property or not. Can we already put this substance to the safe basket, like on Elisabet's presentation, or we need to do something further? Once this first step is done, the second step, okay, then once we know that there is something going on, there is some hazard, it's good to identify the hazard because different hazards have different generic risk management, have a different consequences. So we need, as a second step, needs to be able to characterize the hazard. What is the severity of it? And what is the level of it, because we need it for risk assessment and as well for generic risk management measures. So this is the second step. And finally, we are not informing our stakeholders about the hazard with using nominal concentration from in vitro system. If you will say to the workers, you shouldn't you shouldn't be exposed more than 100 micromolar. I don't think he will get it. What he wants to know is what is the real dose in the milligram of kilogram per kilogram of body weight. So basically, we need to be able to translate our NAM metrics for characterizing the hazard to the external doses, which we use to communicate and manage the hazard and the risk. And this is not trivial. I will tell you later on, we will talk about it later. So those are our three basic needs, and we believe that those needs are quite universal, regardless whether you are talking about repeated dose toxicity, cancerogenicity, or repro. They are more or less universal here. Then, okay, second step, demonstrate. Here we see there are different opportunities for different type of endpoints. For the lower tier endpoints, those simpler endpoints, we have already, for many of them, we have already in vitro alternatives, like we mentioned skin sensitization, irritation, corrosion. But we have others for which we believe as well QSARs can be very good approach. So basically we are saying, let's try to especially revise and better develop QSARs already now for those we see they are, for those lower tier endpoints arena. And then for the higher tier endpoints, we are thinking about this is the intermediate now for next few to 10 years solutions is introducing the omics measurements to already ongoing in vivo studies, which we are doing anyway. And the second is to better utilize NAM to support read across and grouping. I will come to more details later on. And then step 3, as I mentioned already, once we will gain the confidence, once we will understand what we need in this future system, then think about redesigning the system. And of course, here we have few topics which have been already brought before me, but we can already start to think about it. We need to think how to derive reference values for risk assessment from molecular data, not from observed adversity. This will be the challenge. How to calibrate the system that we are not overprotective, but as well we are not missing too many chemicals. Then how to then revise the classification criteria to be harmonized with those changes of thinking. And then we should think about the throughput and performance as well, because as Elisabet showed us, we have quite many chemicals to assess still. So, okay, so those were the needs, and this is our idea in 3 steps, what concretely we have in mind. And of course, we could say, look, guys, fine, I told you what we need. We can sit, wait another 10 years, you will come with proposals, we'll do something about it. But we prefer to propose something now. And let's start with this first reliable in silico methods. Another learning which we have over those years of operating REACH is that, talking about valid models is good, but it is not enough. It is not enough to know that model is good and predictive well in 70% of cases. Because if you have your chemical on the table when you need to assess the hazard of this chemical, you want to know whether this particular prediction for this particular chemical is reliable and relevant or not. So we fairly quickly come up to the conclusion that on the top of the validity principles of the model, we need to come up the new principles for relevance and reliability of the predictions. And thanks to OECD and our colleagues from Instituto Superiore di Sanità and our colleagues from ECHA, we started this project, it was 2 years ago, Andrea? 2 years ago, we started this project to develop this QSAR assessment framework, which is really trying to address this issue. And in addition to revised criteria for model validity, we as well trying to put some clear and criteria for the prediction validity so that everybody, model developer, model applier, registrants will know whether his prediction for his molecule is valid and can be used or not. So this is the first practical step. And I hope after publication of QAF, we'll see the uptake of this methodology by model developers, and as well as then it will be progressive acceptance of those predictions. Then omics enhanced in vivo studies. I think it will be quite controversial. There are quite many people here which will say that's not a good idea. This is a step back and maybe, but I want to tell you, we don't have, and Cristina mentioned this morning, the most important thing is the confidence. When certain methodology reach confidence, then everything goes easier. At the moment, looking at the comments which you've seen from Caracal, which Katrin was sharing, we don't yet reach this confidence. We are not ready for animal-free systemic toxicity methods. We can wait another 10 years. We can do something now. So idea is to basically start to incorporating the mechanistic and omics measurements into the already test guidances which have been already developed. Why? There are few main reasons. First, it is useful as well to develop NAM methodology for the future. So it is not only to stop and doing nothing. No, it is to learn more. Because if you are thinking about systemic toxicity, when there are multiple things to cover, and you will see on Mounir's presentation, for example, how many things we are trying to cover for repeated dose, you have this impression, we have too many questions and we don't know how to answer them. Because you need to think about, okay, how those biologicals, how I can demonstrate that my biological in vitro system is relevant to cover whole biology, which I want to cover in my endpoint. You need to derive reference values on something else than adversity, because you are not observing any adversity there. You need to think about IVIV, how I will do it. For many substances, actually for 70% of, when we've been doing this APCA prospective case study with US EPA, we realized that at least for 35% of substances, we have problem even in running basic IVIV assays to do the proper IVIV. So already we have a problem with 35% of substance and we need to do something about it. And then we need to calibrate the system, as we mentioned before, to be not over predictive, but it's as well do not be not protective enough. So doing this already on in vivo system at least eliminates some unknown from the equations. There are multiple reasons, and this is not only allowing us to move forward and to do the refinement, but as well allowing us to better understand how changes at the molecular level corresponds to adversity, because we will have the same test system when we are observing both adversity, molecular changes. It allows us to learn a lot and gain this confidence, which we are so much missing in our discussions. Finally, so potential for 3 Rs. I think there are quite obvious reasons why there is reduction, refinement, and replacement potential. I mentioned some of them, but just to mention a few more. We can have a shorter test duration. There are multiple examples from different key stakeholders which are showing that doing omics measurements, you can observe the same effects much earlier. You don't need to wait 90 days. You don't need to wait 2 years to see something which you can at the molecular level observe much earlier. This reducing pain and stress. We can as well, trying to regulate based on molecular data, we are introducing more objective criteria for deriving reference doses. It is not anymore expert judgment whether something is dose related or not, which you can dismiss or not. You have a result, you have an interpretation, and you know what is your reference value. Already this will probably reduce uncertainty of the study dramatically. Then reduction. We are trying to reuse as much as possible existing tests and existing samples. If you are thinking about that current high volume chemical, which basically the data set costs over 1 million, what you will learn at the end, you will learn that for this particular chemical, you have or you don't have reproductive effects, cancerogenicity, mutagenicity, and reproductive toxicity effect. This is what you will learn, but you will not learn why, and you will not be able, most probably without any additional data, to extrapolate this knowledge to other chemicals. So trying to preserve the samples from those studies to reuse them to generate molecular data might change this situation in the future. Replace we discussed already. The next practical element, difficult to test substance, I mentioned already. Industrial chemicals are not agrochemicals, are not drugs. They are not meant, they are not designed to be bioactive. Quite many of them are not. And we have a lot of practical problems in trying to test them in vitro. And I think those guys which are here with in vitro experience know what I'm talking about. So anyway, even in the beautiful future, we need to think how to deal with those substances we won't be able to test and for which we will not be able to predict. I don't want to elaborate now on because I don't have time for it, but basically I want to pass you the message that even for that reason, we should think about solution, how to deal with those substances, because we will always have them. And then now for grouping and read across. Since 5-6 years, we have this vibe in our community. Yeah, NAMs are great for read across and grouping. That's probably true. But without putting clear criteria, what it means actually, which kind of NAMs we are talking about, from which biological model they have been generated, and how to interpret those data, and how to build your hypothesis, you will not be able to, this will be always weight of evidence, case-by-case assessment, and it will not help us on the longer term. So here we are saying, yes, NAMs are great for read across and grouping, but we need to come up with jointly agreed criteria, how those information can support decision making. And yeah, to conclude, I hope that I put a bit more light on what we think about the key needs, the key blockers, and what are our short-term solutions. I'm not gonna discuss long-term solutions because this is for tomorrow, but I can only as well echo the statements from the morning. We need to do it together. There is no job for one party. It's not only for developers. It's not only for regulators. It's not only for OECD or the Commission. We need to do it together. And with that, I would like to thank you.
Thank you, Tomasz. You're all still there. Yes. So our last contribution is actually a theme that has already been touched upon this morning, which is validation. And I have the pleasure to welcome João Barroso from the Joint Research Center, where he's working on the European Union Reference Lab for Alternatives to Animal Testing, ECVAM, and where João also coordinates and conducts scientific and policy support activities in the area of non-animal methods, including the identification and assessment of promising methodologies and biomedical application, as well as their translation into EU legislation. I've been interested also to hearing that you have been or are still working at ESAC, a scientific advisory committee of the European Commission that is responsible for conducting independent scientific reviews on non-animal methods and approaches. And indeed, let's hear a bit. What are your thoughts about validation?
So thank you so much for the kind introduction, and it's really an honor to be here today to present about the elephant in the room, validation. It's a kind of interesting and boring topic for me at the same time. I've been working on it for quite some years now, but every time it circles back to this. So okay. So there you go. So the Guidance Document 34, OECD GD 34, has been a key document in facilitating the validation and international acceptance of methods since its publication in 2005. It defines universal principles of validation, but it also describes the process on how to implement these principles in a kind of one-size-fits-all way, because this was defined and accepted more than 20 years ago when NAMs or non-animal methods were seeing their early days, and most people were actually focusing on standalone full replacement methods. But things have changed a lot since then. Independently of that, GD 34 is still a very important document, and it's undeniable that it has helped a lot the implementation of non-animal methods in regulation. Still, as I said this morning, I do believe that validation is really not the biggest problem we have in terms of acceptance of NAMs in regulatory decision-making. We can certainly evolve validation processes, make it more efficient, adaptable to new technologies, but we will not solve the problems of acceptance and implementation and use by just focusing on improving validation. In any case, I would say that the principles of validation described in GD 34 are universal and still valid today. However, the process for validation and international acceptance described in GD 34 no longer reflects current state of the art. Toxicological science has evolved tremendously, and so has the number and types of methodologies we see today. So depending on the context of use and the type of NAM you're validating, you may actually use different processes to achieve scientific confidence. So I think there is a widespread recognition that a revision of these processes is actually required to encourage timely update of fit-for-purpose and robust NAMs. And I'm happy to say that the European Commission, together with the United States and the Netherlands, will be leading the revision of GD 34 at OECD level in the next couple of years. The project was just approved in April in Paris this year. So there have been several frameworks for establishing scientific confidence in NAMs published in recent years. One that I particularly like, also because I'm a co-author on it together with colleagues from the PETA Science International Consortium, several US agencies and the OECD, is this one you see here. This framework presents an updated vision on how to implement universal principles of validation to establish scientific confidence in new approach methodologies in a flexible way. It proposes 5 key elements that you can see on the slide, and I'll be describing and discussing shortly each one of them in my presentation. So ensuring data integrity and transparency is really important in validation studies. And according to GD 34, validation studies should actually be following the principles of GLP, of good laboratory practices. This was actually not done so much in the past, at least not full GLP implementation, but the principles were somewhat followed. But GLP studies were not generally used in validation studies. But this was never seen as a problem because in the past, studies were mostly coordinated by independent parties like ECVAM, who would coordinate most validation studies together with other partners across the globe. But of course, we want to increase the efficiency of validation. We want to decentralize. We don't want to have just a few bodies across the world focusing on validation. We want method developers to be able to validate their own methods. But the problem is that we're now seeing a lot of validation studies being managed by commercial parties who have direct interests on the methods. And in those cases, the trustworthiness of the study and the integrity of data become questionable. So it is actually quite important to demonstrate the integrity and credibility of the results, from the raw data throughout to the final report by implementing independent quality assurance in all steps from data acquisition, transferring, and processing. And this is quite important to be done even before you submit those data for peer review or for regulatory consideration. So independent scientific review is another important element of the scientific framework I just presented to you. The appropriate level of external review depends on the NAM and its intended use and should be decided on an ad hoc basis. This might include a simple publication in a peer-reviewed journal or a review by an independent panel of experts who have not been involved in the development and validation of the method and who have no professional or financial interests on it. International adoption by OECD typically needs formal peer review with an independent panel of experts, and scientific peer reviews and peer review publications would not be sufficient in that particular case. Importantly, NAM developers may fund, but should obviously not manage peer review. Peer review should actually be done independently and managed independently, but it can, of course, be sponsored by the method developer. So another important element of the framework is biological relevance. So in the case of human relevance, human biological relevance can be determined by demonstrating similarities between the physiology of the test system or the biology measured by it and human biology. So NAMs that actually capture key aspects of biology or mechanistic elements and in toxicity pathways will increase scientific confidence. So where human data are available, high quality human data, concordance with human responses also helps build scientific confidence and ensuring that the NAM is relevant. And the accuracy of NAMs to predict human data should be equal or better than the accuracy of animal tests to predict the same human data. And that's a more fair comparison than just comparing, NAM results with animal results. Unfortunately, this is not always possible, but for instance, in the case of skin sensitization, that was successfully applied. So I'd say that establishing biological relevance of an NAM can be used to benchmark its performance instead of just relying on comparison to animal data, also considering that animals have clear inherent limitations. So fitness for purpose involves, for instance, determining which regulatory statutes are the data supposed to comply with, for instance, TOSCA, REACH, or other. It also involves determining if the information provided is sufficient to address the regulatory endpoints of interest and whether, for instance, the level of uncertainty is acceptable for the defined purpose. It involves defining how the method will be used, for instance, as a standalone, as part of a defined approach, as part of IATA or weight of evidence assessment, because that also will define the process that you will apply for validation. And finally, also the context in which the method is intended to be used. For instance, regulatory screening, prioritization, chemical grouping, hazard identification or characterization, and even quantitative risk assessment. And I think we will all agree that depending on that intended use, the requirements for validation will change. So here's another version of the iceberg. Now, here it's focusing on methods rather than chemicals, but I've put it here to make the point that, you know, there is a lot of NAMs available in scientific literature, but only a small fraction of those ever become international standards or are used in a regulatory context. So, you know, what can we do to increase confidence on all those tools that we have available in scientific literature? And, you know, one possible way to increase the usage of these tools that we have available today is, for instance, to focus on their technical characterization, or what we call technical validation. So that is assessing technical characterization, including reproducibility and biological relevance, without having to establish regulatory application up front. And here I would, you know, like to stress the flexible nature of the framework. Assessing and establishing fitness for purpose is obviously, you know, preferentially should be assessed and determined already during method development, together, you know, in collaboration with regulators and industry. But it may not always be possible to define it upfront in its entirety. And in that case, this should not actually be a bottleneck in the validation of the methods. And we should find ways to actually proceed with validation and even acceptance as standards, and revisit regulatory application later on when more information on this becomes available. You know, we should also then find ways to improve and accelerate the acceptance of these methods, even if they are not standalone or the regulatory application is not yet clear. You know, having standards on these methods and making sure that they are robust will probably increase their uptake and usage in case studies, in weight of evidence, which would inform afterwards the regulatory application. So I would also like to stress here that we cannot just rely on standard methods to make regulatory decisions. Information requirements based only on test guidelines will not allow for faster and better decisions. So, you know, we heard patients this morning talk about academic data. Academic data are used with other standard requirements to support information requirements and various types of assessments. And they are even essential in some regulatory decisions, like REACH registrations. In fact, 58% of the key studies used in REACH restrictions use non-standard data, are non-standard data. So, you know, independently of how much we progress or evolve validation, non-standard data will always be there. And we, you know, regulators have a duty to consider and assess those data. So beyond focusing only on evolving the validation of methods before data are generated, we also need to make sure that we develop frameworks for assessing the validity of non-standard data and increase their utility in regulatory decisions. So technical characterization as another element is also quite important to make sure that the method is robust, and it involves items like accuracy, reproducibility, transferability, applicability domain, and others. And what is considered acceptable may depend on the NAM being evaluated and its intended use. For instance, a NAM for prioritization or screening you know, may have probably higher levels of uncertainty than an NAM you would validate for implementation in a risk assessment context. The data reporting should also allow for independent evaluation of the NAM, including the protocol, the equipment, and any computational models used. So I think most of this is self-explanatory, and I'll focus only on accuracy and reproducibility in my next few slides. So GD34 talks about relevance, but a lot of the weight on relevance is put on accuracy against animal data. And while accuracy has historically been determined by comparing the results from a new method to results from animal methods, this should not be the default way to determine the relevance of a NAM. You know, most animal studies are decades old, and they've been introduced in test guidelines without rigorous validation like we implement today for NAMs. And there are a lot of you know, publications out there showing the lack of reproducibility of animal tests for multiple endpoints. So we should definitely consider this, the uncertainty that we also get from animal studies, classification from animal studies, deriving points of departure. And that level of uncertainty needs to be considered when you actually are discussing the acceptance of NAMs. So moreover, traditional animal test methods should not be assumed to provide data relevant to human biology or mechanisms of toxicity and be the right answer to determine if another method is valid. Sometimes a direct, or most of the times, a direct comparison between NAMs and animal data is probably not even relevant. So instead of focusing entirely on empirical data and comparisons, accuracy compared to animal data, I would say that accuracy can actually be demonstrated in other ways. For instance, considering consistency across NAMs. If you have multiple NAMs addressing similar mechanistic events or similar pathways, and you see concordance of results, that I think increases the confidence that your results are relevant. The ability to identify positive and negative reference chemicals that are mechanistically relevant would also increase the relevance, the assessment of relevance and your confidence that the results are relevant. And finally, greater emphasis needs to be put on biological knowledge, mechanistic relevance and reproducibility. So finally, I would like to discuss the importance of reproducibility in ring trials in validation. And I would start by saying that demonstrating reproducibility is absolutely essential. In particular, within lab reproducibility should be assessed in an early stage of the confidence building process and should be done at least in a single laboratory. However, ring trials are the most time-consuming and expensive part of a validation study. And I've coordinated several validation studies and I've assessed many others. And I would say, and I would argue, that actually between lab reproducibility is often more a reflection of laboratory quality or expertise than of an NAM's reproducibility. In fact, in validation studies, you actually quite often see that the lead laboratory is the least reproducible one, because naive laboratories were just trained and they are following the SOP really to the letter, while labs that have been using the same method for a long time tend to be more flexible and actually have less reproducible results. So, we need to understand what the question we want to answer and not just to ring trials because it's a requirement. So on the other hand, properly designed training and transfer studies are really essential and informative. They usually lead to further clarity on the protocol and they make sure that the protocol is understandable by other laboratories and is transferable. Moreover, post-validation proficiency testing, as requested by OECD test guidelines, adds confidence on the capacity of a laboratory to perform a test. So I'd say that it should be possible to actually conduct a well-designed and properly performed validation study without actually conducting ring trials, making validation easier, faster, and cheaper. I'm not arguing against ring trials all the time, but I on a case-by-case study basis, we should define when it is really required. So just to exemplify this, I've put here the results on within and between lab reproducibility for multiple validation studies conducted in the past 15 years in the areas of eye irritation and skin sensitization. And you can see that the difference between within lab reproducibility and between lab reproducibility is generally below 10%, and BLR is almost always above 80%. So I would ask, what did we gain actually? What essential information did we gain from conducting these ring trials beyond already what we gained from properly designed training and transfer studies? So I think, assessing reproducibility and transferability of the method should not be done by default, using a ring trial, and we should not focus on what we want to achieve in the first place. So the thyroid validation study that was coordinated by ECVAM is a clear example of how we've implemented the vision that I've just presented to you. in the past few slides. We validated 18 in vitro methods using 15 labs of our UNetval network in collaboration with 14 method developers. Such a study would not have been possible by using traditional validation processes and ring trials. And just to conclude, validation is essential to facilitate acceptance and ensure sound science-based decisions. Of course, validation needs to keep pace with rapid scientific progress and emergence of innovative technologies. But of course, at the same time, it is important to maintain scientific integrity, credibility, and usefulness while making this process more efficient. Validation should be framed as a process to characterize and reduce uncertainty rather than a ring trial to demonstrate toxicological equivalence. The focus should be on protecting human health and the environment rather than predicting animal methods. Where comparisons to animal data are done, it is important to characterize the human relevance and uncertainty of the reference in vivo method. And finally, I would like to finish by stating that validation is not the same as regulatory acceptance. You can have a perfect validation study and still experience a lag in regulatory acceptance. So, you know, the old vision of considering animal data as the gold standard needs to change, and information requirements also need to be adapted in order to accommodate NAMs and make best use of validation efforts. And with this, I conclude. Thanks a lot for your attention.
Thank you, João. I would like now to invite all the speakers. We will reshuffle a bit the podium, as I understand, and do a deeper dive into your presentations and look for the question of the audience and on the Slido. Yeah, you need to help me on that. Yes, well, while we are organizing ourselves. Andrea, now it's working. Andrea, maybe we indeed, I mean, the microphones are there for if there are already questions in the audience, but I would like first to ask Andrea if there are already some very popular question on the Slido. I think we see some on the screen. Please guide us a bit on that one.
Yes, thank you. Also for this afternoon, we are receiving a lot of questions on Slido. It's nice to see the audience so engaged. We have a question that has the most votes is on one-to-one replacement and says that a regulatory animal test is far from being one test. It is a very complex study involving tens to hundreds of measurements that require weight of evidence interpretation by pathologists. A non-battery with equivalent technological complexity and expert interpretation should be acceptable too.
Seems more like a statement. Is there someone that wants already to add on that? I see.
I can only agree with that. And I think this is the first realization and another learning which we learn over our journey with NAMs, that like Mike Rosenberg used to say, it's not plug and play system, that we are plugging out in vivo and plugging in one in vitro and that's everything is fine, everybody's happy. No, since already acute oral toxicity, this is not the case. You need to think about quite many different elements to make it successful. More long-term studies are even more. Mounir later on in the next session will show you how we've been trying to approach it for repeated dose toxicity. I think we integrated over 22 different assays from 8 different technological platforms. We have high throughput transcriptomics, we have high throughput phenotype profiling, IVIV, a lot of computational models, a lot of specific models trying to predict specific toxicities, and then all integrating all of this. This is not easy, and this is what I said. we are not going to validate anymore one single beautiful in vitro method which will replace an endpoint. And I think that's exactly what we need to think. And I agree, we need to demonstrate simply that those method works. And I agree as well that we need to demonstrate that having realistic expectation regarding the performance and uncertainty of already existing gold standards in brackets of in vivo. So let's keep it in mind. We are not looking for full concordance as well, because there are uncertainty and we need to take it into account, and we will.
Morris' question triggered a thought that I realized I didn't manage to cover in my presentation. For the needs of speed, for some of the replacements, I had indicated specific OECD methods that we currently envisage could replace in vivo methods. But in fact, what we plan to do, or hope to be able to do, is that we future-proof the information requirements in such a way that we would formulate the standard requirement to say in vitro cytotoxicity or acute toxicity in vitro and in silico, and then only specify in ECHA guidance which methods we currently believe are the most useful ones to apply. But in this way, if other methods become available that could equally do the job for a certain type of chemical, then we would not need to amend the column 1 requirement again, but we would only need to amend or update the guidance. So sorry that I didn't manage to cover that in the presentation earlier.
Okay, thank you for that, Katrin, because I was also thinking about that, to say that at some point. And it's very important that we are less rigid, and we assume that there will be, of course, a lot of NAM development. We already have a lot of NAMs, and they might be more or less applicable in different contexts. But also in this, that everything is complex, and we are comparing to animals, we are comparing to human, we do battery of tests and so on. I think it's important that we sort of change the mindset and divide it into different levels. What do we need to know at this stage? So, I mean, you can think about keeping a protection level. I mean, you perhaps you don't have to mimic an adverse outcome or a disease. You can have something that gives you some sort of feeling for what this compound can do. I mean, you can start with physical properties. I mean, it's already telling you a lot. And then, I mean, to a next stage, it's almost like a testing strategy then, because then at the next stage you say, okay, I know to understand this and this better, and then you build up a more complex battery. And when it comes to non-batteries, it's also like this, that you might mimic things that you never managed to mimic in the animal test, and actually the human relevance keep on to be very important in this context. So I don't know if I should say this now, but I mean, thinking also about the non-enhanced testing. Actually, if you think about, you learn a lot. It's almost a research set of mind. But if you are wanting to make a safe use for a human being, you actually don't know which is the driving underlying mechanism in the animal and in the human, and if they are the same. So you wouldn't have this relationship that is clear between the mechanism and the adverse outcome that you observe. Okay.
Well, I'll try to be short. I think the colleagues here already said most of the things that should be said. But I think Morris makes a really relevant point, and probably the difference is that in one case regulators are used to what they've been using for years, and in the other case we're talking about new frameworks that are not so different in nature, but they are new, and changing paradigms is always difficult. But I'd say that, for instance, if you look at OECD test guidelines on in vivo studies, they usually do not describe how the data should be interpreted. They describe how the data should be generated interpretation is then done elsewhere, for instance, at GHS. But when it came to NEMS, in order to get them accepted, we had to describe how the data should be interpreted already in the test guideline. That's a big change. Test guidelines should be about testing, not about decisions. And we are increasing the burden and also makes it international acceptance more difficult because the requirements are changing from country to country. And I think that's something that we really need to consider, in the acceptance process and development of new guidelines.
Losing my microphone already. May I ask those on Slido, but also when you raise question, to present yourself shortly, and also maybe say to whom you address your questions more specifically. But I see that there are meanwhile 2 people that were already waiting. I invite the lady at my left side to introduce herself.
Yes, thank you. And Fritsche, IOF Düsseldorf. So my question actually relates a little bit to Morris's, because I'm wondering why the developmental neurotoxicity in vitro battery has not really been mentioned during these talks. So I'm one of the test developers together with EFSA and the US EPA. We've been working many years as a collaborative approach supported by the JRC, of course, on that project. And listening to your talk, Joe, so the DNT in vitro battery has many of these requirements already fulfilled. There was a provisional guidance document which is now called Interim Recommendations by the OECD that went through the WNT group recently. And I think this would be just a perfect case study to be taken up by the Commission, by ECHA. Before it's becoming a data requirement, we probably need some more case studies. But I think this would be perfect because a lot of that was said this morning and also this afternoon, this in vitro battery fulfills. And well, that's my question. So where is it? Is it going to be taken into consideration? There's a lot of money, a lot of effort on both sides of the Atlantic went into this battery, and the US EPA is actually using the methods already for the regulation of their chemicals. So where are we? So that would be my question.
Thanks for the question, Ellen, and by all means, we had expected that one. And we have indeed seriously discussed about the battery, which I think is quite an impressive progress to assessing this very, very difficult endpoint that DNT is. We hope to be able to include it soon. Right now, at this stage, we felt that it is a bit premature in the sense that it is a very large battery, and we weren't very confident to ask manufacturers of, for example, low tonnage substances to ask to conduct all tests that are in the battery. While at the same time, we felt we have not sufficient guidance for example, in the form of a defined approach available to give advice on which assays to focus on. But it is certainly a set of NAMs or a NAMs package that we want to introduce as soon as we can, and maybe there is a need for another discussion on the confidence in the battery and how to apply it. But for this round, where also we have been asked to propose a targeted revision of REACH, where the introduction of a, let's say, new information requirement for DNT was maybe falling a little bit out of scope. At this point in time, we have considered it not opportune to include it. Maybe Elisabet wants to add something more to it.
No, I just wanted to acknowledge what you said, Ellen, and I absolutely agree. I didn't mention it just for lack of time. I had to focus on one, but I think that the anti-validation study is very much hand in hand with the thyroid. I think they both already implemented this kind of vision even before it was published. I think we published the obvious, to be honest. And I think, now we're entering in both cases a situation where we're starting to discuss what's enough. what more is needed. Do we need ring trials or not? And I think that's a very important discussion to be taken, because it will set, define what will be needed in the future. I think the way you actually started building confidence on the methods was the right approach. Focus first on mechanistic understanding, developing AOPs, actually choosing the methods according to their importance in the mechanistic pathways leading to DNT. The same applied to the thyroid, and then assessing, reproducibility and relevance of the battery as a whole. Obviously, it is quite important to demonstrate transferability of some of these assays, and maybe there's some more work to be done there. But going from there to actually now conducting ring trials on all the assays, I wonder if that's really of value. But
well, a ring trial won't be done. I mean, EFSA just published a call for tender on the lab, showing the lab-to-lab transferability, and I totally agree that this is important. Also, that CRO can perform the assays. I mean, that is also important. But I think it's still really unfortunate that methods that have gotten that far, I mean, we went through the comments, with this guidance document for almost 2 years. I mean, this is really a strong case. That such a strong case doesn't make it to the next step, I find really unfortunate, because it could be like a flagship. But that's my personal.
And we're only talking about the guidance document at the moment, not even test guidelines.
Yeah, of course. Well, thank you.
You want to add? No. Then we will take the next question.
Robert Landsiedel from BASF, a chemical company in Germany. And was that already too much information? I have a question regarding the list you have shown, Katrin, and there was obviously the neutral red assay for cytotoxicity and QSAR. And I wonder what that is for, having listened to Tomasz, who's just said even systemic acute toxicity is very complex. Is these two methods to replace the acute systemic toxicity testing in vivo, or is it additional data? Because in my impression, only one of you could be right.
Apologies if the slides were not clear enough, but indeed the proposal is to replace the acute test in rats.
Then, Thomas, you are wrong.
Then I will tell like this. Okay, cytotoxicity. We know that cytotoxicity assays in general are quite good at predicting baseline toxicity.
What they are not, and it's published, but we don't have.
But we don't. This was not our proposal. I can tell you what we are doing. Before already announcement of this, those changes for Annex VII, we started to investigate internally to which extent we could already think about QSARs as a column 2, because for acute oral toxicity is quite densely populated. Endpoint, we have quite nice data density there, and we start to gain the confidence that for quite many substances, it will work quite well. It is demonstrated that it works within the reproducibility of in vivo, especially that we have multiple in vivo assays for acute. So we could get from QSARs accuracy of 0.4 log unit, which is more or less the same as for experimental data. The problem is only that it will not work for all. And that's why I was referring to the QSAR assessment framework. That's why I was talking about validity of the predictions, that we can easily find out ourselves for our chemical whether we could use QSAR as a default option or not. And I hope that even without discussing whether neutral uptake is good or not for acute toxicity, I believe that in practice, majority of chemicals will be covered by QSARs. We will have problems with those which are UVCBs, which you cannot derive easily the structures, or with those which are not so densely populated. So from our perspective, this is the pragmatic proposal. We want to, and I think in a week time, Andrea, we have this session in QSAR Conference 2023, when we exactly have a specific ECHA sponsor session on that, and we will ask for the report exactly trying to cover those applicability domain, what kind of class of substances can we confidently cover already with QSARs. And this combined with QAF, I hope in practice will solve a lot of problems for acute oral toxicity already.
I tend to agree, Thomas, but I don't share then your skepticism with other endpoints. I mean, if it can be done for acute toxicity, I think same applies to other endpoints. But well, it was for clarification, and I thank for that. And I was interested in hearing.
I agree. This is the first step. We will continue with other endpoints later on.
Good.
Hello, I'm Carl Westmoreland from Unilever. I was just thinking back to this morning's discussion about the use of NAMs for consumer safety of cosmetics and kind of the role that exposure science plays in that. I mean, this afternoon's session has been necessarily focused more on the hazard side of things, but I would be really interested to understand the panel's views about the role that exposure science and understanding what people and the environment are actually exposed to plays in deciding about a chemical safety.
Who wants to take up that one first? Nobody? I will have to decide. We two.
Well, I mean, of course, exposure is always important, and you can have, but I mean, it will always be specific, and we have perhaps been very focused today, both on REACH and CLP, and you don't actually know the use. But for cosmetics, of course, you know, and it has been applied very well. I mean, the new generation risk assessment based on NAMs and making a logic, you know, the exposure from the beginning and so on, and it could be applied wider, but it will always. The problem is that it will be sort of a one case all the time. So you can do it, and you can assume that you could ask the manufacturers to do it, but it will probably not be sort of centrally done for all uses. You cannot cover it.
I guess that's one of my frustrations, really, that whenever the topic comes up, we don't know enough about it in some cases. It's really the question, what needs to be done, so that that's not always the answer, I guess. So that the answer isn't always we don't know enough about exposure. What needs to be done so that that's not always the answer?
Well, yeah, we will. I mean, for the defense, you always believe that the manufacturer will know the exposure scenarios that they are doing. So perhaps, I mean, somewhere, I mean, we should perhaps trust that they do what they should do. I don't know. I mean, how you solve it in another way, Katrin?
What I could add is that as part of our revision, we are also planning to make the text in Annex 6 a bit more concrete, that more use and exposure information should be added to the dossier. But for the current situation, we are faced with the problem that the use information in the dossiers, of which the majority of them are joint submissions, is mixed or is incomplete, and it is also due to the simple nature of how companies need to operate. Several uses or exposures are changing because the use of substances are changing. So in the current system, at least how we have it, it is very difficult to rely on the use information because at least currently ECHA can never be sure whether it's correct or whether it is complete. I know myself from my past that if you do an assessment and you can arrive at a safe exposure, then you tend to document the maximum that you can support, while that might not be the realistic exposure that is actually occurring. So probably we would have to rethink about the system, how this information is provided, and how to deal with it in our current system that is based on joint submissions.
Can I? You want to go first?
Just to finish this exposure story, and you know, on the top of everything else, for chemical industry, not necessarily producer know all his exposures. And I think if we have colleagues here from BAS or other big companies, if you will ask them honestly, do you know how your chemicals are used? They will tell you, no, we don't, because there are many different reasons why. But you can say, okay, yes, but look at the Americans, what they are doing. They are developing expocasts, huge investment, huge efforts, trying to predict the exposure patterns of different chemicals, irrespective of the, informations from the producer. And what we see on those exposure predictions for for industrial chemicals. Average uncertainty of those predictions for generic population is 7 orders of magnitude. So try to, and if you think about toxicological space, which is 3 orders of magnitude, maximum 4 if you are very lucky, we have still 3 orders of magnitude uncertainty. How you want to deal with that? So this is another practical consideration. And now I will.
No, I just wanted to say, building on what Tomasz was saying, what we hear is usually it's difficult to predict external exposure from multiple sectors. Although I know companies try to gather information also from other applications of the chemical and try to predict external exposure also from other exposures from other types of products. But maybe the solution is more or less in what Elisabet presented, shifting to a classification system that considers internal exposure rather than external exposure and kinetics. And you start, classifying based not only on dynamics, but also kinetics. And if we start doing that, then, external exposure becomes a bit less important. In any case, colleagues from ECHA always say that exposure is considered already with the tonnage levels. Whether that is enough or not, that's discussable.
Yes, indeed, the exposure discussion is probably not the last one we will have. I would like to invite the next question.
Good afternoon, and my name is Anne Gourmelon. I'm from the OECD, managing the test guidelines program. And thank you very much for all these very interesting presentations and discussions this afternoon and this morning. I'd like to come back to the topic of validation and the human relevance, demonstrating human relevance in the absence most of the cases of human data for complex endpoints, systemic endpoints, because we don't have access to such data. I was wondering if anyone has an idea, in the absence currently of such human data, how we can go about demonstrating actually that the NAMs are better protective and that they are more human relevant, as we need at some point to do the validation and, as you suggested, João, use some reference chemicals and determine whether the NAMs are concordant throughout time and between labs about showing what is positive, what is negative, because currently those positive and negatives are mostly based on animal data. So is there an idea how we could get access to more human data? Is it possible? Does anyone have idea how we could have such access to human data?
Just quick answer. We started already doing it in practice by trying to, as it was mentioned by Ofelia this morning, we are transfer all the data published by FDA, the public data from human trials and animal data for the same drugs into the rich format and publishing them out. So this will be the first layer of information when you can get grasp on concordance. Of course, we have to remember that toxicological studies slightly different than clinical trial. We are not doing histopath slices after our patients, right? We are not assessing toxicity in such a way. But there are ways of doing this concordance, but we need to keep in mind that there is, of course, we need to remember that they are different for the different purposes as well. And I would like to talk more that we have to keep in mind that very often we are hearing lack of concordance for animal data. This is mainly if you are thinking about fully predictivity of your medical effect within very narrow dosing range for your drug. But actually, from the safety perspective, there are not so many failures. It's of course there are those accidents, but they are not so protective. Value of animal data is not so bad. Its predictive values may be a bit problematic, but protective value is quite good, I think. And we have to keep it in mind. Probably now I put the stick to the ant nest. Let's see.
Yeah.
Oh, yeah.
No, and I agree with that, with the protection, and that is what we came from. I mean, this that you try to keep the protection, because I think that we are quite well protected. But for the human data, of course, you can also look at epidemiological data or clinical data. There are sources. We have the human biomonitoring and so on. So we start to get a view that is a little bit different. I mean, these type of studies used to be quite, interpretable. I mean, you couldn't really rely on them, but we are now having almost always more and more sort of, it is really on a population level. So you start to get to understand something more. And it's not just like in just one factory site and so on. So I think that we can look into human data and understand better the human relevance from this.
And I would like to add, and I think it's a good point, and the colleagues already said where human data may be found, but human data will always be scarce in a way, and sometimes also highly variable, high uncertainty sometimes as well. And I would say that, we should not commit the error of continue to focus only on empirical comparisons. I think we should have a framework that combines both empirical data and knowledge. Biological knowledge, there will always be gaps there. But you have, the AOP program at OECD trying to compile knowledge into interpretable tools that can help, assess that relevance. And we have to start giving more weight to this, to the biological knowledge. We're starting to use also test systems that are developed based on human tissues, human cells, more complexity on those test systems, being able to capture more biology, and understanding those models and being able to explain why they are relevant should be, a process at least as good as empirical data and comparisons into demonstrating relevance. So I really think that we also need to have a shift in mentality, because if we're expecting to have always human data to be able to prove relevance, we're going the wrong way.
It was not just about the relevance. We talked about the protection, the level of protection. And if we want to trust the negative also, we need to be sure that we are on target and that we are not, missing the negatives with the NAMs we have. Yeah.
True, but we also have tools like omics, metabolomics, toxicogenomics. And we can use both targeted and non-targeted approaches when we don't know so much about the potential risks of a substance. And we have to make use of those tools to start also building more knowledge and trusting those results, rather than just, expecting to know everything about biology. In certain cases, I think companies probably will know enough about the mechanisms of toxicity and whether they need to apply a targeted approach. And probably, some tools will be sufficient for that. When you have non-targeted approaches and you just look at, toxicogenomics data, probably you would, with a certain level of uncertainty, be able to make a prediction. And those levels of uncertainty probably are actually not so different from the uncertainty you get from repeat studies in traditional animal methods. The differences in points of departures from repeated studies probably are as different as you have from NAMs compared to those traditional studies. So, if we're expecting to know about everything about biology before we are able to make decisions on negatives, we'll never get there.
Later on.
It's okay. I mean,
you will continue.
No, I was just thinking about this with negative data. I mean, at some point we have to stop also to test everything forever and ever. Yeah. So I mean, it's a little bit about the iceberg again. I mean, if we are not going to know everything about everything. So sometimes we have to accept that, and perhaps trust also negative data. And I mean, I don't know how to come around it, and I don't know how many times I have discussed it, but it's something with a mindset that we have to have the courage, and we never did know everything. So why don't we take the step and trust also negative data?
And we have another question on the screen, actually, that is very persistent. That is actually the opposite, but I think related to that one, which is the positive case. And more specifically here, indeed, whether additional testing there should always be triggered on the trigger. So who wants to answer that one? It's the first question on the screen. I don't know if you all have the same on the screen. Looking to Katrin, you are the...
Sounds like it's a question about the information requirements for ED, so I'll give it a shot. Indeed, it is planned to have the in vitro tests mandated at Annex VII level. And then we consider that definitely for substances that are also marketed at higher tonnages from Annex VIII or higher, a positive in vitro should lead to confirmation in the animal test. Weight of evidence considerations will probably still play a role. Definitely they will do so for the low tonnage substances for which we have not yet reached agreement to what extent in vivo follow-up at the lowest tonnage level should be required or not. So indeed, we are trying to come up with a proposal that would avoid thousands of animal tests on the basis of just one positive in vitro ED assay. But for those that are positive and that are marketed at higher tonnages, I can confirm that we do want to follow up in vivo.
And maybe to add, if we will be lucky and we'll have as well toxicokinetic extension of the rich annexes, maybe we will be able to reduce the number of false positives by taking into account as well toxicokinetic and systemic exposure considerations. So this is our hope. JRC had the proposal demonstrating on few cases this indeed is the way forward. So might be that if we'll take into account both, it won't be so bad in terms of oversensitivity to be seen.
I cannot remember who was the one. I think it was you, Matthew.
Thank you, Matt Dent from Unilever. And just to apply what you were saying to the latest question that's being asked on the screen, I think if you're in the situation where you have a well-known use of that substance, because as Heli's pointed out, there will be a few chemicals for which uses are few and well-known, we could also use an opportunity for exposure to be used in that sort of assessment to make sure that we're not triggering unnecessary animal testing. And I wonder what the panel thought of that. Where uses are few and well known, and how do we justify ethically not taking that into account?
Yeah. It is a challenging question for a chemical to be used or to be regulated under REACH. I think if you were asking the question about a pesticide for which uses are few and well known, then probably a specific and substance tailored approach could be identified for that substance. As you're aware, we are not conducting such substance or use specific assessments under REACH because of the horizontal nature of the regulations that was explained at length in the morning session. So we would have to commit to adopting a change if we wanted to do that under REACH. And currently we have not seen an easy way to do so, because even for such a substance that Haley might be thinking about right now, it might well be that also that substance is part of a joint submission where other users are in that submission, and it is already administratively super complicated to apply different requirements to the same substance marketed by different actors and for different uses. Currently, we don't technically know how to apply different rules to different registrants that are bundled together in such a joint submission.
Yes, I appreciate it's complicated, and everything that we're talking about is complicated. Not using animals is complicated, and I think if there is information that we know, then we should be using it.
Someone more? No. Then I think we can go to the next question, please.
Okay, thank you very much. My name is Pia Juhl Nielsen. I'm from the Health and Environmental NGO ChemTrust. And first of all, thank you to ECHA for the initiative to arrange this workshop. And from this morning's discussion, I nearly got the impression that using NAMs for a regulatory decision is just around the corner, and we just need more validation and less conformity authorities. So therefore, I'm happy that here after lunch, you have brought more nuances into the debate. I also understand that the industry already uses a lot of NAMs in their development of new substances, and João mentioned that authorities to prefer to do what they're used to. But then I will ask, but are they the only ones? Katrin mentioned that inclusion of new in vitro test for information requirements, and we just got a question here for endocrine disruptions, but both PETA and industry are not happy with this triggering of more testing. So there's no industry representatives in the panel, and maybe I've just got the answer, but I really want to know that if you really want some transition to new methods, are industry willing to accept regulatory decisions based on in vitro assays? So that's my question. Industry is not in the panel, but is it the impression from the Commission that this is the case? Thank you.
Indeed, I'm on the panel, but I will be neutral. No, I think we basically already touched a little bit, the positive, the negative. I think it's both sides. But I would like to hear also what Katrin has to say.
I can objectively limit myself to the impressions I got from the replies or comments after the Caracal meeting at the end of March. And generally, from the comments that if I recall them correctly, from industry, there were a lot of reservations raised, whether or not a in vivo route remains still open, if it is questionable whether or not the in vitro result was correct for the type of substance. So one can interpret that as not accepting a positive NAM result, or one can read it as a question related to a real applicability domain problem, which I'm certain that those also exist for UVCBs, for metals, for many other chemicals that are tough to test. So my impression is that the acceptability of these results is not yet uniformly there.
No, so it means that if we really need this transition, then industry must also take their part in this process.
Yeah. Thank you. Maybe do the microphone.
Yeah, but I also believe that there is a lot of in vitro methods used in industry today that we can learn from and that everyone can learn from, and we would very much like to probably know more about what is used today and collect that, and that is a good idea to do in the EPA designathon, for example. And then for sure it is like this, that it might be results that not are trustworthy because it's not applicable to the substance itself and so on. But usually I think there is also knowledge about that. And perhaps that in fact should be communicated when you have such a concern as, I mean, we need to share our knowledge from all parts, of course.
This is a very valid question, quite an important one. But, you know, not everything positive should lead to a positive classification. And I give you the example, for instance, in skin sensitization, when we updated the REACH annexes before the DAs were approved, the request was for 3 key events, right? And before the DAs were approved, the interpretation of that was that all of them needed to be negative in order to accept a negative result. And one single positive assay would probably lead to a classification or would be interpreted like that. If you look at the DAs today and the way they are implemented, that's not the case anymore, because that would lead to a lot of overclassification. So if I would be on the industry side, I would certainly not accept that everything positive needs to lead to a classification or an interpretation as positive for an adverse effect. It's just that you then need to look at the integration of data, and that's not always possible up front. You need to have further evaluation case studies to understand how the data need to be interpreted. But definitely, we shouldn't consider that everything positive in a mechanistic assay should lead to classification. And I would understand industry not being very keen on going that way.
Well, I can just follow up. I agree with you, but I mean, if you don't want to have this triggering, then the result will be that then you need to accept that in vitro studies, the result of in vitro studies.
Please come closer to the microphone, unless there's someone else that wants to rebound.
I just wanted to add,
Clarify.
I think I agree. We need to have this agreement that if we are going for NAMs, we are going for NAMs for good and bad together. It's like a marriage. We are doing this and we have to decide. So, but I agree as well. But then let's do it carefully. Of course, we are starting now to implementing some single assays for the reactivity. They will be at the beginning over predictive. They will be probably a lot of debate, but it will give us an opportunity to be exposed to this data, to debate, to think, and to improve it. It was like with the cars, the first cars. Nobody would like to drive the cars 100 years ago, right? They were not very practical. But at the end, now we have quite nice ones, even electric. So there is a way, and we need to start from somewhere, and we need to start with realistic expectations. So my appeal is here, really try to think about NAMs not only as a cheap way to getting access to the market for the easy chemicals or just as an easy way to targeting further testing, but let's try to think about NAMs as a solution which is really having in mind the further full replacement. And this will probably mean a bit more things and a bit more work, but I'm pretty confident that if we will start to do it together, we'll get there.
We had the iceberg, the snow, and now the marriage. Looking forward. What are you looking for a question?
Yes,
we still have a few minutes. I mean, we will have the coffee break a bit shorter, but we thought
I'm on the side to thinking of that this marriage can cause some problems. So I am thinking in the implementation of this specific. Excuse me, I will start with introducing myself. Katarzyna Malkiewicz from the Swedish Chemicals Agency. So my reflection goes to the specific proposal of updating REACH annexes with the specific in vitro tests that at present they are lacking standardized protocols in the OECD. So the question is how we will implement this to ensure legal certainty and also technical and scientific certainty. In the REACH context, the decisions on the tests that we have been taking so far were specifically based on the standardized protocols, and even in the situations like that, we had different stakeholders, industry, different member states, ECHA's evaluation, Board of Appeal, and Commission and General Court, different stakeholders going through different processes and not being able to agree on some cases, even in the situation of standardized protocols. So how will we deal in the cases for 1,400 chemicals with very many NAMs, with no standardized protocols and so many stakeholders? That marriage can cause some troubles.
Looking for your ideas. Who wants to take the microphone? It seems, Katrin, you keep.
It did sound like a question directly addressed to the Commission, so I will make a start. If you try to remember the in vitro methods that I listed as being under consideration in the slides, Those methods for in vitro effects all have a OECD guideline. And then there was another question here on Slido why we haven't introduced any for the thyroid route of mechanism. Well, for exactly that reason, because we don't have a guideline method for them yet. The in vitro replacements for acute fish for bioaccumulation, they all have a OECD guideline. Then we are left with the methods that we have proposed to assess the toxicokinetic and ADME properties of the substances, for which I wanted to emphasize that we do not plan to base any drastic regulatory decisions like classification for category 1 on the basis of this data. It is data that is supposed to inform read across or grouping, and since we had the idea of introducing these studies to the requirements, our thinking then evolved further to also include that we could use that information to inform further in vivo follow-up testing. So there we are starting to go into more serious regulatory consequences. I'm aware of that. But between the time now and the time that these information requirements will apply, which I believe you understand the regulatory process well enough to know that they will not apply from 24 onwards, but only later. I do hope that we find sufficient agreement on how this data should be generated and how it can then be used.
Follow-up question, are you referring to the OECD process that is well established, or a new way of finding standardization of the protocols?
I was actually going to address your previous question still, if I may. I tried to actually cover that in one slide in my presentation. As I mentioned, I mean, 58% of key studies used in REACH restrictions are non-standard studies already. If you look at REC decisions, a significant percentage of studies that were considered key were not even in the ECHA registration database. They were picked up from published data, and they were not in the original registration dossier. So, I mean, that's already happening, considering, and you know, then you, as I said, probably we should focus also on developing frameworks to assess the validity of non-standard data, rather than expecting every single information source to be a standard method, because that takes time. We will always make decisions on non-standard data. That will continue, and that should be embraced, I think. But of course, we need to have ways to show that the data have quality and that the protocol can be trusted and that there are no biases in the study design, for instance. But there should be ways to guarantee that, right?
Yeah, and I think that this type of methods should be described in guidance. That would be also more easy to revise and update as science go ahead. And then you could describe them. You could also describe which type of method and what sort of performance standard you are accepting and so on. But of course, it's not the same as OECD test guidelines, because it's different status, but it could be a part of the information that you use.
So we still have 1 minute now for one more question, Sylvie. One small reaction, because it was for industry, and one suggestion. The reaction was actually on the positive in vitro, accepting the outcome. I think the core of the issue is the regulatory system, the consequences, the mandatory bans, the consequences of classification. And of course, it makes it very difficult if you have only one in vitro positive, knowing that in vitros are designed they have false positives because they are screening tests, and you end up, being regulated and banned from the market because of the generic restrictions in the future or the automatic bans. Then yes, it feels completely unfair, and so I think it's part of the confidence There's also confidence to be built in industry. If there's a second in vitro, something else that can help, yes, we should move like that. And it doesn't necessarily mean you have to confirm in vivo, but it means we need to address those cases with more elements. So it's not that black and white. I just wanted, if you allow me, to come back to uses and exposure, because it's going to be needed in the future more and more for SSBD, not only REACH, SSBD, eco-design, it's about the full life cycle. I think the honest answer, and you were right, Tomasz, sometimes we know very well, sometimes you don't know. An additive that goes in plastic, you don't know if the plastics end up in food contact or in a cable or somewhere else. A solvent for a cleaning product, you don't know what you're going to clean at the end, at the very end. That's true. But there are still, if that's essential for NAMs and it's essential for other parts of REACH, then I think we should have, or have had, or hopefully have, much more thinking about how to improve. You're right, joint CSR is an issue, but the logic behind the joint CSR and the CEF was to avoid animal testing. Right? So if you don't have animal testing, then maybe we can rethink the logic, more easily opt out. Distributors, 1/3 of the volumes of chemicals go via distributors. They don't tell us, they pass information, but they're not officially a downstream users. So we don't always have the information because at the end, producers and distributors sometimes are competitors, right? So there's an empty part of the market that we need to solve. You could use advice against more. So if you have an additive that you don't want to go into food contact, for whatever reason, you don't have the right data or you think there's a risk, okay, then you sell it for something else, but you say use advice against. I think there's really several things we can do. We should also be clear on the level of detail to be supplied in the value chain. Who starts? The downstream user, the suppliers, this ping pong. This has been going on for 10 years. And I think there's still a lot of room to improve, even in the current system. But if it's important, then we should not only talk about restricting chemicals and regulating chemicals, we should think of having better exposure information. And maybe the US way, or I don't know, exposure cast, but maybe the US way has also merit. So it's about rethink the system. That was not a question, Sylvie, that was a long. So we need really, we need now and to have a coffee break. And I would just say we continue the discussion there. And also, I mean, for those who still have the discussion, there are more panels planned, so don't hesitate. Schreiber is also there. We will collect all the questions. And for sure, I'm not promising that we will address all of them, but we will have a look to many of them. So thank you very much for my panel and my.
Last session of the day. It has been a long day, but so far very interesting presentations and discussions. And now we'll have the opportunity to dive into specific regulatory endpoints and see actually all the exploratory work that has been being done in those fields, and what are exactly the opportunities and the readiness actually of these endpoints to actually enter into the regulatory sphere. We'll hear from 6 experts in the field, and after we'll have a brief panel and question and answer moment, and then we'll have the intervention from Dr. Rusty Thomas from US EPA that will talk about moving beyond measuring adversity. While listening to our great speakers, we have launched a poll in Slido. Which endpoint would you prioritize for new approach methodology development? You can wait maybe for the end of the session to decide to put your ideas forward. Without further delay, I would like to invite you, my colleague Mounir Bouhifd. He's a member of Alternative Methods team at the Computational Assessment and Alternative Methods unit here in the agency. And his main areas of work relate to the adaptation of rich dossiers and the promotion of new approach methodologies. So the floor is yours, Mounir.
Thank you, Tiago. Good afternoon. It's my duty to bring you back and your energy to this, I hope, very interesting session. So it is really a special day, not only because ECHA is organizing this workshop and showing our efforts to enable the discussion in this very important topic, and we'll have the privilege to talk about the repeat dose toxicity, the current status, and the opportunities, and what we are doing as to implement NAMs in this very challenging endpoint. It is also a special day because just yesterday, and Ofelia mentioned it, this morning, we released the 5th report under Article 117.3 of REACH on the use of alternative to testing on animals. So this is a promotional slide, and it is the only promotional slide I have. So in this report, that is also an instrument for the promotion of alternative. We provided the current status of the REACH database, as we usually do, and we know that stakeholders are keen to see the same analysis of the data, but we added also an analysis of new registrant substances of the last 3 years. And basically, there are relatively few differences between the approaches registrants used to fulfill the information requirement in 2022 compared to the past years in 2019 and 2016 even. We also included a chapter that discusses an animal testing-free regulatory system for industrial chemicals, where we show ECHA activities on NAMs in general, and also we discuss the challenges and opportunities for replacement of animal testing. And I invite you to use the link that you have on the bottom of the screen to download the link and read the reports. Under REACH, the regulatory requirements for repeat dose toxicity are usually in vivo studies, usually in rats, and going of increasing the minimum duration. The oral route is the most common route used, and the standard information requirements are specified in REACH Annexes 8 to 10. So the information on subacute 28-day studies is needed at already Annex 8. Annex 8 is 10 to 100 tons substances that are manufactured or imported into Europe at between 10 and 100 tons per year level. At the next tonnage level, subchronic 90-day study is required. In addition, further studies may be needed at Annexes 9 and 10 to address concerns related to longer exposure duration or different routes of administration. Regarding testing, they usually refer to internationally validated methods, standardized and reliable. And those are the current standard test methods are and corresponding OECD test guidelines are usually all in vivo studies. So under the current regulatory system, these studies indicate the health hazard or the adverse effects likely to arise from repeated exposure, and these form the basis for risk characterization and classification and labeling. It is really very important to understand the objectives of those studies if we are serious about thinking how to replace those studies. So those studies provide information on the adverse effects on target organs, on the dose relationship and the threshold, the mode of action and mechanism data, and the potential cumulative effect. Regarding risk characterization, the data should allow the derivation of threshold values, low-L, no-L, BMD, benchmark doses. And for classification and labeling, the data should allow the comparison to the CLP criteria for example, STOT RE classification category 1 and 2. And also the potential of cumulative effect and the reversibility of adverse effects. And the studies might provide trigger for further information requirements. If we look at what type of information these studies generate, we can see that they generate usually more than 200 parameters like body weight, clinical observation, clinical chemistry, histopathology, hormone measurements. And it's important really to keep in mind these parameters when we consider the safety assessment of chemicals, and this is the way we are doing it now. And there were some observation in slide earlier on the fact that in vivo studies we have also an integration of different parameters. And you can imagine that a one NAM battery or one in vitro method or even combination of in vitro methods in a battery will not be able to provide all those parameters that we are talking about. Because NAMs provide a different type of information, we heard about that. And it is clear that we cannot pretend to replace one-to-one all those parameters and replace one-to-one a repeat dose toxicity study. So when considering NAMs in the current system and thinking of a replacement of in vivo repeat dose toxicity studies, an important question we would like to ask and we need to ask is what's comparable with repeat dose toxicity means when you're considering NAMs. And taking those elements that I just showed and the current system, how it is working, we can say that to demonstrate that an outcome is comparable with repeat dose toxicity or a 90-day study in the context of hazard and characterization and risk management, a NAM solution should be able to provide estimates for or reference values for NOEL and LOEL if possible, and also provide indications of concerns to trigger additional testing for specific effect like reprotox, immunotox, and so on. So this is the current status, how the system is working now. And if we're thinking of the use of NAMs, what are the fundamental questions or what are the fundamental parameters we need to consider in our thinking? Of course, this is a very, very challenging endpoint. And here, what I wanted to show is that when it comes to repeat dose toxicity, the very good review by Pistellato from Pistellato, talking about the current European regulatory requirements for the assessment of chemicals, show that for repeat dose toxicity, while we have 12 in vivo test guidelines, OECD test guidelines, there are none in vitro or in chemical test guidelines that are available now, whereas for other endpoints, like for example, skin or eye irritation, there are in vitro and in chemical test guidelines that are available. So it is really a very challenging endpoint to tackle using NAMs. Okay, now I will go to the second part of the presentation. The first part was about the status of the repeat dose toxicity in the current regulatory system, and now we would like to talk about the opportunities that we have of using NAMs in this particular for this particular endpoint. Again, our initiatives are ECHA initiatives are described in the reports we just published. that I invite you again to read. And our involvement in APCRA is one of them. And this morning, there was a question about what are we doing specifically in APCRA and how we want to use the learning that we're having in this consortium. So APCRA is accelerating the pace of chemical risk assessment, which is a government-to-government consortium that is currently managed by Health Canada, EPA, and ECHA. And we see in the picture the manager there, Tara Barton, Rusty Thomas, and Mike Rosenberg from ECHA. So this consortium, the consortium strategy is built around concrete case studies to address specific regulatory needs that are spanning over different jurisdictions, as you saw. And the way we are using this, and that was the question that was asked this morning, is we are using the knowledge and the expertise we are having there to best support our policymaker in Europe. Recognizing that the replacement, for example, of systemic toxicity testing is really a big challenge that needs attention, and this is one of the main focuses of ECHA. The way it is working, I will show you two specific case studies that specifically address this topic of repeat dose toxicity. And think of it, this is a consortium where case studies are built, run, and lessons are learned for future implementation in the regulation if possible. So it's really more for having this learning and sharing common knowledge with different jurisdictions. So the first case study is a retrospective analysis of data from about 448 substances that have in vitro high throughput screening assays data, and in vivo hazard information, and also exposure estimates. By comparing the POD, or the point of departure, based on high throughput screening predictions and of the bioactivity, the exposure predictions that Thomas was talking about, like Expocast or Exposim, and using the in vitro bioactivity, the study wanted to show that the in vitro bioavailability could be a protective estimate in this case. You can find more details in this paper authored by Katie Paul Friedman from the EPA, and you can see that many scientists from various organizations also participated to this paper, including in my unit here at ECHA. So if we look at this graph here, we can see that of all the substances that are there, about 90%, 89% had the POD NAM, so the point of departure that is derived from the NAM battery or the NAM high throughput screening data are lower than the traditional POD or the POD derived from the in vivo studies, which means that the NAM can already be used as conservative priority setting. So this study, although it showed that it could be providing a conservative point of departure, there were some challenges that arose there, and those are the kind of lessons we want to learn from this kind of case studies. So the first concern or potential concern regarding the approach is the fact that it is overly conservative. And there were a question also, I saw it in slide, you maybe will address it later on, how we use that and what is hampering you from using it. So one of the challenges is that this approach is overly conservative. And there are other questions that arose from this case study. Can we use the same approach for chemicals where we don't have this high throughput in vitro data, where this in vitro data is lacking? And can we build an optimal assay battery that will generate this type of data? Could we design a NAM battery that is really very effective in terms of number of assays that are in there, their cost, the time you need to generate data to address those, or to generate this high throughput screening data that you need there? Another important endpoint is the TK. Could we have improved models that could be used there? Is there any room for improvement? And what about the applicability domain in that assay? The classes of chemicals that were used in there are different for different sectors. So all those were concerns and questions the consortium had, and that's why the consortium decided to follow up this case study with a prospective case study with the objective to identify this optimal NAM battery to provide, and specifically targeting repeat dose toxicity, to provide PUD for wider range for systemic effects from repeat dose toxicity, and also mechanistically based repeat dose toxicity specific hazard flags and indication. And remember all the objectives of repeat dose toxicity. So this prospective case study, so this is the second case study that we are participating to, is led by my colleague Tomasz Sobanski, who was discussing just he would discuss just before me, and with substantial support from EPA. Katie Paul Friedman is provided the support from EPA and valuable contribution from different organizations, GRC, NTP, Health Canada, ASAR. Just for I see that I have just a couple of minutes to finish my presentation, so I will tell you about an important aspect of this study is really the collection of tools we are using to generate the NAM data. So here we can see on the left side of this slide all the different tiers of NAMs that are used to generate the data in this case study, starting with in silico tools and continuing with in vitro broad profiling using high throughput phenotypic profiling. So those are high contact imaging technologies, and also in vitro high throughput transcriptomics data using three different in vitro systems. So the data generation has been completed for this case study, and we have at the moment the data is being analyzed mainly by our partners at EPA, and you will be hearing soon from that because the data will be published very, very soon. So this prospective case study, again, the work is ongoing, and our objective is to provide this NAM-informed framework and also this chemical assessment workflow that is optimized for the specific endpoint of repeat dose toxicity, and also to investigate the potential of combining the bioactivity estimate and the hazard flags that we talked about in different scenarios. I think this is really a very good example of how we can deploy the best science available. And here we showed all the NAM battery that is in there without going into the details, but it is really substantial to address well-focused regulatory questions. Here we are talking about repeat dose toxicity with very specific regulatory questions for common objective of the old consortium, which is the promotion and the wider use of NAMs. Just final remarks. The 173 reports that we published just yesterday will give you will provide more discussion and about our activities to promote NAM, showing that ECHA is very proactive in this area now. You can see some more description of the short-term and long-term opportunities, and my colleagues Thomas and Ofelia talked about them earlier. And again, I can just say that it is really a collaborative effort, and we really need buy-in by all stakeholders, including the citizen. Thank you for your attention.
Thank you, Mounir. Thank you. It will be, I think everyone will be very interesting to see the outcome of this prospective study. And thank you for reminding us of the report on the promotion of alternative methods. I take the opportunity also to congratulate you and all the colleagues that did a really good job on preparing this report, and it was just published yesterday. Without further delay, I would welcome now Aldert Pietersma, which is a professor of reproductive toxicology at Utrecht University, and working also for RIVM, the National Institute for Public Health and the Environment in the Netherlands. And he will talk us about developmental and reproductive toxicity. Welcome.
Thank you.
So good afternoon, everyone. Reproductive toxicology. I would like to thank the organizers for inviting me to give this talk. I'm very honored by that. At the same time, they gave me a big challenge. Past, present, and future of reproductive toxicology and NAMs in 15 minutes. So here we go. Let me start with the past. It's not such a long past. It's 2004, the European Chemicals Bureau, which was then in Italy, and moved to Helsinki as the European Chemicals Agency. And this was then a test animal need for different endpoints that was estimated by colleagues from that bureau. And what you can see here is a whole list of the different assays, the different test systems in animals that were done in those days. And you see that there is a top level of 2 assays or 2 test systems that really drive the animal use here. And those were the OECD 416 and the OECD 414, the 2-generation study and the prenatal developmental toxicity study. Well, we know that now that the 4116 has been replaced by the OECD 443 extended 1-generation study, which was actually introduced in order to reduce the number of 2 second generations in that study. But in actual practice, it's been a big challenge to in actual practice reduce the animal use in that particular study. So this slide shows you that about 2/3 of all animal studies was estimated to go into reproductive and developmental toxicology. So really, this is an area for attention when it comes to alternatives. And also, there are quite a lot of challenges here with reproductive toxicology when it comes to the test systems on the one hand and the regulation on the other hand. I've just listed a few of the current issues that I've encountered in the past months or so. There's a lot of debate on the triggers for generating a second generation offspring in the OECD 443 extended 1-gen study. There is also discussion about the requirement for an OECD 443 after the observation of thyroid changes in other studies. And the background there is that if there are thyroid changes, it might affect neurodevelopment. So the question is then, how far should we go with after such an observation? Another point is the need to study endocrine disruption after observing liver enzyme induction effects. Of course, we know that every compound that enters the body will at some point affect the liver, even if we can't measure it, because the liver is attaining our homeostasis when it comes to xenobiotic exposure. So this really is a large set of compounds that might affect liver enzyme. And the secondary effect of liver enzyme induction might again be an effect on thyroid homeostasis. So that is the reason why, again, this gives attention for questions about endocrine disruption. And then the point has come up about the requirement for extreme high dosing for compounds that are less potent in order to be able to observe effects on endpoints that would result in classification and labeling, such as fertility and developmental toxicity effects. And then the question, of course, is also an ethical question, the need to accept extreme general toxicity in parental animals in order to find a low AL for fertility or developmental effects. So these are just some of the issues that we see currently in the actual testing practice. And of course, there are underlying issues that drive these points of attention. Of course, what we're often doing in Europe is to execute risk management based on hazard identification only, without considering realistic exposure scenarios and compound potency. And this has been brought up today already. And then the tendency to consider changes in physiological parameters as an indication of adversity, which of course is a complex issue. Because this pertains to homeostatic changes. The body will respond to any change in the environment by changing its homeostatic response. And so the question is, how do we distinguish adaptive changes from adverse effects in those animal studies as well? And then we have the ethical limits of animal welfare and suffering that are at stake. So there's really a lot going on in this area of reproductive toxicology involving a lot of animals. And really the need for alternatives has been recognized a long time ago. I mean, we have these OECD guidelines since the early 1980s. And even from that time on, we also started to work on alternatives. And this is just a classic list of alternatives in developmental toxicology, and many of you will not even recognize some of these assays because they have been developing through the years, and some of them have disappeared again, and new assays have evolved. So it's by no means a complete list, but it tells you at least that the types of tests are quite different. You have continuous cell lines, primary cell cultures, organ cultures, and embryo cultures, and the real non-animal tests are, of course, the continuous cell lines in this list. And they look at endpoints that might be relatively simple, from cell proliferation or differentiation up to a complete development of an embryo, which of course would be usually an animal study based on dependent on the regulation that we have. Just to give you one example of perhaps the most popular cell system that has been used in developmental toxicology, it is of course the embryonic stem cell lines. Embryonic stem cells can be derived from the blastocyst of a vertebrate embryo, and it can be driven into different differentiation lineages dependent on the culture conditions. And we can also derive continuous cell lines from these cells so that they can be used in standardized testing. And the very first validation test that was done based on these pluripotent stem cells was the differentiation into cardiac muscle, which you see depicted here also. So the test system was very simple. You produce a hanging drop culture under the lid of a petri dish, and you put in cells in those drops, and they will aggregate due to gravity and form embryoid bodies. The embryoid bodies can be plated out on tissue culture plastics. They will adhere and grow out and form beating muscle foci. And the count of beating muscle foci is taken as the endpoint of the test. So compounds will interfere with the test by inhibiting the beating muscle foci. And this test system was actually validated in the early 2000s. And I was part of that validation study, so this is about 25 years ago now. And this is one of the publications that came out of that study. And it came out quite good. I mean, we tested 20 compounds in the test system. It gave an 80% predictivity and 0% false positive. So that was kind of a good result, we thought. But then, of course, other people also started using that test system, and it didn't come out that positive. Just one example here is the study that was done by Bob Chapin and Don Stedman and colleagues at Pfizer in the US, and they tested their own set of compounds that were interesting for their company, and the accuracy there was 75%, but they had about 40% false positives. So they really said, well, for our compounds, this is not a useful test system. After all these observations done by different laboratories, we convened a workshop to review the implementation of the embryonic stem cell test. And this was also published as a workshop report, as you can see here. And we came to a number of conclusions. And of course, in retrospect, it really shows that we had been somewhat naive. First of all, we were actually doing a one-in-one comparison. We were comparing a simple test, a cell line, with the outcome in an animal study. So the gold standard here was the animal study, which is which can be disputed as a starting point. But secondly, of course, the simplicity of a cell line to try and predict something that as complex as developmental toxicology is taking it a very long way. The other point, of course, was we only used 20 compounds. And how can 20 compounds be representative of the world of chemicals? So one of the basic conclusions that came out of here, which we could have drawn beforehand perhaps, is that the limited biological domain of the in vitro test precludes that it will correctly predict all toxicants at the level of the apical endpoint, right? So we can perhaps predict with this cell line the effect of a compound on a certain differentiation route. Yes, we can do that because that is the biological domain of the test. But to extrapolate an effect on cell differentiation to what happens in a pregnant animal with the fetus is, of course, really far-fetched. So this realization actually brought us to thinking about a different approach for thinking about how to design an animal-free testing strategy. One of the ideas was, of course, to start with using batteries, because you can then use different tests with different biological domains, pile them up, and you can probably have a more integral coverage of what you want to cover. But still, you don't know whether you cover everything. There's always this uncertainty of what you can do. And again, these test systems are relatively simplistic. You're still looking at effects on the cellular level. How about homeostasis in the intact animal? How about the translation to apical functions such as, well, let's say autism, Parkinsonism, cognitive function? That is a totally different story from what you can actually measure at the cellular level. So what we need to do is to come up with a system that starts from understanding the biology of the system. And the idea here that has arisen over the past few years is to start from the toxicological ontology. And let me explain to you what this system entails and what the idea is here. Suppose that it would be possible to describe human physiology from the molecular level up to the cell, tissue, organ, and organism level in a system that you could actually describe in a computational model, right? An ontology basically is a set of items, a set of characteristics, plus the relationships between them. And of course, this is the way that, for instance, an adverse outcome pathway network is described, and it is also the way in which physiology can be described. We have a number of chemicals, we have a number of factors in the body, and they interact with each other. And this, some of you may recognize this map as the old Boehringer map of biochemical interactions in physiology. I just borrowed that one to show how we could actually depict such a system. And what should a system like that be able to do? Well, first of all, let me point you that this is not the first time that we think about it. The Virtual Physiological Human Institute is an institute that is actually doing this. They are describing human physiology in a virtual environment. And this is a worldwide process that they are actually using. And this is a starting point also for designing computational methods for doing clinical diagnosis and clinical treatment. And this, of course, is a totally different world from ours, but it has shown very much promising results in that area. So basically, based on these computational methods, people are diagnosed based on an assessment of their clinical chemistry, etc. And then the diagnosis is made and treatment is also proposed by the system. And in many cases, especially in certain forms of cancer, this works much better than the estimation of clinicians. So there is a precedent here. But we simply should think about how could we apply this also in toxicology. So the system then, if you challenges with different chemicals, should actually predict what the outcome would be through a calculation of what happens in between. And how do we measure what happens in between? Well, now I come back to what the National Academy of Sciences in the US about 15 years came up with their report at toxicity testing in the 21st century, where they said, well, there is probably a limited number of toxicity pathways that we need to consider to cover everything, because chemicals and sensitivities in the body are limited. There must be a limit to it. I'm not sure whether there are 6 elements that are critical. It may be 60 or 160. But anyway, let's suppose that there are 6 elements in this system that are really crucial. They should be triggered for an adverse outcome to appear, right? And they should be probably triggered to a certain extent. So it's a matter of not only qualitative, but also a quantitative effect. And then all these chemicals should go some way through these stars in the system, if you will. And some will trigger some and some will trigger others, but it will, in the end, determine the outcome. And then, of course, as I said, this is very reminiscent of the adverse outcome pathway framework approach. You start with initial events, you end up with adverse outcomes, and in between you have key events that need to be triggered in order to go from an initiating event to an adverse outcome. Now, suppose we would have identified those stars in the system, and we could represent them by test systems. So here we have 6 stars represented by 6 test systems. So let it be in vitro systems or whatever. and you would test your compound in those 6 test systems, and it would give you a quantitative relationship. So a dose response, a concentration response in vitro. And then the toxicological ontology computational model derived from that map would then give you the toxicity profile. So this is still theory. And of course, the question is, can we make this work in practice? First of all, if we are using those kinds of test systems, I need to say a little bit about validation. And I'm actually mirroring a lot of what João was saying earlier on today. What we need to know here again is the biological domain of the test. What are we actually testing? You know, false negatives can often be explained by the fact that we do not have the biology that is triggered by the compound in this particular system. We need to know about technical performance, and we need to know about chemical domain. But when it comes to sensitivity and specificity, we should test a test system, a challenge test system, with compounds that actually affect the biology or do not affect the biology. That is what's interesting here, and not beyond the biological domain. And the validation of the test battery as a whole should be done against in vivo toxicity, or especially even better against human outcomes if possible. So validation becomes a different story here. It's not a one-in-one comparison. It's a comparison of the system against the human situation. What we've actually done is to try and make this work in actual practice. We have made a cell designer map for neural tube closure. And cell designer is the system that has been used also for the virtual physiological human project. And this actually describes the neural tube closure in molecular and cellular terms. You see the different components are the different areas and different cell types in the closing neural tube. And we have put in all those cell types, the different molecules, as well as the genes that are driving the closure of the neural tube. And in parallel, we have made an animation of the neural tube closure that can be driven by the biology that is represented in this particular map. And this is, in general, not a new approach. The US EPA Virtual Embryo Project has been doing this for several endpoints or several processes in embryogenesis. So there is proof of principle. And we are doing that proof of principle now for neural tube closure. And here you see the animation that we have made. And in the normal situation, the second from the left, you see that the neural tube is normally closing with the epidermis closing on top of it. Whereas on the left, we have, with hypoactivation of BMP, one of the regulators there, you see that the neural tube doesn't close, but the epidermis does close. So this would be a spina bifida occulta. And on the right side, you see an open neural tube that remains open. And this is just driven by the fact that we mimic the inhibition or activation of bone morphogenic protein, which is one of the main regulators of neural tube closure. So here, what we can say is that if we have a cell system in which we can actually measure the effect of a compound on BMP, and we can mimic that effect in our in silico system, we can take it to the adverse outcome, which is neural tube closure and neural tube closure defects. So here we have the bridge to a simple cell system, from a single cell system to the adverse outcome at the end. So this is, to me, it's proof of principle of how such an ontology system in silico might actually work. And this gives you the histopathology of that kind of effect. So just to summarize, and I'm finalizing my talk now, if we have a good knowledge of this system, and we are not there yet, but the virtual physiological human project is getting there, and it is really advancing quickly now. And we have information about our compound, physicochemical properties, etc., which lead into the question of how does the compound behave in vivo. So we would use an ADME model, a kinetic model of how the compound is actually distributing itself in the body. We could then make a choice on what test systems actually to use for testing the effect of this compound. So again, that might be compound specific, and it might be specific for endpoint. It would then, the information would then feed into the virtual model, and it would give you a safety profile. So that idea has now been published at various times. It just appeared a few days ago as the cover story on Current Opinion in Toxicology, which made me quite happy, of course. It's always nice to have that kind of thing. And to finalize, I have a few take-home messages. The current regulatory hazard-based risk management based on animal study protocols meets with issues regarding interpretation and animal welfare. Computational approaches based on the toxicological ontology offer innovative opportunities. And as I said, clinical diagnostics and treatment now successfully uses computational models using personalized patient parameter input, which is an example for us, I guess. The US Virtual Embryo Project shows proof of principle of computational prediction of dose-related compound-induced adverse health effects. And then the virtual physiological human, which I alluded to, provides the physiological basis for computational modeling. And then test batteries comprehensively covering the AOP network provide data input for computational models. And such a test battery can be trustworthy because we are covering the biology of the system. And of course, it's good to note that a number of big projects are actually taking this idea on and trying to move it forward. So what I've just shown you as the neural tube closure case is actually work that is done in OnTox, a European project that is really moving this forward very, very quickly and very successfully. And in the Netherlands, we have the Virtual Human Project for Safety, which is actually built on the same premise. And of course, because I have run out of time, I do realize that I have just given you a list of references here, so you can read upon it. And I've, of course, had to be very quick to make sure that I didn't run too much over time. But I thank the chairman for his patience and thank you for your attention. Thank you very much.
Thank you. Thank you for trying to. It was not an easy task that we gave you in 15 minutes to talk about development and reproductive toxicity, but thank you very much for the presentation. Without further delay, I will pass the floor to Dr. Hezingveld. I hope I pronounced it good enough. Close enough. Which is a toxicologist at the Center for Health and Protection of the Dutch National Institute for Public Health and the Environment. And he will talk us about carcinogenicity. Welcome.
All right. Well, thank you for bearing with us, and thanks to the organizers for inviting me to talk about carcinogenicity here. I won't be talking about icebergs. It's pretty. It was a chilling experience, I must say. Anyway, chemical carcinogenicity assessment, NAMS and beyond. A little bit on where we are now. I was asked to give an outlook on the future, but I cannot do that without touching upon what is done now. So in carcinogenicity, there are two things important, genotoxicity and non-genotoxicity, or non-genotoxic carcinogens. And so the ability of a compound to interact with the DNA directly or cause cancer via other pathways. And within REACH, and I'm realizing that I'm really bringing it to a 2D level, like really flattening it out in black and white. Genotoxicity is covered, yes. There are a couple of assays there that work pretty well, but carcinogenicity is largely uncovered. So the consequence of that is that the non-genotoxic carcinogens will remain undetected under REACH, largely, of course. And for CLP, there is mutagenicity, so genotoxicity is covered, but carcinogenicity is not. And in that sense, the revision of REACH gives opportunities, but also new challenges. And to see what we can do, we said, okay, the cancer hazard assessment, for instance, for agrochemicals is typically done in a 2 years carcinogenicity study in mice and rats. That's the basic approach. And this works, but there are some serious limitations to that on the ethical level, but also on the scientific level. And we said, okay, if we want to move away from the animal study, we need to know what we're talking about. And we're aiming for something mechanistic, so really a mechanism-driven approach for predicting carcinogenic potential. And so to really get an idea on what the different mechanisms are that we are talking about when we're looking at the classical animal study, we built a project that was kindly funded by the EPAA, identifying mechanisms. And to really, in a nutshell, we took all the reports from over 400 unique agrochemicals from different agencies, what was available, and identified all cases of tumor formation. And we came to a list of 340 cases of tumor formation, of which 170 we could label between quotation marks, because it was our own label, as non-genotoxic carcinogens. The details on this study are described in the reference below, so I won't go into much more detail there. And to our surprise, with these 340 cases of tumor formation, we came to a fairly limited set of mode of actions listed behind me. You're not supposed to read this, but the list is limited. It's only 9 different modes of action. But one of the things that bugged us was there were, out of the 340 cases, there were 114 cases related to 72 chemicals with unknown modes of action. So there was no mode of action information available whatsoever. These are all, this is just a pie chart to demonstrate where all these unknown modes of actions are, and they're all throughout the body. And we know there are 19 different organs and organ systems, and upon further detailed study, we could identify modes of action for the lung and the adrenal gland, but so far the rest is unidentified. So that brings us to, well, we have a list of modes of actions now, but now there are some issues to be solved, because solving one issue sometimes brings you into problems, rising more issues. So we identified these modes of action in rodents, and ultimately we're looking for a human carcinogenicity. So we need to add on top of these modes of action, missing human modes of action. For instance, immunosuppression. We were not able to find these in all the reports that we dug into. So it's probable that is something human, which is not reflected by the rodent test at the moment. And there is this question we have. I showed you the list, and we can have a full day debate on whether these MOAs should be considered for risk assessment. But we need to realize that we should decide altogether which MOAs should be considered and who determines this relevance, and how do we define relevance of a mode of action, and what criteria can we apply that we all agree upon that a mode of action is relevant for further study. One of the things that is important in this respect is, and João already pointed at biology, and just also did, know your biology. We're studying rodents now and rodent tumors, but we need to relate everything we do in the end to human tumor biology or human biology. And we need to see if, for instance, the tumors that we find in rodents, is there a homology with a tissue or a cell type in the human? That could be one of the criteria of deciding on whether a tumor that is found in a rodent could be relevant for humans or not. And this all, in the end, should be based on mechanisms. This should be really mechanism-based strategy and not just adding something into a system, seeing what comes out, and if something comes out, check the box, carcinogenic. And if we're talking about the different mode of actions, AOPs come to mind, but we should keep in mind that we need to go to quantitative relationships and not just qualitative relationships, because we can understand biology, but if we do not understand the relationship between the different parts in the biology, then we're still not there yet. Already mentioned AOPs. One of the things that we did with all the mechanisms we identified is we outlined AOPs. Giving you 2 examples here, one where you have one a molecular initiating event all on the left and different adverse outcomes on the right, and another one where you have a load of molecular initiating events and a load of adverse outcomes on the right. One way to really structure the data. with a mechanistic-based approach, we should define the NAMs for the relevant key events. If we decide these mode of action should be tested, then we need to have NAMs, of course. I'm talking about new approach methodologies and not necessarily non-animal methodologies, but that's a totally different discussion. And there are many NAMs out there. That's what we already know, but we need to, speaking of something that we need to decide on altogether, what are criteria for NAMs to be met for regulatory use? How do we make sure that in the end, the regulator can accept the outcome of a NAM? It's already been touched upon earlier. What is the technological readiness level that we would like to see in order to have confidence in a certain method? And with all models and all models in vitro, be it in vitro or in vivo, we should have a serious characterization of a model. We need to know what the model is capable of with a toxicological applicability domain, biological applicability domain, and make sure that if we test for a certain mechanism of action, that we know that the MIE in the AOP is also present in the model. Because if we want to test the effect on a certain MIE, some people do not realize that this one should be there. And we should, we should decide on what to do with when the relevance of a certain model or the relevance of a certain endpoint is unknown or uncertain. How to define that? One of the ways to really structure this approach has already been alluded to by other speakers is using integrated approaches to testing and assessment, or shorter IATAs. One way to really structure the approach, starting with the AOP and going through a series of iterative assessments, in the end deciding what the regulatory conclusion would be based on the AOP, the problem formulation, the information, a weight of evidence assessment, and in the end the regulatory conclusion. And for non-genotoxic carcinogens, one of these, an IATA has been proposed. It's in the publication of Miriam Jacobs et al. In 2020, and here you can see that there are a lot of different. Is the pointer working? It is working. A lot of parameters related to the pivotal parts of information that you do need to decide if you come from an MIE all the way to a tumor. A lot of parameters that need to be that you need to be informed about. This is work in progress, and currently there is a review ongoing of the available NAMs and or assays in terms of robustness and appropriateness to really build on this IATA. And of course, there is the issue of human relevance, and we believe that this should be done in a structured and transparent fashion, using the well-defined criteria based on, for instance, the WHO IPCS framework. And it should be done for pathways as a whole and not for single elements of a pathway. And also it should be done for the pathways plus the associated NAMs. And on the right, you can see the mode of action framework that can be used for that. So then one of the most daunting questions I got from the organizers, are we there yet? Well, yes and no. Let me start with yes, to start on the positive side. On the positive side, there are a lot of assays available for the MIEs and the first key events in many mechanisms and many AOPs. That's positive. Absence of GenTox, so genetic toxicity, we're well able to do that in a NAM-based way. So that's also on the positive side. And for the extrapolation of the in vitro or NAM-based data that we generate to the human in vivo situation, we need modeling, but the PBPK models and the KeyViva models, for instance, to really translate what we find with NAMs, they're being developed and they're well underway, I must say. On the other hand, there is the no. And with carcinogenicity assessment, there is one elephant in the room, and that's a proliferation assay in vitro. And that is coming back time and time again. And this discussion, we can also organize a full day discussion on this one. But we need to find an assay where you can reliably test for proliferation of a cell model in vitro. So far, this one is missing. as are many higher tier endpoints in the AOP structures that have been built. And then the question is, are we there yet? No, because we can only predict the first parts of the AOPs, and that is not so far predictive for what happens in the end with the adverse outcome. So that's the no on are we there yet. I said already a no because we need a quantitative approach. If we're there with a qualitative approach, describing all the mechanisms, building AOPs, we're not there yet because we need to really go to the quantitative side. And of course, we need to build test strategies. If we have single NAMs, single approaches, that's not what that's not all we need. We need the test strategies, and we need cell models, the whole organism models, and we need to consider, at least for the first part, not replacing everything with a non-animal approach, but trying to find the human relevant endpoints in animal tests that we can use with the in vivo, with rodent studies, for instance, to really back up what we're doing with our in vitro systems. And then one of the other elephants in the room, and I already heard it in a couple of other presentations, how do we end up not overly conservative? Some things, and that was one of the questions of the organizers as well. What can we do? What can policymakers do? So facilitation through policy. One of the things is start talking. That may be an open door, but every now and then I run into this figure where people describe how the fields of NAM development can be described by these 4 arrows with the 4 different groups of stakeholders. And I think this one is fundamentally wrong, because what we need to do is this. We're looking at the same thing. We're looking at that we have the same goal, but if we keep looking at different directions, we will never agree on it. So we need to do this. And we need to decide on, with the development of NAMs, how to build trust, how to build confidence, what are quality criteria, how do we define something being reliable, reproducible, etc. And that is really pivotal to go there, and we need to do that all together. It's not one of the stakeholders that can really set this bar. We need to do this together. And of course, there is. It's always good to encourage data sharing, because there is a lot more data out there than what you can find in the different reports or what you can find in the literature. So it may be good to think about data sharing, and maybe even a transition period where classical dossiers are handed in along with sort of extra dossier describing everything that we know on a NAM-based way. That brings me in the last second of my presentation to the acknowledgements. I'd like to thank the EPA and the team on the left for giving us the opportunity to do this, and a couple of colleagues of the RIVM on the other side. So with that, thank you for your attention.
Thank you very much for again bringing a quite complex topic, but also bringing many of the elements that were already also discussed in the previous presentation, and bringing also IATA and how IATA also already can be used, and giving examples of that. I'll pass the floor now to Professor Pim Leonards from the Environmental Bioanalytical Chemistry, in Environmental Bioanalytical Chemistry at the Vrije Universiteit of Amsterdam. And he will talk about endocrine disruption.
Yeah. Okay, great. Yep. Okay, great. Thanks for inviting me to talk here about endocrine disruptors and NAMs. And I will give you a very concrete example. I think we talked about today about many aspects. But I will show you some results of a European project, and you will see that many of the things we discussed today, you will see them back in some of these slides. But before that, I will start with this slide, because there are a number of ID criteria, which you can read in the EU guideline there. But there are 3 important aspects there. First of all, to be an endocrine disruptor chemical, we should know the mode of action, and that the mode of action is related to the endocrine system. The second part is there should be an adverse outcome. And the most important part is that there should be a link between the mode of action and this adverse outcome. So it means that the endocrine system is changed and it is causing an adverse outcome. And there is another word, what I mentioned there is intact organism. That's also written down in this guideline. And I will come back on that later, because today we are talking a lot about in vitro work, but here's the word intact organism. So I will come back on that. Now, if you look at the guideline, it's also saying that's a weight of evidence approach. So we can work with in vitro work, but also with in vivo work. But in the endocrine field, there are many things what we don't know. This guideline is really focused on estrogenicity, androgenicity, and thyroid hormone. But there are many more ED systems. And this is still a challenge. And this is why now, I think more than 4 years ago, these 8 European projects started to develop new testing methods, screening methods to identify endocrine disruptors. Here you see these 8 projects, and they work on less studied endocrine systems, but also less studied adverse outcomes. So you see the thyroid hormone system there, disruption. You see the metabolic disruption, female reproduction, and developmental neurotoxicity. I will focus now on the endpoints project. That's mainly because I work on this project, but I think it's a nice example to show what's going on in this endocrine field. So what I said, this is the endpoints project where we try to understand the relationship between an endocrine system and a DNT outcome, so developmental neurotoxicity outcome. This sounds easy, but when we started the project, there was one missing link here, and that was the endocrine system here, this. So we know from a lot of epidemiology studies that there are links between the chemical exposure and DNT outcomes. There are many studies which show, for instance, pesticides related to ADHD or autism and that sort of thing. But the question was it an ED-linked effect? So was it an endocrine effect which was causing a DNT outcome? So this is one of the gaps we try to solve. And this is what I will show you a little bit more in a few slides. And then I will come at the end, I will show you the needs on endocrine disruptors and NAMs. So the approach we followed, so this is the basis for this approach, was that we worked on new NAMs for in silico, in vitro and in vivo work. And we mainly worked a lot on the in vitro part. The in vivo part, the rodents, was really on twofold. First of all, to see what the links are between the in vitro work and the in vivo part, but also to understand the mode of action and how is this mode of action linked to adverse outcomes. Now, another important part was the omics part. The omics part, we mainly used that to integrate the whole system, to get a link between the in vitro system. Do we see the same type of markers, omics markers, as we see, for instance, in vitro work? And the other thing what we want to do is, can we use some of these omic markers to, for instance, predict cognition or behavior outcomes? So there is in this project, there is also a cohort study where we try also to see what type of omics markers are these linked back to the in vivo work, for instance. So it's going all the ways down. So the NAMs we are developing, and that's I think what we discussed today also, is QSAR's in vitro work, some in vivo work, but mainly adding omics markers to existing guidelines. And in 3 slides, I will show you some of these concrete results. And I think these are things we discussed also today. So this is, for instance, in silico prediction models, QSAR models, what we developed on 13 endocrine receptors. And you can see already that's not only the ER system, the androgen and the thyroid hormone system. So there are many more androgen systems what we covered in these receptor models, in these QSAR models. So these models are available. They are published, and you can use them for classification as a first screening tool. Now, the in vitro work, we try to understand or develop different in vitro models which are linked to the brain development. And so we have models which are in the proliferation phase, the differentiation phase, migration, network formation, myelination phase. So these are all kinds of different in vitro models which are developed. And from very simple cell line models to very complicated brain organoids 3D structure models. And one of the things we tested, what I said at the beginning, is the relationship. If you activate one of the endocrine systems, are then there effects found on the DNT side? And this is the case. And you can see that it's very detailed here, but at least you see the same receptors here, what we see in the in silico models, but you see that many, if you activate some of these endocrine systems, that or there is a DNT outcome which is decreased or increased. So it shows that these DNT models, what Ellen had a question about later this afternoon, have also endocrine systems available. Now, the last part, what I want to show you is that we try to find markers, especially omic markers, which can have a predictive tool for adverse outcome. And that can be used, and I think that's what we discussed also today, maybe to trigger animal test or not. And one of the things we did from the cohort studies, we selected a number of chemicals, which you can see here, where the cohort study said that these have DNT outcomes. So these chemicals are linked to behavior changes, for instance, in children. And this is what we tested. And with different types of omics, we try to find markers which now are linked to these DNT outcomes. Now, the last part, and it's already Harm also said that, to link, I think it's super important that you link all these models, especially the in vitro models, in an AOP network. Because this is the bridge, this is the anchoring of these models, these NAM models, to an adverse outcome. And I think that's a challenging part also. Because maybe we don't have all the models available to make these links, but I think that's the important step. And I will show you that in a moment also in what we need. And this is what I'm also telling now a little bit more about. What are the needs? Now, this Orion project, because I showed here an example of the endpoints project, they will deliver a lot of new NAMs. It's a whole battery of new NAMs. This Orion project will end next year. Most of the project will end next year. And so they will provide in silico, in vitro, and in vivo models, also non-mammalian models, and also biomarkers. I started with the first slide where I said also intact organisms. So many of these new NAMs are not intact organisms. And I think therefore it's highly important that we embed all these in vitro models in this AOP approach. Because this is the link between an adverse outcome and maybe an in vitro work. On the short term and long and medium term, that was one of the questions also from the organizers. In the morning, we talked a little bit about validation, and what I learned from this European project, and I think also the other Orion projects, is this pre-validation is really time-consuming. It's hardly needed, but it's really time-consuming. And one of the other things what's really challenging is the transferability between labs. So many of these new NAMs, these new in vitro assays, they are high-end. You need high-end knowledge, you need high-end equipment for it to run these assays. So it's more an open question. Do we go this way? Do we really want that every lab in the world can do these assays? Or do we say, okay, there are restricted labs who can do the assays? That's I think, an important question. this, I think, morning or afternoon, I don't remember anymore, but the financial resources were also called, of course. It's a highly important thing if you really want to do the pre-validation. In this Orion project, there was, of course, resources available for that, but it was already raised in the morning that you need resources for that, because it's what I said, time consuming, but it's highly important. And I will end in 2 slides where how we maybe can solve this, or how there is maybe an option for that. So on the long term, I already said time consuming from non-development to pre-validation, and there's even one step further to an OECD guideline. So it's a long trajectory, I think. The other thing I think what we need is what Harm also said, we need more discussion, no more talking. I think the omic field is so fast moving in the scientific world. I think we need really discussion between the scientists and the regulators. What can you do with the omics data? How can we put that in the regulation? I think it's highly important. And there are still a lot of scientific data gaps on EDCs. I mentioned here a few. But for instance, what we found in our project, there are many interactions between ED systems. If you have a mixture of chemicals, we're now assessing single chemicals, but how are these interactions when you have an interaction between ED systems and you add a mixture, maybe one chemical worked on the thiotermone and the other one worked on the estrogen system. We don't know that. So that's an interesting question. And then I want to end with, how can we move forward now? Yeah, that's the question. And I think this morning was also raised, the pre-validation. I think Miriam, if I'm correct, raised that question also. I think what we need is more resources for that. And one option is to have platforms for that. You maybe know the PEPPER initiative platform from France. They have this platform where you can do pre-validations. I think this is a very good idea, what France started, this platform. And I want to make more a plea for that other member states are also doing this, or maybe they do it together with PEPPER. But this is maybe a way how we can move this pre-validation, because if more and more NAMs are coming and we want really pre-validation, then we need resources for that. And the last point, I think, of course, we need also non-test guideline studies should be incorporated, but I think that's already what we discussed. And this is what I want to tell you today. So many thanks.
Thank you very much, Pim. Actually, thank you for giving us a bit of time later on for the Q&A. It's my pleasure now to invite Dr. Kristin Schreiber, which is the head of the Department of Environmental Toxicology at the Swiss Federal Institute of Aquatic Science and Technology. She will talk us, go through new approach methodologies for chronic fish toxicity.
Wow, let's breathe. This is a lot, isn't it? And now that we've heard a lot how we are as humans trying to protect ourselves, which is fair enough, I would actually like to ask you to take a bird's eye view and recognize for a moment that even though we are protecting ourselves, and that's fair enough, we are only a very small part of a complex environment for which we have an obligation to protect. And as an ecotoxicologist in ecological risk assessment, we are very concerned about the preservation of fish populations. Now, fish, they will never smile at you. Okay, I recognize this, but they're fantastic organisms. And actually, when seeing them in the wild, one of my PhD students, Fabian Balk, painted by hand this beautiful image of a brown trout. Now, silently, fish perform many vital functions also for us. So they regulate food web dynamics, they provide important ecosystem services, and maybe,
easier, closer to us is the fact that they are providing an important source of food. Now, did you know that there are chemicals, those main uptake route into humans is actually via fish, and so that there are restrictions in, how much fish you should eat. So that should be a concern of us, because this means these fish cannot eliminate these chemicals, they accumulate and they make it up in the food chain. So therefore, what we are concerned about is that fish survive, that they grow, and that they're able to reproduce. And we also want to know whether they actually accumulate chemicals, as I've just explained. So to measure these criteria over the past decades, a whole range of in vivo tests have been established and are regularly used also under OECD test guidelines. Now, it's not so easy to figure out how many of these tests are actually being performed, because animal numbers are recorded as total numbers, so you don't know exactly what they're being used for. So I would actually like to use a study led by Elisabet Berggren, where they asked 15 contract research organizations which kind of tests they were asked to do in the period from 2014 to 2017. So here's the list. So you see on the y-axis the different types of fish tests. On the x-axis, you see how many times these tests were performed. And remember, this is really only a snapshot, okay? And then you see that we have 3 front runners, and I also list there how many fish approximately have been used according to the number of tests. And so the upper test is the fish bioconcentration test, which essentially gives us something about how the chemical behaves, bioaccumulation. Now, the second front runner is the fish acute toxicity test, which is still the most widely used fish test, not only for chemicals, by the way, but also for water quality assessment. And then the third front runner is the so-called fish early life stage test, which you can see is very animal consuming and which actually is moving into predicting fish chronic toxicity to fish. Now, if you want to change the need for all these fish and these very elaborate experiments, we really need to change our perspective. And I think we all agree that what we want is animal-free, but also mechanistic, resource-efficient, standardizable, and scalable. So let's change our perspective. And I leave it up to you how you want to interpret this image. I'm sure there are many different interpretations. The way I see it is, hey, there's a whole world out there that if we don't change our perspective and look from a different angle, we'll never find out it's actually there. So let's, for example, take fish bioconcentration test. Remember, this was one of the front runners on top. So traditionally, we expose fish to a chemical over time, and we take the fish, we extract all the chemical out of the fish, and then we put the remaining fish into clean water and we measure the depuration. And from this, we can actually calculate the so-called bioconcentration factor. How much of the chemical accumulates in the fish compared to its aqueous environment. Now, if you want to do this with an alternative method, we have to change the way we think about this. And so two very successful OECD validated methods are the using primary hepatocytes or using basically an enzymatic fraction of fish liver. Now, I will admit you still need the fish, but you can do way, way, way more experiments from one fish liver in a very quick time. So what you do is actually you use the hepatocytes or the S9 fractions as a reaction mixture, and you measure over 4 hours how quickly your chemical is actually depleted, biotransformed by the liver fraction. And then you can use this elimination kinetics with a computational model to now calculate an in vitro derived bioconcentration factor. Now I provide further information on this and other potential future assays to predict bioconcentration in the back of my slides. Here's another example where I think we have been already very successful, and this is to predict fish acute toxicity. Now remember, this is the most widely applied fish test still. It's obviously a high severity test because we look for death, and all we monitor is fish death after 4 days. Come on, guys. In the 21st century, you must be able to do better than this, okay? So there are now 2 proposals for replacement or to substitute these tests. One, still an animal test, okay, the fish early life stage test, even though I would call it a refinement, it's a non-protective life stage. But now we also have a true replacement. It's the fish gill cell line assay, which we have developed to predict fish acute toxicity. And I have a little disclaimer here, okay, because this is the assay that we developed, of course, with many colleagues around the world in my group. And we also felt the need that we need to provide sort of a service lab on GLP, which can offer this test to people that would hopefully pick it up. And so what I can tell you is that industry and also environmental protection agencies, they do pick up this assay, okay? And so it's a very rewarding experience to go through this, but I often hear, will there anyone be to do these alternative methods? Will there be enough capacity? I will tell you, if the assay is robust and relevant, it will be picked up. Just let the market do its magic, okay? It's going to work. All right, also some more information here in the back of my presentation. So when I think about the 2 first front runners here, bioconcentration and fish acute toxicity, I think we are there. Let's use these alternative approaches, learn with them, improve them, but please let's start using them. So what about chronic toxicity? So the first you see is the fish early life stage test, which essentially also measures survival, change behavior, but the main outcome there is growth. And so you start with a fertilized egg and you expose the fish until juvenile age, and it's very animal consuming. And depending on the fish species you use, this takes a month to 3 months. So what we have been thinking actually quite some while ago is that, hey, if these fish grow less on chemical exposure, it must mean that these fish have fewer cells. And we should actually be able to measure fewer cells in the lab. So what we did is we used, again, the same gill cell line as a model for richly perfused tissue. And we designed an assay with which we can measure within 5 days and differentiate if there's a reduced cell proliferation on chemical exposure or not. We can then calculate from the number of cells the cell weight, and using a growth model, we can then predict what this would mean for a fish grown under the chemical exposure. Now, here's the proof of concept, which we just recognized, published actually quite some time ago. And I would like you to focus on the right-hand side, the propiconazole, which is one of the test chemicals that we used in this proof of concept. And so what you see on the x-axis is the chemical concentration. On the y-axis is the fish weight, either predicted or measured, because all the black dots that you see are real in vivo data. Okay, now the green horizontal line shows you the average of the in vivo data, and the red squares show you our prediction based on the cell model. Now, I think this is actually quite phenomenal. So what we have done in the meantime, we have expanded this data set to other types of chemicals, and every time we tested this pipeline, it was very successful. Now I will say that we still treat the cells as a black box. So we actually now have a project to really look at the mechanisms to find out what is actually going on in these cells, that all these different chemicals eventually lead to reduced cell proliferation, ergo reduced fish growth. But then what about reproductive toxicity? So I would say, as we've heard, that's next level, huh? And also includes a lot of endocrine toxicity. So here, I think for the ecotox field, we first should think about refinements of existing models. For example, there has been a study to demonstrate that the fish early life stage test, so the one that I've just talked about, is actually quite predictive of the fish full life cycle test. Well, that's excellent news, okay? So how about maybe adding reproductive toxicity markers to the fish early life stage test? Or now that we know we can use fish cells, at least the gill cell line, to predict reduced growth. Maybe we can add some additional markers to this assay there. Further to refining existing methods, we can, of course, think about using the same model, but adding different capabilities. So one example would be now a transgenic zebrafish line from which you can use the embryos to specifically detect estrogen receptor agonists. Or, and we've also heard a little bit about this, adding new endpoints to existing strategies, such as, measures for thyroid disruption in the fish embryo test, or of course, adding molecular markers, mechanisms, be it in a targeted way or in a non-targeted way on the protein transcript or metabolome level. The capabilities, the technical capabilities are all there. But what about in vitro models? And so the nice thing about working with cells is that, hey, we are all made out of cells, you, the fish, the plants, so we can actually learn from cells. And so one idea would be to also look at databases like the ToxCast database. If you get information on conserved pathways, where we can transfer the information from mammals to fish. Hey, maybe we can also use, fish cell lines. And so here I wanted to let you know that we just started a Crackit project, which we won, where our aim really is to expand the fish cells to be able to tell us something about reproductive toxicity in fish. Now, how do we do this? We first developed a pipeline for biomarker identification to find those biomarkers that have already experimentally been proven to have a role in reproductive fish toxicity. And now we are going to test them in these different cell lines, which are of relevance to reproductive tox. So the overall framework that we are sort of envisioning is this fish in vitro, a coherent framework to use different fish cell lines and all the organs that are named here. I have fish cell lines in my liquid nitrogen store, okay? And so in this way, build different modules, a flexible system where we already have a module for acute toxicity survival. We have a module for growth, which needs further development. And we now really would like to tackle a reproductive toxicity module. So if I come back to this chart here, for chronic toxicity, I think there is a lot to do, but we do have ideas. We do have, some initial work that looks very promising. And I think if as a community, we stick together and sort of define the path, we can move forward a lot in the next 5 years. So coming back to my One Environment, One Health slide, focusing on fish. Did you know that there are more than 30,000 species of fish out there? So there's no way experimentally ever, in vitro or in vivo, we can account for the different sensitivities. So here I would like to highlight that there are certain initiatives to combine all the information that is out there to identify conservative biological pathways, which again, I think we can also use to identify species sensitivity differences and thereby predict also from one species to the other, maybe also from fish to humans. And with this, I'm at the end, and if there's time for questions, 3 seconds, you're welcome. Thank you.
Thank you. Thank you so much. As you may have noticed, we are a bit running out of behind schedule, but as we are at the last session, and if you are able to hold a bit longer session and stay other additional 15 minutes, I think we still have some time. I think it's very important that we give also the opportunity to everyone to make some questions and our presenters and speakers to answer those. So I would invite all the speakers to the stage. And we'll take some questions. For all of those following us remotely, we have been receiving many questions on Slido. Unfortunately, we are not able to answer to all of them, but we will do our best to take them into account in our discussion. So maybe I'll just start by taking note of the poll that we were running during the presentations on which endpoint we would prioritize for new approach methodology development. And from the 112 answers, it seems that developmental and reproductive toxicity is in the leading front. But in the meantime, I'll ask Andrea if what is Slido telling us. And I noticed, sorry, that we have only one microphone.
So, as always, we got a number of questions, and the most voted so far is one for Mounir. And this, does ECHA have a plan for integrating the outcomes of the APCRA work into the EU chemicals regulatory framework?
That's a very valid question. And I hope I conveyed the message in my presentation about all the activities ECHA is doing around NAMs. And this, the APCRA initiative is only one of the initiatives that we are taking to promote the NAMs. So our role in APCRA, which is an international organization where regulators come together to talk about their needs, their regulatory needs in their jurisdictions, while we know that for those needs, maybe the questions will be slightly different, but we know that the tools that we are using are similar. And that some of the answers that will be given will be also similar. So, what is our role in APCRA? Is really building this forum to discuss with other regulators. So, will we use the outcome of APCRA directly? Will be implemented in the regulation? Will be regulate chemicals based on the outcome of a case study like APCRA? This is not to be implemented right now in the really very, very short term. This is more mid-term, let's say, exploratory initiatives that we are making, and there the challenges that we got from the APCRA case studies, for example, overly conservative outcome, the biological domain, applicability domain, that challenges that we're having, all those challenges are the kind of question, the kind of lessons we would like to learn from this kind of initiative.
Thank you, Mounir. I'll take a question from the floor. David.
Hi, David Bell, ECHA. It's been fascinating to listen to you, and it's been very stimulating. If I can share a kind of blunt approach from a regulator's perspective, when we dose an animal, all the organs get exposed, all possible pathways get interacted with. You either see an effect or you don't, or you can grade it. I've heard some really fantastic work, a lot of molecular work, a lot of thoughts gone into it. But to what extent does you doing molecular work or characterizing an effect in your system enable you to say, well, actually, this chemical doesn't have an effect in the liver, or in developmental reproductive toxin, or in carcinogenicity? How close are you to being able to answer that question? That's an easy one.
Anyone?
All right. So from my perspective, I have this vision of, also we heard about the virtual human, I have this vision of a virtual fish. And I think in all of these approaches, we need to account for physiology, which we do with physiologically based modeling, for example. And I think this needs to be incorporated also into these, new techniques like proteomics, metabolomics. Which organ is probably the most affected? Where does the chemical get? So this would be one of the ways I would approach your question. It's probably only a small part, but it's a start, I would say.
Yeah, I can only repeat myself, I guess. Your question is very, very important. I mean, with individual NAMs, with our own hobby horses, so to say, we tend to dive into those and to look at effects into those. But the big question, of course, is how does that extrapolate to adversity in vivo? Well, you've heard my answer to it and my approach to it. I think we need this, this virtual human in silico model to integrate the data from in vitro assays and other NAMs and what have you, also the kinetic models, in order to achieve a toxicity profile of a compound in the end. And that'll take some time, but looking at what computational models are doing now and how quick the developments are going in different areas where computational modeling is used, it may go faster than we can currently think about. So it's really something that we need to get on board there as toxicologists. And one thing that I've learned is, and that's I think an important message for me, was when we started working on the noodle tube closure case, I was just moving out of what I knew from toxicology and diving into developmental biology. And it turned out that there is a lot of information there that we could use, actually, but it never comes under the lamppost of the toxicological area that we're looking into, right? So, I mean, looking beyond what we are currently doing and in the different areas, such as developmental biology, in my case, teaches us a lot to provide the data that we actually need to feed that system, because that's going to be critical. If we are going to have a reliable virtual human system, it needs to have the right data in there, right? And that is of course the big bottleneck for any computational model. But looking at the other areas in which it is being used, it may go faster than we can think of now.
Maybe I can add, because your question was also the exposure, of course, and it can go to different compartments and that sort of thing. There are, of course, now very good BTK models where you can do predictions. So I see it more, the NUMS, as really a battery you need. And this is part of the battery, I think. It's not only in vitro, it's also in silico you need. So it's really the whole picture. And I think it was said in the morning, we have to think about the framework. Yeah, what do we want? And I think that's still an open question. And that's probably for a next workshop, maybe. What do we want in the framework? Yeah, I think that's one step further.
Okay, I'll take the floor, Tomasz.
Okay, Tomasz Sobanski. Very quick question, guys. Thanks for all those presentations. It seems that a lot of progress have been made, but there are still some challenges in front of us, especially I'm looking for repro, calc. And my question is, do you think the proposal which we are trying to facilitating the access to cryopreserved samples suitable for omics measurements from in vivo studies which we are generating now would help you as a developer to find out the answers for some of your questions? What do you think?
Well, the general answer is any more data is always helpful. It should, of course, be data that is well controlled, so we really know where it comes from, etc., etc. But I mean, a comparison of our in vitro assays with in vivo is essential. My only reservation is that it's probably coming from animal models again, and we're interested in the human. So we need to think about the translatability of those data. But in the end, I mean, more data is better. Of course, we need the proper quality control, etc. But beyond that, I think it will always be helpful.
I think additional. Oh, go ahead.
Yeah, I agree. More data is better, but I think the usefulness of the omics data really relies on what we understand of the biology behind it. And animal omics data can be really useful for understanding mechanisms of toxicity that are perfectly human relevant. So in that sense, yes, more data, yes, please.
But I think I showed in my slides also epidemiology studies, and there's also a lot of omics work done, and I think this can also be the link to maybe the the rodent studies, or it can be the link to in vitro work, because the in vitro work, a lot of NAMs which are developed now are human cell-based NAMs. So this can be another link. I think we forgot that we have also epidemiology type of data, and there's a lot. HBM4U, for instance, they produce a lot of chemical measurement internal levels also. So there's something to win also to combine these fields.
Just to bounce back on the availability of data. Yeah, of course, more data is good. That's okay. Does it provide more knowledge and understanding? That's I think that's the fundamental question. Not having more data, but how we use the data, how we integrate it. Professor Prisma was talking earlier on the different elements in answering the question of David Bell about the different elements we could have. How we integrate them. It's not an easy question. I think we hinted to it, but we really need to say we might try to mimic the complexity of a whole organism. We don't succeed to do it now. So we need to say this clearly. It is a challenge. We need to say it clearly.
Very brief intervention, so we have time for a couple more questions.
Yeah, I would say I couldn't agree more, and this is really learning by doing. You know, we have a few proof of principle, as I indicated, on different levels, so it seems to work at those on those little areas, but we have to bridge it to the entire physiology, and that's a big challenge. I agree.
I'll give the floor, the word to the floor, and I would suggest that actually we reply just one or two members of the panel, so we just have the chance to have more topics brought to the discussion. Thank you.
Thank you. So Larry Higgins at Payment Consulting, and my question or comment really is to Harm, where he described his efforts to look at the mechanisms or to develop NAMs for carcinogenesis, and looking at the 300 odd studies, whatever, you identified a handful of mechanisms that are common amongst all of those studies, and for at least for the nuclear receptor mechanisms, so CAR, PXR, PPR alpha, etc. There is a pretty well-defined series of assays, or NAMs, we used to call them mechanistic toxicology assays, looking at those particular mechanisms and their human relevance. And these have been used widely in regulatory submissions for probably 20 years or so. So my comment really is we just need to be careful not to start reinventing the wheel if we have a set or a suite of assays that will address those concerns and the human relevance. They're already there, and including proliferation in hepatocytes.
Yeah, I agree with you that there are a number of assays out there and already for quite a while. But I think one of the things that is really yeah, well, that's not solving the issue is that we do not agree on the relevance of the different assays, and even though there are perfect arguments to agree that something is relevant, there are also counter arguments that are perfectly valuable. So I think we should sit around the table, regulators, industries, CROs, everyone who has an influence there, and decide on how do we define the relevance of these assays? How do we find human relevance of assays? And I think if I think about the literature of the past couple of years, there have been a couple of papers on this specific pathway, the CAR-PXR, and it's human relevance or not. And I think one of the things that comes to play there is that it's a matter of is it human relevant in a quantitative or a qualitative way, and that's also one of the questions that we should discuss. But so far, I think the discussion is really behind sandbags, so to say, and agreeing to disagree, but we're not coming any further. And I think given that there are NAMs out there, and given that there is so much experience with it, we should come to an agreement at a certain point.
Well, we have epidemiology data for greater than 100 years with phenobarbital, so we don't have any human-related tumors from exposure to phenobarbital.
Yeah, that's true. One compound. Sorry,
but it's that mechanism.
It seems we will have a very interesting discussion during the networking afterwards.
Thank you.
Before going back to the room, I'll just I would like still to give the floor once more to the people that are following us. We have been having consistently more than 300 people following us remotely, which I think I praise them to be able to stay so many hours in front of the screen. So Andrea.
Yes, we have a question for Kristin, among others. That's most voted. Excellent presentation and work. In your opinion,
Okay. Wim?
Yes. Hi. Wim de Koen, ECHA. Maybe too anonymous, I can start and then I can move to you, Kristin. No, I agree with the question. Excellent presentation. Great to see that you're working on chronic fish testing, because for us, this is definitely an issue. From a regulator's perspective, I can tell you that for us, the 234 is currently within the standard information requirements, a bit of the golden standard. And I would say, please don't take it away, right? 30 years ago, we had the first publication on endocrine disruptors in the environment. I think it took us 30 years to get finally, hopefully, something in the REACH regulation. It's a golden standard. Now, of course, it covers hatching, behavior, morphology, sexual development, etc. So question to you, I think you mentioned it already, Kristin, you talked about a virtual fish model. Your cell line seems to show growth. I think triazoles were mostly the substances you tested. How can we get there so it doesn't take another 30 years to get into a
Give me a lot
model?
of money.
Okay, yeah, I think I have to talk to
yeah.
other people. Yeah.
No, I think like what we really would like to do is establish this modular approach. And if we do this and we have more people dig in, we can be also much faster. If we work on a modular approach, which I think, we already heard about this from the mammalian field, we can sort of tackle individual responses in defined assays and then put it together. So when you say this assay covers hatch, growth, survival, okay, hatch, I would say we have not tackled this with cell lines. I'm not sure if it's possible, but survival and growth, I think we can do. And now we look into biomarkers also for reproductive toxicity. So, it's on the way, but it would, more resources, just in general, more resources to support this kind of work would be really good.
Yeah, I think even, from involving all the people around from the cross from you, I think, right? I'm sorry, you showed all the stakeholders. Maybe in a park context, it could be useful.
Yeah, we are also part of park. If I can just maybe add, because obviously everyone says, give me more money. I'm fully aware of this. But I would say that in the environmental field, we are underfunded compared to the human toxicology field. In comparison, if you take this really seriously, I think there must be more resources put into this. into alternatives for the environmental risk assessment.
Agree.
Thank you. We'll have time just for one more question. I'm really sorry. Please.
Hi, Knud Lagergaard Pedersen, Danish EPA. I'm also a national coordinator on the OECD test guideline program, so this is my home turf as well. First, Kristin, amen. That's how it is. But I would like to grasp what you said, Pim, in also about sending more money. And that's because this huge park program that we've seen on the screen today, 400 million euros. I know that last year, for the budget for park last year, Germany suggested that just a few percentages should be put aside and allocated to validation, because park is not. I have a lot of sympathy for academics, and your need for money, but park is not for supporting academics per se. It's for applied science to increase safety of chemicals. So and we don't get that until, as we've heard many times today, before it's actually a test guideline, which requires validation. And then in the coffee break, I just heard that actually now we have a unit inside park called validation, but unfunded. OECD has no money. It's only voluntary contributions from countries. So I mean, it's a no-brainer. We need to use some of the funding in park for validation if we want to speed up NAMs. And I have to phrase that as a question. So let's play Jeopardy. And who will tell the Commission and the guys in park that we need to allocate money for validation, so that you guys, your work, when it's ready, can be put to use, when it's ready, because this is a very, very important lesson we've heard that I hear many, many times. There are so many promising scientific results on NAMs. We will get there, but we're not there. And we have an obligation to tell the public very, very honestly that it's not tomorrow. We're not talking about 1 or 2 years. We're talking about 1 or 2 decades before we can replace NAMs. I see some of you nodding. We need you to tell the public, because this sad referendum in the EU Parliament where people suggest to ban animal testing. Somebody has told them that it is about tomorrow. It's
so
not. We have an obligation.
The question was made. I don't think anyone in the panel can answer to that question, but I think there are ears in this room that might hear the question. So thanks a lot for the question. Thank you very much for the presentations, the very interesting presentations. Very interesting to see all the work that actually is already happening and showing that actually it is possible, and already some ideas actually how we can actually speed up a bit the work that we all wish to move forward. Thank you once again. We still have a final salve of applause for our. We still have a last intervention from Dr. Rusty Thomas, that directs the Center for Computational Toxicology and Exposure at the U.S. Environmental Protection Agency. We have a video recorded presentation from him, but he is following us already online, and we'll still have the chance to make some questions to him live. So I hope that you can bear with me. We are already even further late with our schedule, but again, the only thing that prevents us is from going out for networking a bit more. So I'll hope that our colleagues, yes.
Greetings, fellow workshop participants. I'm Rusty Thomas, and I'm the director for the Center for Computational Toxicology and Exposure at US EPA. I apologize for not being able to join you there in person. Looks to be a great meeting, and I wish I could have participated in many of the important discussions you are having. I want to thank the conference organizers for giving me the opportunity to speak. I was asked by them to talk rather ambitiously about moving past measuring adversity in an intact organism. In thinking about the topic, I decided to frame the discussion presentation in the context of a journey, our journey towards a NAM-based toxicity testing and chemical assessment approach. Although this is pre-recorded, I will be connecting later for questions we may have. Although we're going on this journey together, we're not necessarily starting from the same spot. We have different regulatory frameworks, we're part of different organizations, and we may be interested in the topic of NAMs for different reasons. However, I would pose that we're all in the same general vicinity in our starting point, and that we still largely rely on measures of adversity in an intact organism to evaluate chemical hazard and assess risks. Moving past adversity in an intact organism implies that we don't want to stay where we are. So, as the Hobbit says in Lord of the Rings, we're going on an adventure. The first thing one needs to usually do to figure out when they're going on a journey is what direction we want to go, and it usually helps to know what things will look like when we get there. If we don't know which direction to go, it is likely to take much longer to get to our destination, and if we don't know what it looks like when we get there, you may pass the destination and never realize it. In the context of NAMs and evaluating chemical hazard, the direction we are traveling is to determine whether our test models need to be protective or predictive of human health and what level of protection or prediction is required. Our expectations in terms of the destination are determined to some extent by our current models and test systems. There are a number of published and ongoing studies that suggest our current models in environmental toxicology, namely rodents, serve as protective rather than predictive of human toxicity. On the left-hand side, you will see one of the multiple studies done in the pharmaceutical industry that qualitatively compare toxicological results from preclinical animal studies with those from early phase clinical trials. I bolded one key takeaway from the abstract of the study. The authors note that while the positive predictive value was high for certain species and organ effects, the negative predictive value was much stronger across species and target organs, suggesting that the absence of toxicity in animal studies is a better predictor of similar outcome in humans. Other studies support this conclusion as well. This suggests that our current models serve more of a protective role in qualitatively evaluating hazard rather than predicting what specific hazards we should be concerned about in humans. On the right-hand side are preliminary results from a recently initiated intergovernmental case study under the Accelerating the Pace of Chemical Risk Assessment, or APCRA, where we're collaborating with ECHA and others to determine the quantitative concordance of rodent and human toxicological responses from preclinical and clinical pharmaceutical studies. The scatter plot shows the concordance of the 5th percentiles of low observable adverse effect levels and low effect levels for toxicological responses, regardless of whether the adverse responses were the same. The quantitative concordance showed an R-squared of around 0.3 with a root mean squared deviation, meaning the variability of the residuals of close to a full log unit. The bar graph on the right shows the R-squared for dose concordance for adverse responses matched at the organ level. The dashed line is the R-squared for the non-matched endpoints. As you can see, the concordance doesn't improve when the responses are matched versus the unmatched results, and in many cases, the matched results are lower. This supports the notion that our current animal models are generally protective and not necessarily predictive of human hazards, either qualitatively or quantitatively. If we can accept that our rodent models are largely protective and not predictive of human responses, then it follows that they predominantly function as test models for in vivo biological activity for the chemicals we evaluate. This provides us with a promising path forward for how we develop and apply our new approach methods. On this slide, there are two case studies that probably many of you have seen where we evaluate the utility of in vitro biological activity as a protective point of departure for chemicals. On the left-hand side is a case study performed under the Intergovernmental APCRA Consortium. This case study compared the points of departure for approximately 400 chemicals associated with the lower 5th percentile from an in vitro responses across a battery of primarily target-based assays, with adverse responses from traditional in vivo toxicity model. The results showed that for about 90% of the chemicals, the point of departure from in vitro bioactivity was protective. The 10% that were not protective were generally pesticides with an acute neurotoxicity response, which the in vitro battery did not cover to an adequate degree. We have an ongoing case study in APCRA that is also looking at this question in a prospective manner. On the right-hand side is another case study that compared the lower 5th percentile from in vitro responses, but this time from more broader coverage, high-content imaging assays, evaluating morphological changes in one or more cell types. The results showed that bioactivity measured using these profiling approaches provided similar but slightly lower levels of protection as a ToxCast assay battery. Use of other broad coverage profiling approaches, such as transcriptomics, also demonstrate that they provide similar levels of protection. The bottom line from these case studies suggests that in vitro bioactivity generally provides similar or greater levels of protection compared to our current in vivo models. Remember that specific hazards identified in our animal models generally aren't predictive of human responses, and that the quantitative concordance of the in vivo models is generally plus or minus tenfold. In addition to establishing the predictive versus protective capabilities of our current animal models, we also need to characterize the variability of our test systems in order to adequately set expectations. If you remember my analogy, how do we know how good we need to be if we don't understand how good our current models are? While I understand that from a scientific perspective that we want highly reproducible models, regardless of whether they are in animals or in vitro, we also need to be realistic and not necessarily hold our NAMs to a higher standard than what we hold our current approaches. This is a challenge since we typically don't repeat these studies multiple times due to cost and time requirements. On this slide are a couple of studies that have been undertaken at EPA that attempt to do this. Katie Paul Friedman and colleagues have been using a highly curated database of legacy guideline and guideline-like toxicity studies called ToxRefDB. ToxRefDB contains nearly 6,000 studies on over 1,000 chemicals. Katie has been analyzing these data in different ways to get at the questions of quantitative and qualitative variability. Although there are limited examples where higher tier toxicity studies are repeated under exact conditions, such as dose, route, strain, etc., one can look at those that are repeated or repeated under similar parameters to ask these questions. On the left, Katie and colleagues analyze the reproducibility of low AL values using study parameters such as route, strain, etc. as covariates. While in another approach, they filtered the data down and looked at reproducibility in these low AL values only in those highly similar study designs. Katie also broke out subchronic from chronic studies to see if study duration had an impact. The take-home message is that no matter how they analyze the data or the duration of the studies, the quantitative variability was generally within a root mean squared error of between 0.4 and 0.6. What does this mean? Well, using a root mean squared error of approximately 0.6, the 95th prediction interval of a low AL value is plus or minus tenfold. On the right-hand side, Katie and colleagues evaluated the qualitative concordance of target organ effects while breaking down this concordance based on sample size, study type, species, and target organ. The qualitative concordance ranged from 40 to 80% and generally within 60 to 7% concordance. This means that if you ran a study and saw a specific target organ toxicity for a chemical, such as liver or kidney effects, and someone else repeated that study, they would only see the same effect maybe roughly 70% of the time. This qualitative reproducibility is similar to those observed for other endpoints, such as uterotrophic studies and skin sensitization studies. Okay, so on our journey, we generally know where we want to go and what things we should look like from a performance perspective when we get there. But how we get there and what route we take can depend a lot on the landscape we need to navigate. While there may be multiple dimensions to the landscape in terms of the chemical proportion of the landscape, it is important, in my view, to understand that the most environmental and industrial chemicals interact with biological systems in a non-selective manner. In other words, they are very promiscuous in the biological process and targets they perturb. The cumulative distribution plot on the left-hand side is one way to look at this principle. The data are the industrial and environmental chemicals in the ToxCast library evaluated across a broad suite of ToxCast assays. The x-axis is the concentration to activate the first assay divided by the concentration to activate 10% of the assays. For most chemicals, there's a less than a threefold difference between the two. The lesson here is that no matter how good your technology or how advanced the science, expecting to identify a primary mechanism for a non-selective chemical is probably impractical or infeasible. In addition, it also means that this chemical likely perturbs multiple biological processes and pathways in multiple different organs and tissues at or around the same dose, which would support the use of bioactivity as a good protective surrogate for potential adverse effects. This is not entirely new concept and is similar to accepted methods to classify chemical modes of action in ecotoxicology between specific acting and non-specific acting, i.e. narcosis type classes. Understanding that many industrial and environmental chemicals promiscuously act with biological system only gets you so far. It is important to also incorporate this concept into whatever toxicity testing and assessment paradigm is being developed. I believe that this is being done in slightly different ways in many of the next generation risk assessment paradigms that have been published either from EPA or others in the cosmetic sector. The left-hand flowchart is a generic representation of the many testing paradigms that have been or are being proposed. In many cases, a combination of broad coverage technologies or methods, such as omics or phenotypic profiling in multiple different cell types, is being combined with target-specific technologies and models. The different technologies are being integrated into an assessment and testing approach to first determine whether a chemical appears to be selective for a particular biological target or acts relatively non-selectively. Given the results from that integrated assessment determines whether a bioactivity-based point of departure is appropriate or whether a specific AOP or mode of action-based point of departure should be used in the assessment. Apart from aligning the toxicity testing and assessment process with chemical selectivity, we also need to change how we define and rely upon hazard. For these non-selective chemicals, where there would be relying upon integrated bioactivity to set a point of departure, we will need to accept that we're not defining or linking to a specific hazard or ICID. Rather, by the very nature of the response, these would be protective. Keep in mind that our current animal-based testing assessment approach is very similar in that we typically select the most sensitive endpoint that is considered adverse across a range of different studies and use that to derive a reference dose or derive no effect level. This is especially true if the endpoints we select have minimal qualitative or quantitative concordance in human responses. For those selective chemicals, we can define specific adverse outcome pathways or modes of action that lead to specific hazards in a predictive manner and set safe exposure levels based on those responses. So the type of testing and assessment are matched with the biological selectivity of the chemical. The next aspect of the analogy is that this is probably not going to happen overnight. It is unlikely we will set a deadline of midnight January 1st, 2035 and say on that date, we're going to all switch to this new way of testing and assessment. We will need to take detours and take smaller steps until new roads and bridges are built. Change is hard, especially when public health and large economies are at stake. So what kind of detours are we talking about? I think that there will be different types of detours, but one example is a new human health assessment product being proposed by EPA. This new human health assessment product would rely on transcriptomic-based points of departure from short-term in vivo studies, and that this transcriptomic-based point of departure would be the basis for deriving chronic reference doses. Why this detour? Well, for several reasons. First, it proposes to rely on general biological activity as measured by transcriptomic changes as the basis for the point of departure, with no linkage to specific adverse effects or hazards. Second, it's proposing to use short-term molecular changes to derive chronic reference values. As you know, many of our new approach methods are not exposed for 10, 20, 30 years in order to see adverse effects develop. We're going to be extrapolating our potential effects into the future. And third, the analysis underlying this proposal incorporates some of the variability analysis that we discussed earlier in the presentation and uses that to set expectations for how good short-term in vivo studies need to be. While this may be viewed as a detour, I believe it puts in place many of the essential components that will be necessary to move past adversity in an intact organism and towards a truly NAM-based testing and assessment process. Given the diversity in the regulatory frameworks around the world, we also need to appreciate that the route from point A to point B may not be the same for everyone. That there may be multiple routes, even if one is a bit longer in order to provide the type of information to make a decision. This could include different testing batteries, different ways to integrate the data, and other things. In my view, these different methods and approaches are going to require a more flexible process for validating and building scientific confidence in many cases. They should also be performance-based. This is not incompatible with the existing OECD guidance, GD34, which states that the process should be flexible and adaptable, and that performance should be demonstrated with appropriate reference chemicals and the relation to relevant toxicity data. However, we have not always chosen to allow this flexibility in our validation processes. To evolve the process, different expert bodies and organizations have been proposing a shift to a more fit-for-purpose and performance-based process. In his 2017 report on using 21st century science to improve risk evaluations, the U.S. National Academies of Sciences emphasized importance in defining purpose and scope of the NAM. They recognize challenges in validating NAM where there is no gold standard, or against assays that themselves have not been validated. They also suggested that establishing performance standards for data quality and recognize that ring trial design is not necessary for all purposes. They finally emphasize the need for reporting standards and for greater transparency. Finally, the publication on the right-hand side builds on those concepts and evolves them further to put forth a general framework for establishing scientific confidence in these emerging scientific methods. You can see the main components of this framework include a fit-for-purpose, technical characterization, biological relevance, independent review, and data integrity and transparency. These are all the same components that were emphasized in the 21st century science for risk-related evaluations evaluated by the NAS committee. Lastly, one of the things that may happen when we arrive at our destination, whenever that may be, is that the view from that new location may not be that conceptually different from the way it is now. On the left-hand side is a general representation of our current in vivo testing paradigm. If you accept the qualitative and quantitative concordance of the preclinical to clinical toxicity studies at face value, you can say that many of the broad coverage toxicity tests that use apical endpoints as the definition of hazard are generally protective, while the mechanism-specific tests, i.e. those that are designed to specifically evaluate particular mechanisms, such as receptor-based activation or pathway inhibition, if they are human relevant, using an AOP or MOA framework can be predictive. On the right-hand side is that parallel paradigm for using new and emerging science and new approach methods. You can see that when they're integrated in the appropriate ways, you can achieve the same general testing and assessment goals for human protection for non-selective chemicals and prediction of potential adverse effects for specific acting chemicals. Since I began with a quote of The Lord of the Rings, I will end with one as well. You step into the road, and if you don't keep your feet, there's never knowing where you might be swept off to. I want to thank you for listening. As you know, it takes a lot of effort from a lot of individuals to change the way we are doing toxicity testing. There are many colleagues from the Center for Computational Toxicology and Exposure that are working hard to make that change possible. In addition, we have colleagues from U.S. federal agencies that are part of TOC21, as well as collaborative partners, including Unilever, A-Star from Singapore, the JRC, ECHA, EFSA, Health Canada, and many others. Thank you for your attention. Thank you for your attention.
Thank you. Thank you, Rusty. He should be joining us at any moment. And we will open the floor if you have any. Here you are. Good morning.
Good morning, or good afternoon over there.
Good afternoon to us. And we already have someone in the floor to have a question for you, Rusty. Thank you very much for your presentation and for all the detail that you have provided us. Please.
Thank you, Rusty. Great talk. Matt Dent from Unilever. I very much like the distinction between the selective and the non-selective selectively acting chemicals. And we've heard a lot this afternoon about some of the challenges with the more selectively acting chemicals and some of the gaps that exist in terms of being able to do a more AOP-based approach for some of those endpoints. How close do you think we are to being able to make safety decisions for the non-selectively acting chemicals? And what do you think is stopping us?
Thanks, Matt, for the question. Well, I think if you're talking about general bioactivity in vitro or in vivo, as sort of I pointed out on one of my detours, I guess we'll find out in a month or two how close we are to being able to use general bioactivity using short-term in vivo studies to set sort of DNL type or RFD-like type levels. I think this is a first step. And then I think hopefully we'll learn some lessons from that. And in the not too distant future, we'll be able to make the leap to more in vitro bioactivity to set some of those points of departure and toxicity values for chemicals as well. So ask me in a month, Matt, and I'll tell you how it went.
So you're not talking 40 years then?
Well, I hope not, because then I'll be retired by then. You may be as well, Matt. So, but I don't think realistically that if we make the leap to sort of general bioactivity and we are all on the same page in terms of what it can and can't tell you in terms of protective versus predictive, then I don't think it's necessarily a 4-year or 40-year time horizon. I think it could be sooner, but I think we need to have some additional discussions and come to our water in terms of what our current in vivo models tell us. And in my view, many of those are sort of in vivo biosensors anyways. And then we need to then sort of make the leap in terms of what that means for our new approach methods as well.
Thanks.
Thank you. Yep. Andrea, do we still have anyone posting in Slido?
Yes, we got to the question number 141 of the day, and this for Rusty. Great talk. Can you give some perspective from US EPA willingness to accept that the NGRA-based approaches means some chemicals, e.g. those regulated based on bioactivity alone, may not be classified for specific hazards? How is this viewed within OSHA remit to enforce GHS?
Well, it's a fair question, at least in terms of the. Are you talking about bioactivity from these short-term in vivo models coming this summer, or are you talking about general bioactivity going forward and how we're trying to align some of our in vitro bioactivity with, the classification requirements? So I just need to have some clarification there. Both. Yeah. Well, I guess part of that is I don't think we are quite as certainly we have some of those classification requirements in OSHA, but there are other decisions that the agency I work for, EPA, works for, where we don't necessarily rely on classification for those decisions. And I think what we're trying to do, at least initially, is use bioactivity and either the in vivo bioactivity as well as some of the work we're doing in collaboration with our toxics office, in vitro bioactivity, to make some of the decisions that don't necessarily rely on classification and labeling for those decisions. So things like this point of departure and derivation of a toxicity value for that. So not all of our decisions need or require or feed into classification and labeling. And I think that's where our initial opportunities lie, at least here in the US.
Thank you, Rusty. Before we conclude the day, I have a final question for you, actually, Rusty. And reflecting a bit on this, the challenge of replacing animal testing, what do you see that it would be useful, actually, to accelerate the progress? What would be useful incentives and goals to help us move forward, hopefully faster than we have seen over the last?
Actually, I was listening in on some of the discussion that occurred on the panel and earlier in the day, and sort of I heard some of the discussion surrounding that, and I think I was reflecting on that too in terms of what would be useful incentives, and I think that pragmatically it's going to be very inherently difficult, if not impossible, to make sort of an abrupt transition to sort of NAMs and to regulate chemical safety. I think there's, like, even within a single regulatory jurisdiction, let alone internationally, right? So in reflecting more on this, I thought one incentive that the community may want to consider maybe is for a period of time, say 3-5 years or whatnot, to incentivize as well as require registrants to submit both NAM-based data and traditional data in parallel. Right, and that way there's sort of a transition towards a new paradigm, right? That we're able to sort of fine-tune the NAM-based frameworks over the period of time, as well as build confidence in the approaches and potentially allay whatever concerns there are on the part of stakeholders. So it's sort of a parallel sort of track, at least for a short period of time where we begin to make that transition, and part of that is incentivizing then the stakeholders and the registrants to submit that sort of data, either sort of augmenting and providing some sort of additional funds to do that, as well as the resources that the regulatory agencies need to do to evaluate that. So I think it would be a useful sort of transition. So that was one of the incentives, at least, that came to mind.
Okay. Thank you very much, Rusty, for your answer. We are arriving to the end of the day. I would like to thank you all for staying with us here in the room, but also online. Some practicalities. We'll have now a reception until 7:30. You're most welcome to stay until the end. We all need to leave the building by 8 p.m. please. Please keep your badges visible at all times, and in the end of the day you should return your badge, and tomorrow morning you'll repeat the procedure that you did this morning. For all of those following us remotely, I hope you also had a great day, and I hope to see you tomorrow at 9 a.m. Helsinki time, Eastern European time, and you can use the same stream link to connect. So thank you once again, and hope to talk to you later. Thank you.
Bye.